Hi everyone, I'm Layla. I'm at Overture. I'm based in New York. We're pretty dispersed in the US. We're in LA, SF, DC, and New York. We do 1 to 3 million checks in energy, industrial transformation, and climate resilience. And our focus is that we help on everything regarding the government. So we partner with 3 lobby firms, and when we invest, they extend their services in kind to the startups that we invest in. Very excited to be here.
Thank you. Hi, everyone. I'm Julia Travellini. I'm the head of Greentown Boston. I'm very proud to welcome you to our space today. It's an honor to host you today, so thanks for the opportunity. We are the largest climate and energy startup incubator in the world. We have our kind of flagship location here in Boston that was founded 15 years ago, and we opened an incubator in Houston, Texas as well 5 years ago. We're home to about 275 startups working in climate and energy. We've supported more than 700 since our founding, many of which have come through this program. So we are very proudly home to many of the finalists, and alumni of Greentown were many of the finalists as well. So if you're interested in learning more about what Greentown does to support startups as you grow and scale from the earliest stages of TRL all the way up to market readiness and commercialization, come see us afterwards. Good luck today. Thanks.
Thank you. Hi, Dave Miller, Clean Energy Ventures. I love doing these competitions. Teams are always great, people are always great. I think I'm in probably double digits to the amount of times I've done this. It's always fantastic. So Clean Energy Ventures, so Boston-based, but we invest across North America and Europe and have a spread out team. Often first institutional check, from seed through maybe a late Series A. And our, one of our defining metrics is we look for companies that are going to have a multi-gigaton emission reduction potential over the next 3 decades. So it's a very, very high filter, enables us to focus on the most impactful climate tech companies. And looking forward to seeing some of them today.
And one more big thank you to Greentown Labs. As Julia mentioned, Greentown is actually a host to several of our alumni and is a huge part of accelerating the Boston and the Houston community in climate and energy startups. So thank you for letting us use your space. The last thing I'll say is my co-heads, Danny and Michelle, and I, at the start of this year, laid out 3 goals for the prize. The prize has been around for 18 years. This was the impact that we wanted to have. We wanted to increase our applicant pool to over 200 applicants. We wanted to expand our global presence, particularly in Asia. And we wanted to refresh our branding. And as you can see from Michelle's beautiful new logos, fortunately, we've accomplished all 3 of these. But we couldn't have done that without our amazing student team. This is a student prize run entirely by students. And our team really volunteers their time in their busy schedules as they're getting their MBAs and their PhDs and all of their other degrees because they care deeply about this longstanding global community of entrepreneurs. So thank you again to the team. And now I will hand it over to Lars. Lars, oh, sorry. Lars is the Managing Director of Climate and Circular Economy at TUM Venture Labs, and as we've mentioned, this is our 2nd year running partnering with TUM in our Munich semifinal, and so please give a big round of applause to Lars.
Thank you, May. Thank you, everyone, for hosting me and my 2 colleagues, Anna and Anna. It's easy for you to remember from the Munich ecosystem. So, everyone, are you excited? Yes. Great. Startup teams, are you excited? Are you nervous? Yeah. So I think the first thing is a big congrats for those teams who made it here. A big applause to give them the power to pitch. For us, it's now the 2nd time, and the cooperation with the MIT, especially around the climate energy ventures, is still a bit longer. And I can say we're really happy to be part of this game and to support this game. And in just my short keynote, I will also say why this matters and a bit about us. Why this matters, I think it's obvious. We have a climate crisis, but that's not all. We also have an energy crisis, and more or less, we also have a food security crisis. So we need you. We need those talents to work on innovation. We need those talents from a global perspective to understand the The necessity of the local markets, the necessity to do something of the local problems, but also the ability to globally collaborate, to globally learn from each other, and to build global networks. What I've seen and I observed yesterday evening already, many of you know each other from the semi-finals, from earlier pitch. You already connect, you network. The price is great. The price is not everything. In the end, the business model also matters. To understand the customer, take those opportunities, learn it, and use it. It will help us on those challenges. A bit about us. So we are from the Technical University of Munich, and also happy during the day if you have any questions to ask us. I think it's always two things. You have to do your own homework, and you have to do your own stuff. So we on our side try in Munich with the TUM, but also with other universities, with like the LMU, Max Planck, Helmholtz, and whatever you have there, to really boost from spin-off to scalable ventures and to support teams with this as a non-profit organization in different domains, really to have the chance to bring research out of the lab to great spin-offs. But you need it also on a collaboration point, like a hub point. And I think maybe MIT is one of the strongest hubs in the world for this, or the whole Boston area. We have a bit of similar view on this for Munich as well. So then we said, okay, let's do something for energy storage. And the Ministry of Science was so nice to support us to do a German-wide battery incubator where we pushed the battery thing. And it's still a big question mark. Is battery only a Chinese game? Or what is the role of the Western world on pushing it, to look onto it? Then we said, okay, do more. How can we connect our forces? We're collaborating with the ETH in Zurich and the Technical University of Vienna on energy, especially in the field of energy resilience. Similar like in the US, the European grid is quite old, and you have climate, extreme weather scenarios, how you deal with this. On the other side, how do you handle quantum AI and energy? And then we go further, like Imperial College, for example, the chances they have the global network. I know Breakthrough is also part of it, to bring those players together. And then if you go even worldwide, like with institutions, MIT, Stanford, and others around the globe, to bring great minds together and bring things forward. And also the view to Asia. We have many people from Singapore here. We are a bit closer with the NUS and NTU, but the whole ecosystem, I think, bring people together and get things done. That's great. And this is also my advice for you for today. It's not only the winner takes it all. It's more use this for connecting and pushing things forward. And I can all encourage you. The one thing is, it's a bit the tendency, especially we Germans have, that we might be too much in love with our product or too much in love with our solution and forgetting the market and the problem. I think it's both. We're all addicted to tech, so it is the product, but on the other side is also understanding the markets, and therefore many, many thanks to the Greentown Lab for hosting us here today. Many, many thanks for this fantastic team around the Climate Energy Prize as students. They are students, and they're not professionals. They do it in their part-time to make something like this possible, and we're really grateful to be part of it, and we're looking for great pitches today, and fingers crossed, you will all make a great show. Thank you.
Thank you, Lars. So without further ado, our agenda for the day, which I think we're already a little bit behind, but it's okay, we built in buffer time. So we're going to lead right into our startup pitches and have 4 rounds of startup pitches, followed by a keynote by the wonderful professor from MIT, Katherine Wolfram. We'll have a little break, do another set of startup pitches, lunch, and then we'll move on to our last round of startups before we have a panel from a few Greentown companies while our judges are deliberating. So looking forward to the day. And without further ado, the first startup up will be Albon. So please come up to the stage. And just a few other notes, we're going to have Kayla, one of our team members, will be sitting up in this front row. She's right here. Kayla, do you want to raise your hand? She's going to have the timer going so you guys can see how long you've had. And judges, if you don't mind coming up to this front table too. Thank you.
Rivers are the veins of our planet. They feed communities, cultures, and ecosystems. But today, we're poisoning this lifeblood. Around the world, agricultural wastewater is poisoning our waterways. And the result of this is explosive toxic algal blooms that choke our rivers, block out sunlight, and trigger cascading ecosystem collapse. Now, this isn't just a local problem back in Australia. This is a global environmental and economic crisis, and it's accelerating as regulations tighten. Last year, there were up to $15 billion in energy costs from mistreated wastewater, over $260 billion in economic losses caused from mistreated wastewater, and 800 million tons of carbon dioxide emitted from mistreated wastewater. Now, agri-food facilities, whilst they're only a smaller portion of this much larger problem, facilities are spending up to the millions of dollars every year to treat their wastewater. They're spending hundreds of thousands on chemical and energy. They're spending in the millions for sludge disposal, and they're facing mounting fines as regulations tighten. Now, all up, for a large processor, these fees exceed well over $2 million every single year in just OpEx alone, and they're not even fixing the underlying problem. We clearly need a better solution. And Albon's turning wastewater and sludge into compliance and value with an engineered algae and bacteria system. So, how does this work? Well, current treatment leaves behind 3 expensive and polluting problems: carbon dioxide, nutrient-rich wastewater, and sludge. Albon's solar-powered plug-and-play system feeds on this waste. Our system is able to strip nitrogen and phosphorus from the wastewater, making the water completely regulatory compliant. The water is now good to be discharged or can actually be reused on site for washdown. We then combine our harvested algae with sludge, which is the waste product from the facility, and we turn it into a biochar fertilizer, which is a nutrient-rich and stable form of carbon. So now I'm sure you're asking, why hasn't this been done before, and why is it difficult to do? Well, Albon is hard to replicate on 3 main levels: hardware, process, and data. So Albon has a patent-pending novel reactor geometry, and this allows us to achieve enhanced removal rates and combine algae and bacteria in the same system. So methane is already a waste product that's on an agri-food site produced from anaerobic digestion. Albon's taking the next step in redirecting a portion of this methane and using that as the fuel source for our pyrolysis kilns. The pyrolysis kilns produce a lot of heat, which we capture and use to help dry the sludge and the algae biomass that we have on site. And then the resulting CO2 from this is re-injected back into our photobioreactors to cleanse that gas, making it a net negative process. And then every deployment that we make generates us data. And we are building a machine learning model to help manage all of these data inputs, meaning that we get a compounding competitive advantage with every deployment. As you can see, we have here our client dashboard, and we have an AI diagnostic tool that the customer can interact with. So they can troubleshoot their system and see what's wrong with Albon's system here. They can also turn on their pumps. They can control the system remotely. So making this as easy for the customer to use as possible. So we're starting by selling these modular treatment units to meat and dairy facilities. And that is because they are the worst affected by this wastewater crisis, and they need a cost-effective solution. And then with the biochar we generate, we're selling that to soil and fertilizer blend partners, as well as to farmers. So we sell our modules for $150,000 each. And that can be paid upfront, or it can be financed. And then we also then charge facilities an ongoing servicing and sludge fee, which starts at $100,000 for a very small facility and goes all the way up to $800,000 for a large facility. And then with the biochar we generate, that is sold for $2,000 a ton to our offtake partners. And the great thing here is that the feedstock is completely free because we're using waste products that they're currently paying up to 1.2 mil to get rid of. So looking back to that earlier scenario, where we have a large facility paying $2 million every single year in OpEx, what does it look like with an Albon finance deployment at their facility? Well, that facility would see an immediate reduction by up to 33% across the board in their chemical and energy spend, in their sludge disposal costs, and they have no more regulatory compliance issues or events, which for the operators, that is their #1 KPI. They don't want any issues with the regulators. So we started in my backyard just over 2 years ago with a very, very scrappy proof of concept system, completely bootstrapped and built from hardware parts. And we managed to double algal density within a week. And since then, we upscaled to a local council pilot in partnership with one of the councils in Sydney. And here we were able to reduce pond algal blooms over the testing period, and the council also saw a reduction in nitrogen, phosphorus, and ammonia over the testing period. And this success has now led to our first letter of intent which we will now be running a paid pilot at a dairy facility later this year. And in addition to this, we've also now received an additional 4 letters of intent from other meat and dairy facilities in our home state. So we're making cutting edge progress in the lab, and we're actually bringing this to industry, and we have the industry partners to show this. So this is our roadmap. At the moment now we're deep into R&D, so the next year will be R&D at the dairy facility, and we'll be also starting a meat facility pilot. And we'll be raising a pre-seed at the end of this year to help fund this. Off the back of a seed raise in 2028, we're going to commercialize the technology and scale to multiple facilities with these case studies to show for it. And we expect to hit quarterly revenues of $12 million by Q4 of 2030. So one thing that we've learned from talking to all of these different customers is that Albon's module needs to integrate with what they already have on site. So Albon is built to integrate alongside the existing infrastructure, and we can reduce the chemical, energy, and sludge disposal across their entire wastewater infrastructure chain. So you can see here a demonstration of what Albon's system might look like at a medium or large-size processor. And on the top right here, you see a wastewater lagoon, which is what they're currently using to treat the wastewater. And these lagoons can only remove 50% of nitrogen and 35% of phosphorus. With chemicals added to that, you get up to 85% phosphorus reduction. But in a lot of cases, this isn't good enough for regulatory compliance. With an Albon system, they could see up to 95% of nitrogen removal and over 90% of phosphorus reduction, which is significantly better than what they're currently using. So we're starting with the Australian agri-food wastewater market, and that's because we have personal connections to these farmers that need more cost-effective and better solutions. Then we're going to expand into the US before eventually going global. But at Albon, we're more ambitious than this. We want to eventually expand into the global waste and wastewater market for a market opportunity of $713 billion US. And at just 1% of this global market, Albon could clean over 3.6 trillion litres of wastewater every single year, protecting hundreds of thousands of rivers globally from devastating algae blooms that are caused by nutrient pollution. And with that same level of impact, we could capture more than 10.8 million tons of carbon dioxide, which is the same as planting 514 million trees. And we have the right team to deliver this level of real-world impact. John, my co-founder, has previously worked in aquaculture, managing over 200,000 litres of bioreactors. I lead venture scale-up. I've previously had accounting roles and early-stage venture scale-up roles, and have studied at Wharton and the University of Sydney. And last year, John and I met Andrea, and she's now our co-founder and CTO. She quit her full-time job as a consultant to build Albon with us full-time. And she has worked for over 17 years in the wastewater industry as a senior engineer and has a PhD in algae and wastewater separation. Jennifer is our principal engineer, and she has previously worked at the largest wastewater treatment facility in the northeastern United States. Dr. Xiaoxi Wu is a photobioreactor expert. He actually previously worked on a $70 million algae biotech spin-out from MIT back in 2004 to 2008. And Dr. James Joyce is a pyrolysis expert, and he helped commission the first continuous sludge-to-biochar facility in Australia. So to date, we've raised $130,000 US. At the moment, we are raising an additional $200,000 to help to fund our dairy facility pilot later this year. And with the MIT Climate Energy Prize money, the great thing is that with the $100,000, we can match that dollar for dollar with the Australian government's money, and we can also then loop all the 130K we have and match all that with the Australian government's money to get around $400,000 to be able to run this pilot. And this pilot is going to generate us the operating data that we need to scale this to multiple facilities across Australia and then eventually to the US. So this pilot study is going to be critical for us to acquire additional customers. To date, we've had a lot of industry recognition for our innovation. We've been backed by leading accelerators globally, such as the Holt Prize Accelerator last year in London, and we've received a lot of awards as well, such as the New South Wales Australian Water Awards, and also winning the New South Wales Business Awards. Please join Albon in capturing change for our rivers and our farmers, but most importantly, for our future. Thank you.
All right. Great presentation.
Thank you.
Way to start this off. So 2 questions. to what degree do your pilots reflect the pricing in your business model? And two, can you talk a little bit, you talked about what you're charging, talk a little bit more about your costs and what your resulting margins will be.
Yeah, great question, thank you. So we actually have a slide on this. So here you can see the margins that we expect. At a pilot site, the margin is lower. So the modeling that we've done in the slide is based at a degree of scale. So around like 2029 and onwards. Early on, yeah, we do expect that we'll incur more costs, which is inevitable. But that's not a bad thing as well. So the figures on the slides are at scale, to answer your question, and you can see here the margins.
How hard is it for your customers to afford these modules? Like, can they pay 1.2 million for a medium site today?
Yeah, so great question as well. So they wouldn't be paying up. The pitch to them is they're not paying up front. So they would definitely get an equipment financing loan. So they'll pay back to the bank over 7 years. They pay Albon up front because they've gotten the loan from the bank. Then they repay the bank back over time. And the amount that they're paying back the bank, here we have is 452,000, which is significantly less than they're currently paying, which is 700,000. So they have immediate savings versus what they're currently paying.
How hard is it to make an incremental sale here? And like, how many wastewater facilities are around? Like, what does it look like to scale and sell this?
Yeah, so there's around 200 meat and dairies in our state in Australia. And then a lot of them are located in our state, but yeah, across Australia around like 300, 400. So assuming, the good thing about Albon is that we can sell to any facility at any given time. So all of those like 400 facilities or so facilities in Australia, we can sell to all of them because they all have chemical and energy and sludge disposal costs. Whereas if we were selling to new facilities or facilities that are trying to upgrade their full wastewater infrastructure stack, that might be only 5% of facilities. So we can sell to all of the agri-food facilities in Australia. And beyond meat and dairy, we can be selling to beverage, wineries, feedlots, aquaculture. There's a lot of other markets. Eventually mining wastewater as well we're looking at, and also municipal. And then of course, yeah, in the US there's even more.
Yeah, and a lot of these facilities are governed by 10-year permits on what their current effluent limits are looking like. So they're forced to actually reevaluate this when they're about 2 to 3 years out from that limit or that permit expiring.
You mentioned that your first pilot is with a dairy customer and then you're thinking of going into meat. How much do you need to adapt your product to be able to address the needs of these different types of industries?
Yeah, so we actually see a little bit of difference in the sort of the total organic carbon and some of the nitrogen phosphorus levels. Funnily enough, the higher it is in the wastewaters, actually, the better it is for us. So in the case of dealing with abattoirs for their wastewater loads, that higher nitrogen and phosphorus actually is much better for our biomass output to then create further on biochar. So not a lot has to actually change in the technology. What does change is how many modules we might have to deploy from site to site, as well as hydraulic retention time from system to system.
And how did you find your first pilot customer, the dairy one?
Yes, that was a warm intro. We've met a lot of them at various industry events. We've had a lot of successes actually doing cold emails, funnily enough, which is always advised against, but initially we didn't have much other choice. So we did cold emails, it was sort of a researchy email, trying to understand their customer pain points, and then we converted off the back of that.
And I guess 2 questions. How dependent is your business model on the sale of biochar? And then for both of those markets, for the sale to the, like the sale of the box basically, and then the sale of the biochar, what are the risks with the customer adopting the technology or the product?
Yep, so I'll answer those in like 2 separate parts. First part about the dependence on the biochar revenue. So the split between the wastewater and sludge versus biochar is about 80% to 20%. So we can still be profitable without the biochar, obviously much less profitable, and it is pushed back a bit. Let's say there's a scenario where it's very difficult to get farmers to buy the biochar, which we don't see happening, but there is still a lot of potential for biochar in other industries like cement and whatnot, and building materials, so we could easily just sell it in there. The reason that biochar, though, is essential for us is because we generate all this algae, we need to do something with the algae, because if we don't do something with the algae, it is then just another waste product. So yeah, it is essential we turn it into the biochar. And then in terms of adoption risks, algae-based biochar is actually, it is one of the best biochars on the market because of the amount of nutrients that we have in the biochar. So you can see here that, the levels of nitrogen and phosphorus, which are the 2 main elements that farmers really care about is significantly higher in an algae-based biochar than other biochars.
And then on the wastewater operator side, risk that they look at is primarily downtime. They need to minimize that as much as possible, otherwise they don't have anywhere to put their wastewater. To minimize that in a biological system, we use the machine learning algorithm to take that process out of the hands of the operators, where there's typically quite a bit of human error when you're running those calculations, into a system that's able to get better as we scale, as well as manage a lot of those inputs and outputs that actually action the system.
And what are the impacts to the customer on downtime? Is it like they blow their permits, or what's their downside?
We actually see their costs exploding, especially around the regulation side of things. So typically they pay on a per fine basis if they're emitting these wastewater loads. If they can't treat it on site, then they have to irrigate or send it straight to trade waste, where they then pay and their fines balloon. If they don't deal with it in a set period of time, they actually then start risking shutdown. So they're under a pretty tight leash to keep these, within compliance.
And in terms of for if our system had a lot of downtime, and I think your question was about around like the flow-on effects if it means that we can't treat the wastewater, the most likely scenario for an initial deployment is that we're being integrated alongside those lagoons that they already have. So the lagoons have still a bit of capacity. So eventually it would sort of just mean that they have more volume in the lagoons, and it just means that the lagoons still have additional capacity that isn't maxed out. So they just will continue maxing out the capacity until they can keep using our system if there were to be downtime.
Great presentation. Thank you. 2 quick questions. You mentioned 4 LOIs for late 2027. I think they were all dairy, but I'm just curious.
Just 2 meat, 2 dairy.
2 meat, 2 dairy. Curious about how those have come about as well, following the other question.
Yeah.
And then where are you currently doing your R&D? Like, are you in Australia?
Yeah, so we're based at our labs at the University of Sydney. So we're based at the Sydney University Knowledge Hub, which is the commercialization office of the university. So we do all of our lab testing there. We have the PC2 lab there. And then the leads, same answer as before. So some of them were from just cold outreach, and then some of them were from like ag industry events. So we've showcased a lot of events and talked to customers face to face, and that'll continue being our best like customer acquisition pipeline strategy.
Got it. And you mentioned patent pending. Are you spinning out of the university lab, or what's the
So
transfer?
yeah, great thing is we've developed this completely outside of the university. So obviously use is not that happy because they want a piece of the pie, but
Okay.
yeah, completely separated. So no issues there.
Cool. Great job.
Thank you guys.
Thank you.
Careful. Oh, thank you. Doing my job for me. Wonderful. Okay, next up, we're going to welcome Cosine to the stage.
Testing. We are Cosine, and we are rebuilding industrial heat. Heavy industry accounts for 23% of annual global emissions. This includes petroleum refining, steel manufacturing, cement production, and chemicals processing. Now, heavy industry is considered hard to abate or hard to decarbonize primarily for one reason, and that is that each of these processes need heat. High temperature heat. And in order to decarbonize heavy industry, we must decarbonize heat. In heavy industry, close to 3/4 of energy usage goes to heating alone. And today, that is done primarily through the combustion of fossil fuels, such as coal, natural gas, and oil. Now, to replace this for clean technologies, for low to medium temperature processes below 400 degrees Celsius, currently the industry standard is heat pumps and resistance-based heaters. However, for anything above 400 degrees Celsius, which we deem as high-grade heat, there's currently no dominant solution. This is where Cosine aims to fill the technology gap. We are targeting the chemicals manufacturing and processing space because chemicals is single-handedly the biggest sector that consumes industrial heat. Over 40% of industrial heat, or 1 gigaton of CO2, is emitted. And for Cosine, that is an opportunity to abate. In the chemicals world today, heat is primarily delivered through a heat transfer fluid, such as steam or hot oil. In a hot oil system, you have heat exchangers, heater tanks, expansion tanks, pump systems, not to mention all the insulated hot oil pipes to deliver the hot oil to each chemical reactor. And this entire thing is powered by natural gas. So you need pipeline for the natural gas, and then you also need exhaust stacks for the combustion. This is incredibly capital intensive. If you go to an electrified chemical plant, you can replace your pump skid with solid state power electronics, all the hot oil pipes with cables, which are significantly more efficient, and you can reduce the size of your reactor and the number of your reactors because you no longer have transmission losses associated with transmission of the hot oil, and you are heating the chemical reactor directly. This becomes a cheaper and significantly safer process because there are no more moving parts, and we retain full digital control. So we get faster ramp-up times, and we can fully process intensify our chemical plant. Now, we don't have to look too far when it comes to electrified heat. In your kitchen, you have a toaster, which is a resistive heater. You have a microwave generator, which is your microwave oven. And if you're fancy, you have an induction stovetop. We argue that induction is the most scalable technology for several reasons. But before we talk about that, let's talk about how induction works. At its core, induction composes two components. The first is a coil, and the second is a susceptor, the thing that gets hot. We generate an alternating magnetic field by injecting an alternating current into the coil, and that couples to the susceptor, generates currents inside the susceptor, and that is essentially what turns the susceptor hot. The physics of this dictate that this is first a wireless technology, so you can operate at much higher temperatures, and then secondly, you can get much more uniform temperature profiles because the physics assumes this is a volumetric process. Induction is also scalable because there is already industrial precedence. The metallurgy industry uses megawatt induction furnaces to melt scrap metal above 1,500 degrees Celsius. We are taking induction to the next level. Based on the research that we've done at Stanford, we have patented technology in first, resonant susceptors, which just like how you would push a child on a swing at the natural frequency to increase the amplitude or energy, you can couple to these resonant susceptors by driving it at the natural frequency. This allows you to achieve a 99% power to heat efficiency compared to conventional cases, which are less than 90%. You can tailor the susceptor to achieve uniform temperature profiles, allowing you to reduce the size or increase your modularity. And the best thing about all this is that it's just stainless steel, and the manufacturing costs of this are incredibly low. Second, this allows you to pressurize your system without coupling to the pressure vessel itself. The chemicals industry cares a lot about pressurization because a lot of the chemical processes are pressurized. And so by minimizing our losses through our pressure vessel, we can maximize energy delivery to the thing that needs to get hot. And finally, we have patented technology in dynamic temperature control. So we can rapidly respond to disturbances, tailor our temperature profiles, and ultimately become compatible with intermittent renewables, which allows us to tap into the cheap operating costs of solar. Cosine is building fully integrated power electronics and reactor solutions where our power electronics can achieve greater than 97% efficiency using silicon carbide-based technology, and our reactor can achieve uniform temperature profiles, 95% power to heat efficiency, and much faster ramp-up times compared to conventional reactors. Our value proposition is that we're specializing in the co-design of the power electronics and the reactor to bring forth new limits to process intensification and chemicals processing, improving things such as yield, selectivity, and throughput. We are tapping first into the specialty chemicals market for two reasons. The first is that the technical risk is much lower. The scale of these systems are significantly smaller, and so we can build systems that have low technical risk. Secondly, the product value is significantly higher, so we are immune to any high energy costs. We eventually want to scale to the commodity chemical space, which has a total addressable market of about $1.9 trillion, and this is where we can truly disrupt the space. We are forming strategic partnerships with specialty and commodity chemicals where we are building modular reactors to add capacity Given that we have low footprint, this should provide ease of adoption. Our primary revenue stream includes the full reactor stack of power electronics, the reactor itself, and any auxiliary equipment and software. Our secondary revenue stream includes engineering services, customization fees, and any commissioning upgrades. Across the board, compared to other electrified heating technologies such as plasma-based, resistive, and microwave, we win when it comes to power electronics efficiency, complexity, the heating profile, and how hot we can go. Now, electrified heating concepts are not necessarily our competition. Our true competition is our fossil fuel competitors. So for a hot oil system that I discussed earlier, the selling price of one of these systems is about $120K. This gives a payback period of about 7.5 years and a levelized cost of heat of about $160 per megawatt hour of thermal energy. We can cut costs by 3. Our selling price can be about $47K. We can reduce our payback period by a good amount to less than 3 years. And then our levelized cost of heat is only about $114 per megawatt hour of thermal energy. We are offering the cheapest and cleanest solution out there, and we can adapt to customers' needs. Now, to look at our decarbonization potential just for a specialty chemical plant, assuming that we have 100 Cosine reactors that operate at 100 kilowatts with a 20-year lifetime, this produces about 1.75 terawatts across its lifetime. This is equivalent to about 350,000 tons of CO2 avoided per plant, assuming renewable energy. If you scale that up to 10 plants, that's about 3.5 million tons. And this is just a specialty chemicals plant. We eventually plan to scale to the commodity scale and also to other markets. So where are we today? We've filed 4 patents. We've done things at lab scale. We've conducted over 150 stakeholder interviews. We've secured an NSF SBIR phase 1, which is about $300K. And we've signed an NDA with our first customer, a global specialty chemicals company, to build a process for validation. With the help of the MIT Climate and Energy Prize, we want to move out of our university lab, build up our equipment and tooling, hire a reactor engineer that understands compliance, and build up our first pilot prototype. In year 2, we will test and validate and raise our seeds round at the commercial site, and then perform studies in adjacent processes. In year 2.5, we'll deploy our first of a kind and build up nth of a kind designs and prototypes. And finally, in year 3 and beyond, we want to deploy our nth of a kind in other chemicals and chemicals companies and scale to other markets. My name is Calvin, and I am the CEO of Cosine, and I am wrapping up my PhD in power electronics for thermochemical reactors at Stanford. My co-founder, Connor, is the CTO, and he's wrapping up his PhD in reactor engineering, multi-scale multi-physics. We are under the supervision of Professor Jonathan Fan, who specializes in electromagnetics at Stanford. We're 3 electrical engineers at Stanford who spent 4.5 years studying high-grade heat and chemicals. We have industry experience, we have academic experience. We're looking to grow our team to a multidisciplinary world-class team to solve this multidisciplinary problem. And if you believe in our mission, join us so we can rebuild industrial heat together. Thank you.
Can you describe a little bit about what you've learned from your stakeholder interviews so far, and how you expect to be able to sell to this customer base?
Yeah, so we've talked to a lot of different chemicals companies in this space. We talked to the big dogs like Chevron, Shell, ExxonMobil, and we also talked to this tier of chemicals companies that we haven't even thought about, which is the specialty chemicals companies. So one of the biggest learnings that we had was, if you want to get into the market first, you have to start small, because a lot of these chemical companies are not going to necessarily, upfront buy your thing. The commodity chemicals companies, they likely have an R&D team that will try to, electrify their process. So like Shell, BASF, they already have a lot of these teams that are trying to electrify. But the specialty chemicals market we found to be incredibly diverse, but also immune to the energy costs that you might have to deal with when it comes to electrified technologies. So that was the first thing. The second thing I would say is energy costs are really high. So I think being able to shield yourself away from that is probably like one of the biggest pieces for scaling up. Yeah.
I'll briefly add that they're extremely risk averse. Safety considerations are like plenty, compliance regulation, all challenging. And so sort of once you can secure that first contract, you're like golden because you're like the only player who's like has this legacy. And so all further sales become massively simplified.
Thanks. Good presentation. You're solving an important problem. So can you talk about your business model a little bit more and maybe go to the next level of explanation? You talked about co-designing your systems. You talked about JDAs. Just go to the next level of explanation of the business model.
Yeah. So we're targeting two things when it comes to the right customer. The first is a customer that requires. So let me talk a little bit about our customer that we're working with for the next year and a half to build up a process. They care a lot about modularity. So they want essentially reactors on wheels that can be incredibly reconfigurable. They're not necessarily looking for like, here's a drop-in solution right now and right here, because their systems are going to work. They're generally cheap in terms of energy cost. But I think the important thing is that we want to build a company that adds capacity to already existing chemical plants, but we're also targeting, based on a lot of the metrics that we've shown and the techno-economics, that the end of life, we are a better solution for end of life, essentially. So we're looking for end of life replacement. Ultimately, when it comes to like the business model itself, we want to scale to building reconfigurable modular reactors that are generally generalized, but also still co-designed for the process itself. So we don't want to necessarily build like very bespoke reactors for very different processes. We believe that we can generalize to very few platforms that can do a lot of different things.
So you'll be selling the reactors?
Yes, yes, yeah. So it's the full reactor stack, power electronics, reactor, software, and any auxiliary equipment. Yeah.
And kind of pulling on that thread a bit, as you, like, I think you mentioned you're maybe 130 watt per megawatt thermal today is what they're buying, and you're going to be 114, so it's a little better, but not like twice as good. When you walk in, is your pitch to them, I'm going to save you a ton of money, or is it's just about as good, but it'll be electric, right? What's really the story to them, and what resonates with them? How much win do you hand your customer?
Yeah, yeah. The auxiliary equipment that these current solutions have, like the legacy equipment, is incredibly difficult. So our customer that we're working with is like, we don't like the fact that we have all this piping and the insulation is incredibly expensive. We have an entire pump skid that includes like 4 different core components. We have all this natural gas pipeline stuff. For them, it's like, it is a cheaper solution to begin with, and that, that is them telling us. And the second thing is, I think there's a operator-friendly aspect to it that isn't necessarily easy to quantify, which is the fact that this is a wireless technology, so you can easily, swap out catalysts, for example, without having to take apart the entire system. And also the fact that it's just a cleaner solution. You have just cables. The footprint is significantly smaller. And like I mentioned earlier, they just want reactors that they can roll around from one side of the warehouse or the factory to another and service many different reactions. Whereas currently, these things are like stuck to the ground and they can't really move it. So, yeah.
What's the hardest thing about scaling your systems?
I would say probably the hardest part, honestly, is just energy cost starts to become like a huge, huge problem. From a technical side, life actually just gets better and better as you scale. The physics of induction aren't naturally favorable for extremely large systems. But energy costs are the big problem here. And so this is where if you can find processes where intermittency is viable, a lot of times you have like upstream and downstream equipment that can't run intermittently. So even if your reactor is capable of it, the like entire process cannot. But if you can find those options, you can do energy arbitrage and help perform grid load balancing. And that way you get very low electricity costs and life is pretty much great. But yeah, the challenge is finding what are those opportunities where the process can actually run intermittently. But if you can find those, scale up looks pretty great.
I think one great presentation, thank you. You mentioned you got an SBIR, phase 1, congrats. That's a big milestone, especially right now. What is your kind of plan for fundraising beyond that or follow-on funding separate from this prize?
Yeah, the SBIR should take us for the next year to just build up the pilot prototype, be able to test and validate it. And then the sales cycle with that pretty much begins right after that. So this customer wants to build or buy a few of these units. And so if we can get that revenue as soon as possible, then we don't necessarily need funding, like that much funding. When it comes to, I guess, hiring, that's probably going to be the biggest cost. So I think at least in year 2, we'll start seeking a seed round. Yeah.
Great, okay. Next up is Kijani Carbon.
So we are Kijani Carbon, and our mission is turning sugarcane waste into impact and income in East Africa and beyond. So let's start with the problem. That is sugarcane waste, the bagasse you see in front of you there. Essentially, for a mill to operate, what generally happens is cane is harvested from smallholder farms, then transported long distances to mills, where they are processed, output of which is sugar, of course, but there are 3 waste products: bagasse, 200 tons a day, press mud, and fly ash. Now, what generally happens are these are stockpiled, sold for no value add, or discarded. And this same harmful cycle repeats in virtually every sugar mill globally. But why is it harmful? And to whom specifically? Well, let's start with climate. So, the amount of waste bagasse globally is enough to fill 22 million shipping containers annually. Now, Kenya only has a very small fraction of this, and yet it produces as much CO2 as it would take 18 million trees to sequester annually. If that wasn't enough, it's stockpiled or burned. The burned bagasse creates even more harmful toxins and CO2. The stockpiled bagasse creates methane and is a runoff risk. And this is a huge compliance risk for mills as well. On the other side of the production cycle, soils are degrading and smallholder farmers are paying the price. This is a very common problem. It affects more than half of agri-land on the African continent. To use Kenya as an example, what happens is chemical fertilizers generally over-applied. This nourishes the plants temporarily while degrading the soil. So over time, yields collapse. This, in combination with the rising costs, mean farmers get less. And government in Kenya subsidizes $188 million a year just to keep up what is a vicious cycle. So, what are we doing about this? We can solve both of these problems, and we can do it with these waste products. How we're doing it is through this process. So we're taking this mountain of bagasse, putting it through pyrolysis to create biochar, which locks in the carbon, then activating it with the other waste products to create 3 high-value products: biochar fertilizer, carbon credits, and clean power. So if this is such a good idea, why isn't it universal? And the reason, it hasn't been an easy journey to get here. Bagasse is a very tricky feedstock to work with for 3 primary reasons. First, it comes in at an exceptionally high moisture content. Secondly, it produces a glass-like residue at the bottom of reactors due to the sugars and the silica being burned. And thirdly, something we're solving both operationally and technically is the scale problem. So what we figured out is how to recycle the heat from the carbonizer back to the dryer so that it dries the feedstock at an earlier stage of the process without electrical input. Secondly, for the silica, we're taking this carbonizer and turning it into a carbonization bank. This allows two things. Firstly, one carbonizer can be taken out and cleaned while the rest run, so it does not disrupt production. It's easier for modular scaling, and instead of using fossil fuels to jumpstart the reactor every time, we can essentially use the running reactors. Now the scale problem. We've built our entire line in a replicable way, and we've solved the end customer problem through our mechanism of fertilizer and our partnerships with mills and farmers. So let's talk about the fourth thing, activation. What is activation? Essentially, we're taking the biochar, blending it with the other waste products to produce something that extracts the value of that carbon sponge. In this case, a semi-organic fertilizer. Now, it just so happens that 3 of these 4 products are waste products. The exception is nitrogen. Today, we're doing conventional. In the future, we're going to treat wastewater and produce our own ammonia, green ammonia. And the scientific evidence is conclusive on this as well. Cane yield, sucrose yield even more than cane yield, reducing the leaching and longer planting cycles. What's the effect? Well, from our vicious cycle, we get into a virtuous cycle. And the impact on farmers is a 24% increase in income where the default was declining. Now, this may seem very small, but it's non-trivial for smallholder farmers. It allows them to send 1 more child to school. And on the environmental side, we've gone from the base case of large CO2 emissions to, in year 10, going to sequester equivalent of 45 million trees. For mills, this is a no-brainer. Not only are we exceeding the compliance requirements, they are benefiting from the same improvement in yields that farmers are seeing. And what does this mean is $6 million to their top line. If that wasn't enough, we are paying mills $1 million a year for their waste. So how do we benefit? Well, in short, $7 million in revenue per site, per year, and this is at the base level of production, that's 2,000 tons a day. This is split 70% fertilizer, 30% carbon credits at a conservative margin. And for the fertilizers, critically, this is 40% cheaper per bag than the chemical alternative and better for the soil because of the semi-organic nature and the biochar activation. So we stand on solid financials. Including OPEX, our simple payback is less than 18 months, and our revenue split insulates us from fluctuations in the carbon market. So how does it scale over time? Due to our partnerships with mills and our technical replicability, we can scale to 8 mills by year 5. This is leading to a 78% CAGR. That's true for revenue as well as CO2 emissions, as well as the farmers impacted. So we're starting at our beachhead at Angata, which is a site where our family are minority investors. Through Angata, we have access to another 8 mills. And this will enable us to scale to not only high revenue potential, but high potential to impact lives on the continent. So what have we done so far? Not only have we secured our supply and feedstock, we have mapped 22,000 customers who are contracted to receive the fertilizer, and we have done our technical homework. Next is negotiations and pilot deployment, which takes us to the ask. Now, bagasse is tricky as a feedstock, so most of our time and effort has gone into figuring out how this can work at scale while still being economical. And that work will continue using this funding with the shortlisted suppliers. In addition, we have to start getting our hands dirty with a test carbonizer we've already identified to produce and optimize our formula for the fertilizer. In addition, we have to start the regulatory cycles as well. So this is where the rubber meets the soil for us. And our team, myself and Abid, have been in the sugar industry for a few years. We have experience via Angata. I'm on the ops side. Abid is on the technical side, and he works very closely with Thomas, who has over 2 decades of experience in pyrolysis and biochar equipment specifically. The rest of the team has experience in everything from soil science to MRV to, very critically for Kenya, government and policy. So, a last note, most climate solutions require premium to have the level of impact that we have. Not Kijani. Our fertilizer is cheaper and better for the environment. So we are the rational economic choice for farmers and mills alike. We just happen to also be the better choice for the planet. That's Kijani. Thank you.
On one of your slides, it said that it's $0 for CAC. Can you help us understand that?
Yeah, so the $0 for CAC is essentially we partner with mills. So the mills have customers automatically. So what we do is we essentially work with the mills to say, okay, we have to GIS map the farms as well. So the mills essentially take on that cost because it benefits them and it ensures that we have that bag level traceability that we're going to need in the future for carbon removal.
So 2 questions, and stay on this slide.
Sure.
So one is, who do you expect to buy your carbon credits at what price?
Yeah.
And 2, you're talking about your revenue, can you talk more about your costs and what your margins will be over time?
Sure. I'll start with the carbon credits, then I'll move to an appendix slide. So carbon credits, as we see in this tiny visual here, we've put a conservative $100 credit. And that's for no other reason than just to be financially conservative. Our average that we're seeing is 164, so we feel fairly confident that we'll be able to hit that target. And I guess the main buyers have been like the tech firms, Microsoft, and so forth. We had an exploratory conversation with the main buyer for Microsoft of carbon credits as well, but that's kind of far out. We're confident in the quality of our traceability and our credits, and so we feel like $100 is conservative. Yeah, and we'll be able to get the market for it. So now to the second question about the financials. Gotta get through a few slides here. Oh, sorry about that. I guess our appendix somehow is not here. How do we, just going forward. Apologies. Yes, so your question, just so I remember, was about what specifically about the financials again?
So, talk more about your costs and the margins.
Yeah, of course. So our costs are essentially, so bagasse is, we've associated a cost with bagasse, and that's probably the biggest feedstock costs. So we have bagasse, press mud, and fly ash. Now, fly ash is something that costs mills to get rid of. Bagasse is something that is also a liability for them, and press mud they generally sell for low margins. So we're paying them for bagasse where they would get nothing. For press mud, we are paying them almost a 50% premium, and for the fly ash, we're taking that problem off their hands. Our biggest cost in this production is the nitrogen, and we're looking at what would be the cost to process that ourselves from the wastewater plant, which is within the mill, and make that green ammonia. So that is the cost we've factored in. And we still have a very comfortable $8.5 margin. This is not even considering the government subsidies that are a big part. Currently, the government subsidizes $20 to $25 per bag of chemical fertilizer.
All right. So this is showing a single mill.
A single mill, yes. And so this is our scaling plan where we have our 8 mills. And each mill, of course, is also growing here. We've taken a base assumption of 2,000 tons a day for simplicity, but in reality, most mills are already operating at 5,000 tons.
So my question goes to, call it technical feasibility. It seems like you have some clever ideas, but maybe haven't operated them at scale. And how much do you worry about the ability for this concept to play out? And what risks have you knocked down?
I think that's part of what we're spending most of our effort doing at the moment. So working with people who've been, so Thomas, who leads our process engineering, has built these systems and also, more importantly, worked on our energy and mass balances. So we're pretty confident that we can get to the point where we're able to do this. We've seen other people, there's a plant in Louisiana that's able to do it. What we haven't seen is being able to do it at a cost that works for the African market. So the CapEx that's needed across, because a lot of the supplies are European supplies for this kind of equipment, we've had to look further east to find something that's a little more affordable for the market, because we're looking at about $7 million to stand up a plant for 2,000 TCD of a sugar mill. An equivalent European plant would be in the $20 to $30 million range, especially when you consider the power generation component of it. That's going to power initially the pelletizer, as well as eventually use some of the extra power to generate that green ammonia.
Yeah, kind of continuing on the thread of the technology, I'm curious if you could elaborate a little bit on how you deal with the sugars and what you've demonstrated so far by prototypes or operational data.
So the problem with the sugar is it's the residual sugars that are left through. That's in bagasse, it's higher. It's generally pretty low and that we can deal with it. But the sugars combined with the silica generates that glass-like substance. So that's why we've come up with this idea of you'd use 3 carbonizers in a row where you can actually take one offline. And the reason we came up with this is when we looked at other pyrolysis units that have been taken and just put onto the bagasse, their downtime is 40 to 50% of the time just because of that cleaning cycle that's needed. And that means they're also needing fossil fuels to restart that reactor again. So our idea is we combine the 3 and recycle the syngas to restart the reactors, but also you're only taking off a third of your capacity at one time to do that cleaning, and that we're anticipating that to happen maybe once a month or for 2 or 3 days a month.
Great. And then what have you been able to validate through prototyping and operational data so far?
Yeah. So we don't have a full prototype of the mill at scale. What we have is, and we've been able to produce a small amount of biochar that we're using that for the field studies to validate some of what the other yield increase studies have found.
Yeah, but that's essentially where we need the unlock, I think, is to get the test carbonizer that we've identified. We know the pieces and how they are going to fit together. We just need to figure out the technical kinks and continue on that journey.
Great, thank you.
You mentioned family ties. You're starting with Engada, but you have family ties. Could you talk any more about other customer discovery work, or it sounds like there's a lot of promising?
Yes. So a few points. This is how the business came about. We were like, we're going to have so much waste. And this is a very green field. Angata is super green field. A month ago, we started producing. And we didn't want the waste, right? We wanted to do it differently from the rest of the players in the industry. So we are looking at many different alternatives. And we saw this as an emerging technology. We double-clicked, we triple-clicked, and now we're it's a full-fledged business because everything just made sense. And it's also very relationship-driven in this part of the world, which is a benefit sometimes and a problem sometimes. And thankfully for us, we are within the space where we have very easy access to 8 other mills. So essentially, once we prove our technology at the beachhead, we have almost immediate access to 8 other mills. And as we saw, it makes complete sense financially for mills.
Great, thank you so much.
Thank you.
Thank you so much. Okay, next up, we're going to take a brief coffee break and then set up a Zoom. So if you all want to take a brief networking break, we'll be back at 10:45 for our keynote speaker, Katherine Wolfram. Thank you.
Not doing the next one, Aeropod.
Maybe it's a Zoom. Yeah, I thought there were 4 right now.
Yeah.
I think she's setting up a Zoom. Maybe it was our being off schedule.
Maybe.
Okay, hi, this is Zia Gonzalez from I'm pitching California in about 15 minutes. Okay?
And put it up so that it's in both spots.
Yep, I can do that. I just changed the agenda slide.
It's now free. So there are two full virtual, one combo, and then one in person at the very end. There's at the 11th presentation, there's been an addition. Yes. So we did here. Yeah.
So now we're actually, by the way, for your flexibility with this. So now we're actually 3 virtual.
Yep, I know.
And then 2 in person.
Yes.
Yeah.
So share this. You need to be
Yep.
sending this to Zoom because I want to make sure she doesn't get kicked off of that TV.
Yep.
When you share the Zoom.
Sounds good. I'm just gonna.
Need this to happen like now.
Okay.
Because we never were able to test this because of the firewall issues in here. Made us 20 minutes.
Okay, share.
Okay, so you're going to be sharing that presentation.
Yep.
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 Oh. Okay, make sure you're in presentation mode.
Okay.
I think
Sorry.
it's now on.
Yeah.
Slide mode, right down there.
Yeah. I just need. Okay.
Yep. Now, it should also be sharing up there.
Yeah, I know, but I don't want to share it right now for a second. Yeah.
But that's on purpose. You
Yeah,
turned
that's
that
on
on.
purpose. Yes.
Good.
And
okay.
I can turn it back on.
All right, but now, right now, we're just seeing that on that TV.
Yeah.
So we need to make sure that she's pinned.
Okay.
Slides and they will be controlled by the person here?
No, by the person on the Zoom.
But
I'm not going to share the slides. They're sharing their own slides.
Oh. I mean, the idea is that yours is projected here.
Oh, well.
See? So there's like yours and Julia's both are connected to some session, and Julia's is just showing like the speaker, and it is that yours is showing the slides, right? So then I think we'll need the clicker for this one.
But nobody here is clicking.
They're not?
No, because all the pitches are happening through Zoom.
Oh. So I'm not understanding this. So the thing said right now was that the PowerPoint would be controlled here, not in the Zoom. Did you understand that?
The person here is controlling the slides, but
yeah.
She was quite stressed about that.
Yeah.
Yeah, no, they have to control the slides.
Who's the Aeropod person here?
Ocean.
Ocean. would be coming through the live stream. Just maybe
We need to have just do a little bit of talking because we need to do an in-house test.
James, I'm so sorry, but we need the people on Zoom to be sharing the slides.
Does she have the slides?
She has the slides, yeah.
Oh. No, because this is an internal sharing. Right.
You can put the Zoom up here, and then when she goes
let's do that.
through the slides, then
It'll be a combo up here.
Oh, we won't be able to see her face.
Well, hold on. Hold on. You pin her over here. You can have the presentation going on over here, and she can be operating it on Zoom. That's
Yeah.
exactly right.
I think that's fine, yeah.
But you just need to reconnect it.
Yeah. So reconnect it, and then what you're doing is you're not sharing the PowerPoint, but you're sharing the Zoom.
Yeah.
So you can stop the share and then switch over to the Zoom.
Yep, I can do that.
And that actually works great for the virtual presenters too.
I think they're all like that.
Yeah, they are.
It's
Yeah.
a virtual, so if you share the Zoom up there, pin the presentation so she goes through it when she's talking.
We have to re-pin presenters.
That's fine. So what I'm saying is presentation here. Once the in-person presentation happens and
Stay on one side.
Sebrin, are you here, Sebrin? Sebrin?
if you want it to be able to be controlled
Sebrin from Holotrops?
when there's no one virtual, you're going to have to switch
No.
to the actual presentation like it was doing before.
So between these two, we'll have to do a switch, basically. Between these two, we'll have to do a switch.
The thing is, Holotrops is also doing the same thing as them. This guy.
Okay. So whatever we do, we'll.
Okay,
we'll do
it
for
should
them.
be
Like
fine.
a slightly awkward moment in the middle of
It's
this
fine.
and
Yeah.
in the middle of this where because you're having the Zoom share the slides for the virtual pitches, when you do the in-person, you're going to have to switch from the Zoom being up here on your full screen to the actual like presentation in room.
Maybe I should just switch interlinked. These guys are in person and Holotrops is virtual, so maybe
I think it would be easiest to
Yeah.
have it either at the beginning or the end.
Okay, perfect.
So for her, she's sharing her screen, and then Michelle's Zoom is going to be. Okay, so she's basically just sharing her screen. She doesn't have to use Zoom to
So
No,
the
I'm
one
sharing
thing I will say, you're going to have to, since I'm operating camera, just be over here and make sure that you can see her on your screen on your laptop, and then she'll definitely be on the TV. Okay.
And then your screen share.
But I need her to do some audio testing right now.
Yeah,
because
she's
I
happy to do that. So like whenever you're ready.
Who's going to be on switching it? Like who's controlling this?
She wants to like our.
No, I mean like when you're going back from virtual
So
into
please just have her do
who
some
wants
tweaking
to
so we
switch
can do a real quick test in the room. Okay?
Switch to.
in-person slides.
Oh, I'll do that.
Okay, so once the virtual pitches are over,
Yeah,
you'll switch to
I'll
the
switch it.
PowerPoint so that they can control it.
Yeah.
But when you have this up, the virtual pitching will be controlling it.
Yes.
But I would go ahead and share your screen for the Zoom just to make sure it looks right.
So is she talking right now?
I would do entire screen so that when you switch it, it'll be easier. I mean, you can always like reconnect, but it's just easier if you do whole screen.
This is Lou again.
And so this looks good.
And then they'll need to, whoever's doing, if she's sharing her screen, she needs to do that so we can pin it. Because you don't want her video pinned, you want her screen pinned.
Right, okay.
It will be.
And it's starting with virtual, then in person.
Virtual half, it's actually half virtual. What's after that?
But you want the virtual person to be controlling the slides. to
For
start.
all of them,
For all of them.
yeah. Wait, sorry, so can she hear us? Okay, share the slides, yeah.
On Zoom. So you're pinning her slides and I'm pinning her face.
Aeropod, and then the other.
And then we're going to turn the TV off.
For in person.
Well, so can we project Katherine Wolfram's slide?
She has slides?
Well, no, she doesn't have slides, but like this slide that says Katherine Wolfram, keynote speaker.
Yeah.
Up here?
Yeah.
Yeah.
I can switch that.
Okay. So the TV, do you have like a holding slide that you can switch to out of the Zoom when someone's on stage? I would just do that and not turn it off.
I can just do like a CD.
Yeah, I would just bring up the event graphic, like that one, and then when you're switching between, when you have an in-person speaker or whatever, just have a graphic that's full, and then you can have your normal presentation.
Yeah, we don't have to turn it off.
Wait, is she sharing her slides? Can you just call her?
Stop doing it to test.
All
Thanks, Kelly. You're the best. I can't wait to try. How you doing? No, not at all. I'm a stressed person.
Yeah.
Yeah, I mean, I always love seeing stuff come together. The teams have done a really good job. The Rise team has done a good job.
Just speaker.
Oh, you know.
So there's only one person. Yeah.
I don't know what you guys think.
Yeah,
And then
well,
can you
it's
just
funny
click
because
unmute?
maybe it's just frame of reference because
No, I don't know. It's fine, whatever.
slightly more advanced deals lately. And so, I mean, this is
Okay, yeah, and then her
like,
face.
oh, okay, this is pretty
Oh, well, I
early.
guess it wouldn't.
It's
She's
very
Well, she's
early.
right there. And then
There's definitely a way to just have the screen showing, but
Yeah, right?
it's not that bad.
Yeah, I mean, I feel like they have good mentoring.
We only do have 2 minutes until we're supposed to have Katherine start. So
Know what to talk
anything
about.
that's not
Okay,
necessary.
I
it's
think
okay.
Especially about
Can we just ask him to go off camera?
So, yeah, I mean, it's certainly like,
Yeah, anyone who's
I don't feel like any of these are like a waste
So it's also just go off camera.
Do you have the slide for your next speaker ready on the screen? Yeah. I would go ahead and toggle whenever you're ready.
okay, I think we should be all good with yours. Thank you so much for checking.
Are you controlling it from Google Slides or from PowerPoint?
This is from Google Slides.
It's been from Google Slides the whole time.
And then
you'll.
okay, so this and then just this. Yeah.
Easy.
Okay. So make sure that no one comes off mute the Zoom.
Okay.
You know what I mean?
Yeah.
Like while Katherine's speaking, that would be really bad.
Can someone send me that?
originally New York.
Send her that graphic.
So it's not like we can.
Been here for a while.
Wait, why do we need that?
So with this on the screen, so that we
During
don't see her.
conference?
Yeah.
During like all the in-person ones, so we don't have to switch back.
There's.
Can we just turn off the camera?
Can we just turn off the TV? Is it easy to do?
It would just, if you turn it off and then turn it back on, you're gonna have to like make sure it's reconnected correctly.
Okay, never mind. Yeah, okay.
I would just have a holding slide up.
I know, but
Can we just turn it around?
I mean, if you want to turn it off and then just go back and turn it back on.
Well, I think this.
It's just
as
a
long
little
as it
awkward.
doesn't risk like.
It won't mess it up. You'll just have to make sure it's connected onto the HDMI.
Actually, Michelle, I think that's a good one.
Yeah.
Like used every little scrap of time. Yeah. Right.
Oh, the deliberation.
Sorry, thank you.
Right on the other side of this wall. Right.
Well, I'll wait. Thank you all. If you can start making your way back to your seats, we'll get ready for our keynote speaker. Thank you all. So we're thrilled today to have with us Professor Katherine Wolfram, who's a professor of energy economics at the MIT Sloan School of Management. Dr. Wolfram previously served as professor of business administration at Berkeley Haas, and in 2021 and 2022, Dr. Wolfram served as the Deputy Assistant Secretary for Climate and Energy Economics at the U.S. Treasury. Since March 2025, Dr. Wolfram has served on the COP30 Ad Hoc Council of Economists and chaired a working group on climate coalitions. Dr. Wolfram has published extensively on the economics of energy markets. Her work has analyzed rural electrification programs in the developing world, energy efficiency programs in the US, the effects of environmental regulations on energy markets, and the impact of privatization and market restructuring in the US and the UK. Dr. Wolfram is currently working on projects at the intersection of climate, energy, and trade, including work on carbon border adjustment mechanisms and oil market sanctions, very relevant today. So thank you so much, Dr. Wolfram, for being with us, and we look forward to hearing from you.
Wonderful. Thank you so much. It's great to see such a global set of teams here. Welcome to Cambridge or Somerville, I guess. Welcome to MIT. I wanted to talk for about 10, 15 minutes, but then open it up and really have a conversation. So I have been studying climate change for years, and I mark the beginning of my study of climate change to around 2005, when Nicholas Stern came to Berkeley. Do people know who Nick Stern is, Sir Nick Stern? In 2005, I'm not getting a lot of yeses, so 2005, there was a big report that came out, the Stern Review, and it was about kind of all the economic damages from climate change, all the ways that we thought we could address climate change with policy. So Nick Stern, at the time, I met him in person, and I was kind of starstruck, and I was really convinced by the arguments that he was making. And so up until that point in 2005, I had mainly studied electricity restructuring, not climate related directly, but was convinced by the Stern Review and really embarked on a new path in my career devoted to thinking about climate topics. And part of that was I pivoted to work on energy use in emerging market and developing economies. So I since then have done a lot of work in Kenya and Ghana and a little bit in India. So I wanted to share two observations that I had then in 2005. And I think one is still true and one is pretty much wrong. And I'll explain why. So the first observation, and this is the one that I think is still true, is that the global south is really central to the fight against climate change. And I say that without kind of putting the burden of addressing climate change on the global south, because the global south is also growing a lot and needs to continue growing. But if you look at the pace of that growth, and if you look at the energy consumption that comes with that growth, 80% of the people on the globe today live in emerging markets and developing economies. And so that is really where all the emissions are projected to come from, all the emissions growth are projected to come from over the next decade, over the next, until 2050. So I think when we're thinking about technologies to decarbonize, we really need to be thinking about how these will be used in the global south, in emerging markets and developing countries. So hopefully some of the technologies that are coming out of the cases today fit that bill. For instance, I think motorbikes, those are used much more in emerging markets and developing economies than cars. So let's think about decarbonizing motorbikes. Whoops. All right, so that is the observation that I think is still true. Let me talk a little bit longer about the observation that I had in 2005 that I now think is kind of reversed. So in 2005, I thought that addressing climate change was mostly a technology problem. The policy solutions are very straightforward. The policy solutions to addressing climate change are quite kind of Econ 101. We need to make the fossil fuels, make the brown energy more expensive and the green energy cheaper. It's quite straightforward. So why is this wrong now? I think there are two reasons. One is that because of people like you, we've made tremendous progress on the technology side. So in 2005, solar was like $1,000 a watt or something. It was very, very expensive, but those costs have come down way, way more than people would have expected. So I think huge kudos to people like you for helping drive that technology progress. And there has not been as much progress on policy. So I believe a central thing that kind of this reaction that, oh, the policy is easy, has missed is the difficulty of coordinating at a global scale. So when you think about all the progress that the world has made addressing environmental problems, you can tick off a lot of successes. Like if you look at air quality in China, huge, huge improvements. If you look at air quality in the US, water quality in the US, again, huge, huge improvements. We kind of know how to address environmental problems, but the difference between those environmental problems and climate change is that climate change is a truly global problem, that we need to figure out a way to coordinate across countries, whereas with local pollution, like air pollution, like water quality issues, it's one government, like the Indian government, the Chinese government can just say, look, we're going to have less coal plants, we're going to have less crop burning, and that leads to improved air quality. But with climate change, I think that we're in this problem where every individual country is kind of waiting for another country to do something. So you see this play out in the US dynamics, where currently the Trump administration is saying, I mean, this is a direct argument that they used when they rescinded the endangerment finding. It's kind of hopeless for us to do anything if the rest of the world isn't doing anything. And similarly, that you see the kind of competitiveness arguments playing out in Europe. Europe has been quite forward-leaning on climate policy, but they are now getting pushback from their industry because the industry feels like they are being saddled with a bunch of costs that competition from imports has not been saddled with. So I think the fundamental problem here is we don't have a global government, right? We don't have a kind of president of the world who can say, here's the way that we're going to make fossil fuels more expensive, and here are the subsidies for clean, and these are going to be kind of spread evenly around the world in a way that's fair. Maybe a little bit more expenses for fossil fuel use in high-income countries compared to low-income countries to let the low-income countries grow. But that's not happening because we're relying on individual governments to make their own decisions. So I've been very excited, as my students in the room know, about a policy that has come out of the EU in the past couple of years that I think addresses this issue of the no global governance head on in a way that policy hasn't in the past. Oops, did I just advance that? Okay. So this policy is called the Carbon Border Adjustment Mechanism, the EU CBAM. And what the EU CBAM does is allows for the fact that right now in the EU, they have a very explicit policy that makes burning fossil fuels expensive. They have a carbon price in the European Union. And what the EU CBAM does is say if you ever export to the European Union, you have to pay a carbon price on those exports. So if you have a steel plant in Malaysia, for instance, and you're exporting to the European Union, exporting your steel to the European Union, you have to pay at the border as though you were a steel producer in the European Union. You have to pay the same price on your carbon emissions. But, and this is a crucial but, if the Malaysian government puts a carbon price on the steel in Malaysia, then that steel is exempt from whatever carbon price it's already paid. And so this has really kind of linked carbon pricing policies across borders in a way that hasn't happened before. It's really said, like, kind of let's all hold hands together and move forward on climate policy. And whereas before it was kind of like, who's going to go first? No one's really anxious to be the first out the door and impose a lot of cost on their industry when they are facing competition from abroad, from industry that's not facing costs. All right, so that is why, as I said at a meeting once, I love CBAM. I was invited to a meeting where Ursula von der Leyen, the president of the European Commission, was there. Friedrich Merz, the Chancellor of Germany, was there. And I started out my remarks. It was one of those settings where I had like 3 minutes to make remarks, and I wanted them to pay attention to my 3 minutes. And so I started out by saying, I love CBAM. And Merz and von der Leyen just like burst out laughing. because, and then they paid attention to what I said, so that was good. But they never get this reaction that people love CBAM. They've gotten a lot of pushback against the carbon border adjustment mechanism. It's not universally loved. I think part of the reason it's not universally loved is because the European Union has not done a very good job marketing it. They've had like 4 people that have gone around the world and tried to get other countries on board with the policy, tried to get other countries to understand the policy. I think also it's viewed as something that the EU has done unilaterally, has done without kind of coordination with other countries. And I think it's something that's viewed as unfair to emerging markets and developing economies, because it's saying, we, the European Union, we've decided what carbon price we will charge on our producers, and we're going to charge exactly the same carbon price on your producers. We're not going to recognize that, you know, carbon might be more valuable in emerging markets and developing economies because you have to grow. So about 15 months ago, colleagues and I started working on a better version of CBAM. Like, let's keep the parts that are good and address the parts that are not so popular. Let's address the fact that this was a unilateral move by the EU. Let's try to get kind of more countries involved in crafting a solution to carbon pricing and trade. Let's address the fact that the way the CBAM is implemented now, it's not fair, that it's imposing the same cost on emerging markets and developing economies. And let's think about doing this in a way that's inclusive. So we were very lucky. We got paired up with the Brazilian Ministry of Finance in like March of last year. Brazil, as you may remember, hosted the climate conference, the Conference of the Parties, the COP. And we got Brazil interested in this idea that we had of forming a coalition of countries that talk about carbon pricing, talk about border adjustments, and talk about ways to make those kind of generally acceptable. And so in literally the best day of my professional life so far, maybe the meeting with mayors in von der Leyen was the second best day, but soon after that meeting, the Brazilians launched at COP30 what's known as the Open Coalition on Compliance Carbon Markets. So compliance carbon markets is kind of like the insider's term for carbon pricing, but this is basically kind of a coalition of countries talking about carbon pricing together, we hope it will evolve into talking about trade across countries when there's carbon pricing involved, and talking about policies that we think could complement those, talking about, for instance, subsidies from high-income countries to low-income countries to help the low-income countries decarbonize, especially in the heavily traded sectors. So you might not have heard of the Open Coalition on Compliance Carbon Markets. It's right now like kind of in, you know, what's the innovators term, like the soft launch or pre-launch stage. But hopefully over the next year, hopefully at COP31, there'll be more news about the Open Coalition. We were very happy because the Open Coalition was endorsed by 18 countries. 18 might not sound like a very big number. There are 190 plus countries that usually show up at the COPs. But of those 18 countries, one was China. That's huge. The EU, not a country of jurisdiction. The UK, Canada, Mexico. 3 countries from Africa, in addition to Brazil, 2 countries from South America, Singapore. So kind of nice, like, income-based variation, nice geographic variation in the members of the coalition. And importantly, the coalition members represent about 40% of global emissions. So hopefully, over the next, you know, not 20 years, but 2 years, we will see the same progress on policy that we've seen on technology over the past 20 years. And I really think that this kind of policy-technology interaction is super important, that having things like carbon prices, having things like subsidies for clean are additional drivers for the great technologies that you guys are working on. So those are my comments. Hopefully I've inspired some kind of pushback and some discussion, but welcome again to Cambridge, and thanks so much.
Thank you so much. What is the ideal outcome of the Open Climate Coalition? So if in 2 years it works out, like what ideally would you want to see come out of it?
Yeah, thanks for that question. So right now, what the Open Coalition is 400 words. The Open Coalition was endorsed by leaders, so people like von der Leyen, Lula in Brazil. But in order to get leader-level agreement, you can't be too specific at the beginning. So they're 400 words, not many words. The 400 words were pretty nice. The 400 words explicitly said that the Open Coalition has a long-term vision of interoperable carbon markets. The economist's dream is to have a global market for carbon where the price reflects what we need it to be to get to net zero by 2050. And so the Open Coalition articulates that as a long-term vision, which just like warms my economist heart. But in order to get there, there's a lot of technical work that needs to happen. And so, and I should also say the 400 words do not say anything about what I think drove the recent momentum towards carbon pricing, which is the European Union's carbon border adjustment mechanism. Right now, it's a sensitive topic. Not everyone loves the CBAM, and so the 400 words do not mention kind of trade measures that might be invoked. And so I hope that as things evolve, well, I should step back. I should also say, together with a network of global thought leaders, we put out a report in September of 2025. It was not 400 words, it was like 100 pages that articulated what we thought a coalition could look like. And so I hope, over the next couple of years, we'll evolve towards something not exactly like that. I'm sure there will be, political issues that come up, or the world will change in important ways. But hopefully, we'll get to a point where we're talking about real carbon pricing. We're talking about things that incentivize countries to join the coalition and punish, disincentivize countries to stay out of the coalition.
When I listen to you talk, I think this is the deal of all deals, right? And so, as sort of a deal maker here, or instigator, where do you anticipate the technical complexities to be as you get down and start talking Turkey? I mean, of course, there's the disparity of income, but I'm sure there are other factors involved. And how do you modulate those to, kind of come to an agreement?
Yeah, no, there are definitely technical issues involved. And I'm not sure I should take the deal maker, given that like the primary deal maker right now is President Trump. I'm not sure I should take that as a compliment, but I'll put that aside. Yeah, no. It's what popped into my mind. So. I think there are two important technical details that I'll mention, and I'm sure there are a host of others. I think one of the important details is getting into kind of the nitty-gritty of carbon pricing, because actually the way it's implemented varies country to country. And so how do we actually think about recognizing a Chinese carbon price, which right now is essentially an intensity standard? It like lets firms, lets plants grow in their output, but charges them a carbon price kind of above a benchmark, whereas the European carbon price applies to all emissions. So how do we think about an equivalence between those, or how do we recognize the Chinese carbon price when Chinese firms are exporting to the European Union? So I think, they're kind of fun technical details for people like me to wrestle with in that respect. Also, the Chinese carbon pricing system is evolving. China announced last year at the UN General Assembly, China announced that they were going to have an NDC that peaked emissions, like total emissions, before 2030 and came down after that. And consistent with that, the Chinese carbon price is evolving into charging all emissions in the same way that the European. So it's going to transition from the current version to a new version. So I think that's kind of one technical detail that needs to be worked out. And then there are definitely some measurement, reporting, and verification details to be worked out. The ideal is that the whole world is a member of the coalition, is pricing carbon at some level, maybe at different levels, depending on the level of income in the country. And if that's the outcome, then we don't have to worry too much about measuring at a plant-by-plant level what the emissions are. But we do have to make sure that countries are actually enforcing their policies. And so, this is kind of a technical dream, but I've been pretty encouraged by the progress that we've been able to make with satellite monitoring. And so I think maybe it's kind of a technical utopia, but hopefully not too far off, that there'll be a way to make sure that if pick your country is saying that they're pricing carbon, that their emissions are coming down in a way that's consistent with what they say they've implemented as a policy. And we're thinking about, there are analogies here, like the IMF right now monitors countries for kind of compliance with exchange rate regimes. So we're thinking through kind of analogies for how programs like that have worked before, how programs like that have kind of monitored compliance, and figuring out how that can work with carbon.
So, Professor, thank you so much. It's nice to be back listening to you. I'm a student of the professor, but I have a question. So, being today here at in a room full of innovators trying to help to reduce carbon emissions, and this policy could be an opportunity for them, as well as impose some transition risks depending on the life cycle of their own products. So what would you recommend them to take into account now that they are designing their products or their solutions, so they can minimize as much as possible the risks of increasing their costs coming out of this policy?
Yeah, thanks for that question, and lovely to see you. Right now, our group, and by us, I'm talking about the Global Climate Policy Project, which is a joint initiative between Harvard and MIT. And so we have embarked on a new initiative to try to get industry involved in thinking about implementing these policy changes. So I think it's really crucial to have kind of the technologists, the industrialists, the people that are actually decarbonizing steel plants to understand this policy, and even better, to advocate for policies that they think are important. So, as I stressed in my remarks, I think that we haven't made nearly enough progress on policy, but I think that there is this kind of happy marriage between policy and technology, and I think that policymakers listen to technologists. If technologists say, look, you might think that a $25 a ton carbon price or a $50 a ton carbon price can't do anything, but in fact it can, I've got this new technology, policymakers will be very, will be very willing to listen to messages like that. So often when I've given talks before, people say, well, what can I do about climate change? I think the most important thing you can do is vote. But second to that, and I think especially for industry representatives, people that are specialists in the field, you can actually advocate for policy. And you can advocate at a high level for policy that A versus B, if you think policy A is better, but also at a minute level, like the implementation details that the gentleman just before you was asking about. Those can be important. I think it's important to get involved with new policies as they're being constructed and make sure that the technical details make sense and are operable, basically. So hire a VP of GovReg. Yeah. What?
Hi, Professor. Thank you so much. This is Andra with Rosar Ridge. I am curious if you'd offer a bit more color, and of course, I'm sure you could go into great detail about this, but about how you might address the carbon leakage problem and thinking about countries or players who might not be as welcoming of this coalition, and basically the idea of just like relocating production manufacturing elsewhere. Just a few more thoughts on how the coalition is thinking about addressing that.
Yeah, so exactly as you said, the idea of carbon leakage is the concern that if one country, one jurisdiction starts cranking down on emissions, makes it more expensive for their firms to emit, then their firms will, the politicians' nightmare is that then their firms shut down and move to other countries that aren't imposing those same regulations. And so the CBAM, the EU CBAM, was designed to address exactly that problem and say, it doesn't make sense for you to shut down in the Europe and the EU and move to another country, because when you try to export back to the EU, we're just going to hit you with the same regulation, the same cost. And so in an ideal world, we do not have any leakage because we're all kind of operating under a similar policy architecture. And that my dream vision of something like the coalition is we evolve to that ideal world. It's going to take some time to get the laggard countries into that vision of the ideal world. But I think like the more we can do to make it painful to stay out of the coalition and attractive to be in the coalition, the more, I call it like this virtuous flywheel, right? Like the more countries that are in the coalition, the more it looks just kind of silly to stay out of the coalition. When I was in DC, someone said to me, like, the most compelling reason for adopting a policy is it looks stupid not to adopt a policy. And so if you're the US and you're exporting to Canada, you're exporting to Mexico, you're exporting to the EU, and every time you export, you are paying a carbon price, but you are writing the check and sending it to Ottawa or sending it to Brussels, sending it to Mexico City, that looks pretty stupid, I think. Because if the US were to adopt its own carbon pricing system, then it's not sending checks. And the logic is that it's industry, because it's exporting to the more and more countries that its industry exports to, the more and more places it faces this border adjustment, the more and more checks it's writing. So I don't know. I mean, that's the optimistic narrative. The pessimistic narrative is that we kind of devolve into two worlds. There's a world where countries care about climate. There's a world where we're doing drill, baby, drill, and they trade with one another less and less. But I do think, when I was in DC, I learned the term hope casting instead of forecasting. So my hope cast is that we don't get to that world. And I will say, I was just in DC on Wednesday. I think there is recognition, for instance, that climate change is affecting affordability. People are seeing increases in insurance prices. They're seeing increases in energy prices because the hurricanes and the tornadoes wipe out the energy infrastructure. So I'm maybe hope casting, maybe slightly forecasting that the US will get to a better place. Yeah, hopefully pretty soon.
Thank you. We'll take one last question.
Yeah, so I guess there's the costs of going net zero, obviously on like the supply side. There's also, I guess, the cost of failing to go net zero or increasing carbon emissions in terms of how those relate to like increased natural disasters and things like that. Do you think sort of like the economic like effects of these two should be entangled at all in terms of like a policy aspect? Or do you think that we should sort of treat them as two separate entities?
No, I think in the economist ideal, we want to spend as much on mitigating carbon as it's costing us in terms of the impacts of carbon. So that helps us think about, we might want to think about going beyond net zero, right? And having net negative emissions because the effects of climate change are so bad. I think we need to have measures of both of those, and that should, in an ideal world, inform the policy positions. That said, the calculations that are out there now, there's something called the social cost of carbon, and it's much, much higher. We're not at the point where those two things have met, and so I think everything we can do to increase policy stringency is good for a long time. We're not at risk of like overshooting on policy stringency yet. Thank you.
Thank you so much, Katherine. And now, next up, we'll roll right into our next set of pitches. So next on deck will be Aeropod. We have the founder joining us virtually, and we also have a team member here in person for Q&A. Thank you so much, Katherine. Now, next up, we'll roll right into our next set of pitches. So next on deck will be Aeropod. We have founder joining us virtually.
Go.
Hi, Lou. If you could just give it one more minute. We're just waiting on 2 more judges to come back, but good, you're all set. Have a team member.
Go. Sorry, I don't have any audio feedback. Am I good to go?
Yeah, you're good to go. Thank you, Lou.
Okay, awesome. Just got some feedback. Okay, this is Aeropod, and we're leading the regeneration of humanity's most important resource. Soil is alive, but decades of intensive farming practices, like tilling and plowing to break oxygen-starved soil open, and spreading chemical inputs like fertilizers, have killed the life in soil and have left 40% of global soils degraded, expected to reach 90% in our lifetimes. But 95% of global food production still depends on soil. No soil, no food. Farming isn't built for the future, and climate change is making things worse. Last year, the UK experienced its second worst harvest year ever recorded, with extreme weather accelerating compaction, preventing machinery use, and causing crops to rot. And the farmers we've spoken to around the world make it clear we're heading straight for a global food security crisis. Now, regenerative farming offers a way out, and governments globally are pushing for it. But it can take up to a decade to rebuild soils, during which yields are lower, and farmers can't afford to wait. So we need a bridge, a climate-resilient way to rebuild soils without sacrificing immediate yields. And through our research at Imperial, that's exactly what we've built. Aeropods are nature-activated capsules, and when triggered, they autonomously aerate and biologically enrich the soil, breaking through compaction without harming soil. It's quite literally groundbreaking. So how does it work? Well, Aeropods are designed to respond under heavy rain and soil compaction pressures, key oxygen stress events, and this is enabled by proprietary layered technology. You need about 50,000 Aeropods per hectare, and lettuce has about 1 million seeds per hectare for comparison. And so with thousands of these tiny tractors working underground, we're shifting the focus from heavy machinery and chemicals towards innovation that prioritizes the physical and biological health of soil, which has been proven to naturally optimize soil chemistry on its own. Firstly, they're designed to be drilled alongside seeds at the beginning of the season, and at an 8 mm diameter, they are compatible with standard planting machinery and allows for flexible integration into existing farming practices. They're also designed to be time staggered, meaning that they're able to provide continuous aeration all through the season. And after activation, they fully biodegrade, breaking down to improve soil health over time and reducing fertilizer dependency. So Aeropod enables something agriculture has never seen before: continuous in situ safe soil aeration at field scale, instead of blunt force disruptive episodic tillage. And in our results, we've seen improved water infiltration and aeration of more than 500% compared to controls. But what does this mean? Well, continuous aeration or autonomous aeration means a whole host of autonomous benefits for plant growth and the microbes and microbial life in soil, leading to 20% yield increases in high-value crops like lettuce, potatoes, and tomatoes, which are initial focus crops. And the best part, we do this at a 60% lower cost from day one, no payback period. And this is because by simply planting aeropods alongside seeds that you were planning to plant anyway, you're eliminating labor, diesel, machinery, and inputs related to tillage. And this means that with aeropods, the chances that farmers can now, in the UK, can transition to more regenerative methods of farming go up to 70 to 75% from today's 3% currently converted. Aeropod's potential impacts are global and massive. And if we look at the environmental impact, by reducing the CO2 from diesel and the soil organic carbon that's caused by breaking open the soil, we could save about 3 tons of CO2 per hectare per year. And this doesn't include soil's carbon sequestered from improved soil health. So this means if 10,000 average UK farms of 900,000 hectares adopted this over 10 years, that would lead to 14 million tons of CO2 saved, which is the equivalent of taking 4 million cars off of the road today. And that 9 million hectare figure represents just 0.006% of the global arable farmland, that 1.5 billion hectares worldwide that aeropods could serve. And aeropods also improve water infiltration, which reduces fertilizer runoff. Healthy soils are also the world's largest biodiversity hub and carbon sink. And reducing fertilizer usage also reduces emissions associated with fertilizer production. So if this is all great, why hasn't it been done before? Well, although the benefits of continuous aeration are well understood, locally validated in science, no technology has ever made it possible at field scale, making it effectively infeasible in commercial agriculture, at least until today. Our patent-pending technology is the only kind to make this possible for the first time ever. Aeropods outperform existing methods on every single level. Now, soil degradation costs UK farmers over £1 billion annually, and we're starting here, where regulation and strong momentum towards regenerative farming create perfect timing to scale fast, before we move to the EU, US, and China. Our sum is around £150 million, and it's based on our estimates of serving approximately 1,500 average farms within 5 years. And with a significant cost and yield incentive, we're extremely attractive to farmers and distributors, so we sell through 2 key channels. Our primary business model is through ag distributors and retailers. We're able to sell Aeropod per hectare through established ag distribution channels and supply chains, allowing us to reach farmers at scale. And they need Aeropods every season, providing recurring revenue. Long term, we'll license through our patent to accelerate global deployment. Secondly, the soil value chain. So because ag has tight margins, and based on my experience working in ag innovation, scaling quickly is the name of the game for success. So our strategy is to sell Aeropods also through large organizations like food retailers, supply chain actors, and enterprise buyers related to the crops that we're working with. And these organizations are actively looking for solutions to reduce emissions down their supply chains and provide direct access and influence over large-scale agricultural networks. We've already secured some traction on this front. To dig a little deeper into the unit economics, we're able to outsource manufacturing, which provides a low capex burn. And this means that our cost of goods is just about £80 per hectare, and that allows us to produce the 50k Aeropods that we need per hectare at a 40% gross margin. So we see Aeropod as a market disruptor. Our team consists of passionate innovation design engineers with experience in ag innovation and materials design engineering. I have experience working in ag innovation, contributing to R&D, product management, customer discovery, and this was where I personally experienced farmers highlighting these pain points over and over again before I finally decided to do something about it. Ocean grew up around farmers in China from when he was a baby and saw personally his family experience extreme weather, wiping out all of their efforts. And we met at Imperial and co-designed Aeropod together with a wider research group. We also have expertise in microbial research and climate business innovation, represented by Paida and Stephen. And our advisory board consists of industry connectors, agronomists, soil science PhDs, farmers with over 150 combined years of experience in our space. And the awesome thing is that we were able to do is even our business advisors are also soil science PhDs. One of our advisors has founded and taken his own company, our company, from early prototype to market and acquisition. That's Dan. So we co-created Aeropod with over 25 farmers and ag experts to fit perfectly into their existing workflows. It was very co-designed. And since our proof of concept, we've had Aeropods on sites in Lincolnshire and have also been at and won at Imperial accelerators. We've also won several awards, representing Imperial in Vienna, representing Europe in Japan. We've also made quite a splash in the news. It's always a bit cringe adding that one in. We're currently Terra 4 with a 20+ growing global waitlist that represents about £234,000 in potential value. And we've got every single stakeholder needed to make Aeropod happen on board. So what's ahead for our commercial roadmap? Well, we've been hard at work on the commercial side. We've secured trials with one enterprise, 2 paying farmers, and agreed initial pilots with 2 distributors, one in South America and one in the UAE. But there's a gap. The climatetech validation valley of death. We're seeking the 100K prize to set up our pilot supply chain to also handle sourcing and production, as well as process optimization to make these pilots happen. These pilots will allow us to scale up our current evidence, and we'll use them to validate our savings predictions made from our cost models and show Aeropod scalability across different soils and geographies, which will unlock contracts with distributors. And these data points are the key inflection points we want to hit before we raise our first round, and to do so at a good position and leverage later this year. We're also working hard at securing other enterprise and distributor LOIs pre-raise to further strengthen our position and round. Now, even if we change our behaviors today, we'll still have 100 years of climate change effects ahead. So let's future-proof our most important resource with groundbreaking innovation. Thank you. Side note, I can't hear a thing, so if someone can unmute.
Hi guys, it's Ocean, CTO of Aeropod here to answer some questions. So yeah, happy to take a question now.
Hi, thanks. Can you talk a little bit about your IP for this?
Oh yeah, so the Aeropod IP is fully owned by us, and we've done we're currently patent pending and already done a very deep search about this previous technology, and it hasn't shown there's no such. Our technology is first of kind. This technology and has no any other similar technology in this world. Yeah.
So have you applied? What's your status for patent protection or trade secrets? What's your protection?
Oh yeah, so our IP mainly consists of. Oh, hi Lou, do you want to add something? So first of all, our IP consists of the entire structure of the Aeropod itself, and second part is how we produce Aeropods. So how we produce Aeropod, we're gonna outsource the manufacturing, but we're gonna outsource to those manufacturers who has no shared interest to our technology. For example, because Aeropod is like layer technology, and we benchmark the manufacturing against to like the candies, the chocolates, so they don't have any shared interest to us. So that allows us to protect our IP. Yeah.
I'm curious. How much evidence have you collected that it works? Do people believe that it will have the impact you claim it will have on the soil and in yields and so on?
So we've shown, like, the Aeropod is co-created with like 25 plus farmers. And currently we've done a lot of like the soil tank test, and all of them like works really good in this just soil tank. But we're gonna have 2 pilot trials in May to scale up test in real condition and to see whether it will work in the real world. Do you have anything to add on?
Did Lou hear us? Does she want to add anything?
I think there might be some delay, but I guess, yeah.
I had a question, maybe if it's going to catch up. You talked about the 2 channels, your go-to-market channels. The second was about buyers looking to reduce emissions down their supply chain, and Lou mentioned specifically that you've secured traction on that effort. Can you speak any more about the traction, perhaps not naming names, but what kind of signals have you seen from that second market?
Sorry, could you repeat your question?
So there's B2B
There's
to C.
a lag, sorry, in the,
yeah.
So I don't think I can, but if I were just to add something.
Yeah.
Um,
I had a second question. This is going to catch up. You talked about the 2 channels you go to market.
Oh.
B2B to C.
Okay, I think I can add something now because I think I can just go through audio. They said they fixed it. Okay, so I was just gonna say that, yeah, Ocean had essentially said the same thing. So we've been doing a lot of rigorous sort of greenhouse and soil tank testing for now with Imperial Silwood Park and Rothamsted Research, which are leading institutions in the UK. And we've gotten a lot of results that show that Aeropod's water infiltration and aeration improves. Aeropod will improve these by up to 500%. So it's a matter of scaling that up. And that's, those are the pilots that we have next to do in May, like Ocean was also saying. So yeah, I hope there isn't a delay in my answer.
Sorry.
Can you hear us?
Regarding the distribution partners that you're working with, do you have like shared
Yeah, I can
economics
hear.
or revenue share or something like that? How does that work?
Could you just repeat your question? Sorry about that.
For the distribution partners that you have, do you have revenue share with them, or how do you incentivize them to share your product?
Currently, we're talking like still on the collaboration progress with them because we haven't like reached that stage at this moment. But we're talking with them too, like because for those like distributors, they have, for example, in the UK alone, they have very strong like regulatory pressure from the government and also the market momentum, like the market pressure as well. So there's like actively seeking for solutions that can reduce the emissions and also increase the farming's resilience. And that's their goal. And here we are. We tell them we have the solution to help you to reach that goal. So we hope that we can go through their farming networks. They have a very strong farming networks and have a huge influence over those farming networks. So we can accelerate our adoption and also like increase the the penetration and increase the farmers we can reach out to at the very beginning. Yeah. Hi, do you have any other questions? I think she has some delay, so you have to like see all the scripts.
But for this one, we're going to just wait one more minute for the live to catch up, so that should be a question.
If you have any question, I'm happy to take any questions. Yeah, I think it's the next.
Okay, I'll try to answer, but I think there is a delay as well.
Yeah.
But I think the question was around our commercial roadmap and sort of where we're going from there. So a lot of what we've been doing so far has been sort of preparing for our pilots, and how we've been preparing for those pilots have been more through trying to essentially swap out the materials we used before for materials that are already certified for soil use and already have sort of good regulatory approval for, yeah, they already have, sorry, I can hear myself. They already have good approval. So essentially we can bypass the regulatory times, because a key thing about ag is, you know, the regulatory times are really important. If we can't get that sorted, then it doesn't quite match with some of the funding schemes that we're looking at. And then the final thing I was going to add as well was that for our funding route as well, the other commercial aspect of it. So what we're looking to do is to really validate a lot of stuff before we raise, ideally, because with ag, the funding doesn't really match up, or the validation doesn't really match up well with VC funding. So ideally, we would do a lot of our proof points with the pilots that we're having today, so that we can then raise VC funding. Because when we raise VC funding, scaling is going to be sort of the name of the game there, where in ag, you'd want to sort of scale really quickly at smaller margins. So we want to optimize like a lot of stuff around our supply chain and around sort of the cost savings projections, as well as the scalability across crop types and soil types and geographies. Hope that came through okay.
Thank you.
Thank you all for your patience with the technical issues. We're going to be messaging so that hopefully the founders who are joining us virtually will immediately get your judging questions. But for now, we're going to move on, and our next pitch will be from Fitsol. So Fitsol, we're ready to go.
All right. Okay, I would imagine that you can hear me. But let me just make sure we get the. Okay, perfect. Good morning. Let me start by apologizing for not being there in person. I was born in Iran. I know, great timing. And given the current circumstances, it has been very difficult to get a visa. But anyway, so I think we have gathered here today to celebrate innovation and see how we can work together to save the planet. So let's get to it. I'm speaking to you today from our pilot fabrication facility here at the University of New South Wales, Sydney, Australia. This is where the original solar cells were first developed, and our lab is very proud to carry that legacy forward. We hold world record across almost every single emerging and upcoming solar technology. And our company, Fitsol, is a spin-out from this very established ecosystem. In the next few minutes, I'm going to share with you what we believe is going to be the future of renewable energy. And this is a very relevant timing with the conflict in the Middle East, what we have seen in the energy markets. And this is a very important lesson that we have learned, that our energy infrastructures are very centralized, and that makes them also extremely fragile. With just one choke point, and its effect will ripple through our global economy. Now, the irony is that we have access to an inherently decentralized source of energy, and that's our sun. But the fact that we have, the way we have deployed it at scale, that's not really decentralized. So a few weeks back for the semifinals, I was in Singapore, and this again tells you another example of why we haven't learned our lessons. Singapore obviously is a very small city-state. They don't have enough space. So they are now funding this project called the Sun Cable, $35 billion. The idea is to generate electricity in the Australian outback and pump that physically using a subsea cable to Singapore. Now you can see where this could go wrong. This is not the Strait of Hormuz, but you still have one choke point. If someone drags an anchor 2,000 kilometers offshore, you don't send Steve in a van to fix it, right? The whole system shuts down. So for the past 8 years, we have been working on a new technology to see how we can make solar truly decentralized. And we believe that every building has the potential to become a green power plant. Now, in order to understand why we need that, we need to talk about something called urban paradox. As cities grow, buildings get taller and taller, but their footprint essentially shrinks. The rooftop is tiny, and that's super crowded with the HVAC system, motor lift, water tank, and whatnot. At the same time, you look at the vertical real estate that a building has. Our estimate is that globally there's about 100 billion square meters of glass. That's the size of a country, South Korea, and it's just sitting there passively doing nothing. And we believe that buildings need to be part of the solutions because they're responsible for 37% of all the greenhouse gas emissions. We want to turn that liability into an asset. There is already something called the building integrated PV based on traditional silicon, which is opaque, so it blocks your view, but also costs a lot, about $1,000 per square meter, because you need to structurally modify the building, you need to bring in scaffolding, you need to bring in crane, a lot of disruption. It just doesn't make sense. It's not scalable. That's why you don't see it on every building. We are doing things differently. We have developed this ultra-thin peel and stick solar panel, and it's see-through. It's just like a screen protector for building. You put it simply on the building, zero disruption. You can have your board meeting. You're very lucky because we have some prototypes now, latest prototype coming out of our facility just now. I'm not sure if the picture is clear, but essentially we have here different levels of transparency and tint. You can see it's highly transparent. And we have neutral gray color and goes all the way to something we call the golden hour, like a warm tone. And as you can see, ultra thin, flexible, you can just peel and stick. You can see it right here. So we believe this is going to change how we deploy solar all across the planet. And the best part, the energy that this produces is not a gimmick. This is not greenwashing. It's a significant amount of energy, 100 kilowatt hour per square meter per year. That's half of what you get from a rooftop solar. Remember the urban paradox. We have 20 times the real estate. So in terms of absolute energy, we end up generating even more energy. Integration is very important. So the wires will run in the peripheral edges very close to the frame, out of your view. That goes to a combiner box through an inverter and plugs in right into your electrical system that is existing in the building. So why now? Why today? Professor Wolfram was just talking about this net zero target. Everyone is talking about 2050, and I don't know what's so special about this number, because the fact is that 95% of the infrastructure that is going to be in 2050, they're already today. So if you want to wait for new construction projects to save our planet, we will miss the window, pun intended. And you add to that all this ESG mandate. Now in New York, you have the local law 97. You have the push from the Fortune 500 companies. They all have net zero. You have a new driver, the AI, that increases the demand for energy. And that's where the retrofit market comes in. Yes, the BIPV, despite all its limitations, is a growing market, $250 billion. Retrofit market, massive, $4 trillion. So let's look at the impact. We want to give you some numbers. So here in Australia, for every square meter of our product that we install, we save 80 kilograms of carbon dioxide every year. A bigger picture, let's look at the three iconic buildings in Shanghai financial district. These three buildings together, they have 250,000 square meter of facade. That's the size of 35 full-size soccer fields. We put our product, 25 gigawatt hour of energy every year, enough to power a small town. 375,000 tons of carbon dioxide saved through the lifetime of the solar panels. That's 0.7% of Singapore's annual emission. It's huge. And all of that for less than $100 million. Compare that to the $35 billion for the Sun Cable project. So the environmental aspect is great, but at the end of the day, the asset owners, they care about the money. And here, this number, 10 cents per kilowatt hour. This is an important number. This is the levelized cost of energy for us to produce the technology. So this is very cheap, actually cheaper than the grid anywhere in the world. So despite that, we have software level margin, 67%, and yet we are 2/3 cheaper than traditional building integrated PV and slightly more than low E film that they already put on the building to reduce the thermal load. And that's purely passive, it doesn't generate energy. So go-to-market is simple. We start with asset owners that also operate the buildings, think university campuses, hospital, governments. Stream 2 is commercial buildings. So we work with utility and energy companies to cover the upfront cost. Number 3, you have the glass manufacturer. So instead of having low E film, which is passive, you can integrate this at the very beginning on the glass itself. So you have probably heard of solar windows before. What makes this different? Yes, you have organic PVs, can be highly transparent. Their efficiency is very low because they only absorb near infrared. You have cadmium telluride, CIGS. They both use rare elements. So there is a fundamental limit of how much we can make that. And they're also expensive. They're not transparent anyway. And you have the darling of the news media, perovskite. Here at UNSW, we hold the world record for perovskite too, so nothing against it. But perovskite at this point, it's the next graphene. Great in the lab, it's not going to last. Anything that involves organic material, you think of a plastic chair that you leave outside for a summer, it degrades, it's like that. And no one wants to change their facade every 3 to 5 years. Perovskite especially, they also have lead. And that's very difficult from a regulatory perspective to get on your building. So what is our technology? It's a completely new chemistry. We broke the world record published in Nature Energy in January. It's a new platform called antimony chalcogenide. It has 10 times higher absorption coefficient than perovskite, 1,000 times thinner than silicon. So it makes it also transparent. And it's made completely from abundant and non-toxic materials. So as a company, we are very young. We just got the IP assigned exclusively from the university. This year we have about $1 million that we are aiming to get from a non-dilutive funding to do our pilots. By 2028, we will have 50,000 square meter production capacity. By 2031, we want to quadruple that, generate 200 million, and save 100 tons of carbon dioxide every single day. And in order to achieve that, we are going from vacuum-based semiconductor manufacturing, which is that round thing you see that's called sputtering, to a solution-based processing. So every fabrication line is going to be extremely cheap at $2.5 million. So I'm trying to be mindful of the time. It's almost 2 a.m. here in Sydney, and I think I need to get some sleep. I know I'm going to dream about a future that people will not go to wars over energy resources because energy is going to be everywhere. It will be right at your window. It's going to be highly resilient. It will be democratic. It will be decentralized. And we believe that the power plants of the future are right at your window. Thank you very much.
Who's asking the first question?
Okay. All right, thanks.
All right, thanks.
Hold on. So we're thinking, I have Alireza on.
So he can ask the question right now. We just came up with a solution.
But there's okay.
Try asking the question.
Okay.
Can you hear me?
Okay. Say that again.
All right. Can you hear me?
Yes, I can.
All right.
Fantastic. All right. I'm going to try three questions, so I only have to talk once. First of all, can you talk about, you're putting this over the facade of buildings. What's the wiring involved, inverters, installation, logistics, and cost? Second question, you said world record efficiency. What is that efficiency? And third is, another challenge with windows in buildings is lack of insulation. Does your solution provide any insulation benefits?
Yeah, thank you very much. I tried to remember all those questions, very good ones. So the first one, in terms of the cost. So what I showed earlier, $300 on average. Of course, we have a variable pricing because different parts of the world, they get different solar irradiance, and grid prices are different. For example, somewhere like Dubai, they get a lot of sun, but the grid prices are so cheap. So in order for us to make sense commercially, we have to bring down our prices, and we can't do that because of the large margin. But let's say global average 300. This already includes the other fixed costs, like the balance of system. You have the inverter, you have the combiner box. What is not included in this is the variable cost, and it's the same model as if you've ever bought an EV charger for your home. You pay for the device, and the installer comes in based on how many meters of wire they need to have. They will charge you extra for that. And it's the same thing here. We have installation partners. They will take care of the deployment, and then they can charge extra for that extension of the cable. But 300 is the base fixed cost for the solar panel plus the inverters and so on. Now, how does that integrate? Yeah, so basically, the solar panels that I showed to you, we have the bus bar at the very edges here. You can barely see them. Very thin wires goes down along the frame, out of your view, and then you'll have an inverter. You have a combiner box because different part of the buildings they get different amount of sunlight, and then that goes into an inverter. Inverter hooks right into the electrical panel of the building. So it feeds the electrical system of the building. Any excess will go into the grid. The other question, I believe, was about the filtering, if I'm not mistaken. So yeah, so low E film, basically a lot of the most new buildings to reduce the thermal load and meet the energy requirements, they have something called a low E film that stops the UV and infrared from coming in. And that's passive. It's essentially reflects it back, or that's wasted energy. We absorb that and turn that into electricity. So the answer is yes. So this works as a protection, but also turns that into electricity. Not sure if I answered all your questions. If I didn't, let me know.
All right. So next question is. Do people want like two questions? One is there an aesthetic impact on a lot of people want to have buildings with views, and it looks like it is transparent, but it's also distorting the view a bit. So I'm curious if there's an aesthetic concern. And the second is around like shadowing, and I get down to New York or here in Boston, there's a lot of buildings where they're just in shade all day. Do you generate electricity without direct sunlight, or is it you really need to be getting the sunlight hitting the facade in some fashion?
Absolutely. Very good questions, and these are exactly what I heard. So when I was in Singapore for the semi-final, I also had a chance to meet the building and construction authority of Singapore. And a lot of the practical things, for example, what you mentioned about the aesthetics and distortion. So the slight distortion that you see here is actually from the polymer on top, And this is something that, again, it's being a prototype. We are still undergoing tests to essentially get rid of that. It has to do with the refractive index of the polymer. So we are experimenting with different polymers that will be attached on top of it. And we're pretty confident that the final product will be very clear. Now, in terms of the aesthetics, yes. So a lot of the commercial offices, half of the rent goes toward the view. We completely understand that. So the idea is to offer something that is aesthetically pleasing. So very minimal obstruction of your view. At the same time, we realize that this is actually not for everyone. So we have a second product, which reminds me, one of the questions I didn't answer from the first judge was asking about the world record efficiency that we have. So currently, the single junction is at 11%. So we are now working on a tandem, which is multiple layer. That can be for the non-transparent part of the facade. That has higher. We are planning to go up to 18%. Also usable for lightweight space PDs and all that. So the next, yeah, I think I covered everything pretty much. Yeah, I believe so.
Thank you. I'd love to hear more about the team. What are the current skills that you have on the team? Who do you need to hire?
Sure. Yeah. So again, as a company, we are very young. So we incorporated the company like 6 months ago, and we were like 4 months negotiation to get the IP officially, it's an exclusive global IP that has been assigned from the university to us. And anyway, we were a spin-out, we were partly owned by the university. So the founding team is basically here, the 3 of us. So Professor Howe is a very well-known global authority in the field of PDs. I'm not going to go through whatever that we have written in the slide, but you can see. So my co-founder, Chen, he's the CTO, and he's the guy who developed this particular technology during his PhD. I'm also finishing my PhD in the same group, but prior to this, I founded 2 companies that are now profitable and doing well. And yeah, so that's the team now in terms of the expansion. So right now we are basically expanding the team primarily on the technical side. So especially I mentioned we're moving to Gen 2 fabrication, moving away from vacuum solution processing. So essentially, if you look at a typical solar cell architecture, it has multiple layers. And we are hiring about like 5, I would say, engineers to work on different layers on these new processes and to optimize them. So that's this year. The long-term plan is that the fabrication lines are highly automated. So every fabrication line capable of producing 100,000 square meter a year, it only needs 4 staff to run. So it's very efficient.
I was wondering if you could elaborate on the customer feedback that you've received so far on the building integrated concept, and then also if there are other kind of deployment embodiments that you think could be explored. I think it's an inherently kind of low efficiency entitlement kind of chemical system that you're working in. But are there other kind of deployment embodiments that would make sense for the technology long term?
Sure. Yeah, of course. So in terms of efficiency, it's actually considered pretty high by transparent standards, right? So 11%. Again, this is on average getting 100 kilowatt hour per square meter per year. That's again half of what you get from a rooftop from something that is transparent. And you can put it on 20 times more surface. You have 20 times more surface on a typical high-rise building than the rooftop. So, but from a theoretical standpoint, this platform, antimony chalcogenide, so silicons, for example, they're now reaching their maximum efficiency of about 25% would be the max. This platform is capable of reaching 35%. Of course, we are at 11. It's a long way to go, and same for silicon. Silicon, it took like 50 years to get there. So, but in our short-term plan, we are working on a tandem. So the single junction from 11 can go to 12 within the next 1 year. At the same time, we are working on tandem, which is multiple layer, will absorb more of the sunlight. Again, same chemistry, because we can change the composition and move the energy absorption. That would be within 1 year to 15%, and then within 2 years to be 18%. And again, when you look at, for example, what they have on space PVs, the ultra thin one, and this is going to be very important now with the orbital AI data centers and all that, because they're going to have massive amounts of PV, and the weight matters, right? The silicon out. They have CIGS, pretty mature technology at about 15%. But CIGS is fundamentally limited by the fact it has gallium and indium, which are rare elements, and China has all of them anyway. So yeah, this is going to exceed that of CIGS. So next, we're looking at the OPEC part of the facade with the higher tandem, and also with the space PVs that need the low weight for launch.
Thank you so much. Next up will be Earth Sprint.
Hello everyone, I'm Ayush.
Hi, I'm Divya.
And we are Team Earth Sprint live from India.
Before I start, let me ask you a question. Did you have rice anytime during this week? If your answer is yes, then I think you should know the story behind what happens after the rice is harvested. Asia every year burns about 100 million tons of crop residue annually, with emissions equivalent to driving all cars on Earth straight for 10 days. But this isn't just an agricultural problem, because these emissions travel into the atmosphere, intensifying the heat and fire events along with the acid rain. And the materials which we build are degrading at a faster rate, because there is a gap between what we build the materials for and what they are actually exposed to. And this gap is widening. But here is a deeper issue. The agro waste which we burn isn't just intensifying the climate stresses and causing the material failure, but we, instead of addressing it by the root cause, we respond by a cycle of repair and replacement, thereby causing us into a continuous cycle of emissions. The aha moment. We had the problems right in front of us, but what about the solution? The solution was also present. It was present in the form of rice husk. Yes, the same rice husk which earlier contributed to pollution was now the key to solving it. Because this rice husk is rich in silica, the same silica which is the core building block of the geopolymers. And this is when we turn to geopolymers. So, what are geopolymers? The geopolymers are a cement alternative. These are essentially a different kind of cement, which gains strength from the reactive silica materials. And with its unique chemistry, unlike the traditional clinker chemistry, it requires a 90% less water for curing. You might be wondering, if the new carbon alternatives are so promising, then is the market moving in its direction? The answer is definitely yes. The companies such as Material Evolution and Ecosem are already scaling from the pilot to the real production scale, with the low carbon materials already used in the projects. And this matters the most because it provides a 4+ billion tons of market opportunity, and alone it contributes to 7 to 8% of the global CO2 emissions. And here is the problem. The difference lies in how it is made. Most of the low carbon alternatives utilize the industrial waste, such as the fly ash and the GGBS, but it poses some problem. It uses the it requires a limited supply, and also a variable inconsistency, and these two things cause the main problem. Instead, agro waste, the Kisan grid utilizes the agro waste, which means that the supply is reliable and there is no need of heavy chemical processing as required in case of the industrial based waste. It requires the ambient curing and a simple process. And here is what it looks like at scale. With 1 ton of rice husk translating to approximately 40 meter squares of flooring. On the farm level, 1 hectare translates to about 110 meters square, and 100 hectares translates to about 11,000 meters square, exactly matching the demand for an industrial facility. And this connection between the farms and the industry is what led us to build Kisan Grid. Kisan derived from the Hindi word meaning farmer, and Grid derived from concrete. Now that we have understood Kisan Grid as a product, let's see how we bring it to life. The process begins with the collection of the rice husk from the farms, and then comes the heart of our process, our reactors. These are our in-house manufactured and solar energy-driven reactor that extract the silica from the rice husk. The extracted silica is then carefully blended with the components and subjected to a controlled formulation, wherein every ratio is optimized in order to get the desired properties as well as durability. Before getting a final Kisan Grid modular units, it is subjected to an internal microstructure development via the heat treatment. But such systems to be requirement for the scalable needs to be capital efficient from the day one, which we addressed with the use of the decentralized units and supported by the patent file reactor system, which is not only high energy efficient but provides a circular economy model due to the use of the agro waste. Here is the market opportunity. With the serviceable obtainable market focusing on the exposure critical and non-structural segment provides a $2 to $4 billion of opportunity. With the market defined, we do not aim to enter the market all at once. Rather, we focus on the exposure critical and non-structural applications, where the repair and replacement is not only frequent, but also costly, such as the industrial flooring and the chemical facilities. As we enter these environments, the impact is measurable. To understand this more clearly, imagine a Tesla gigafactory. If the conventional flooring is used at the rate of $45 per meter square, it costs around $1.1 million. But if Kisan Grid is used for the same, operating at a cost of $17 per meter square, it provides a costing of $0.42 million. So here, the main impact is the saving of $700,000 and at the same time avoiding CO2 emissions of 1,800 tons. And with this advantage, it directly translates to a scalable revenue model. Kisan Grid providing a clear price cost advantage of 35%, operating at a capacity of 1.5 tons per day, scaling to a revenue of $327K per year at full capacity utilization. Here is our journey from the lab to market. We have successfully built and designed our first modular reactor and achieved an extraction efficiency of 94%, along with the provisional patent filed. What you see here is our validation process in action. On the left-hand side is the product being subjected to a compressive strength testing, providing us an impressive result of 20 MPa, which is 3 times the normal brick strength. And in the center is the product immersed in the acid to evaluate its chemical resistance. And on the right, you see is the product subjected to a flame to assess its thermal behavior. Here is what the industrial flooring landscape looks like, with the need for a surface coating and periodic recoating, and the modular system which comes at a premium. These industrial floorings require these things. But Kisancred takes a different path over here. With the durability integrated into the material itself, it provides a competitive cost of $16.7 per meter square. As we scale, we are realistic of the core risk, including the market adoption, which we address with the live pilots and certification. Second, the production scaling, which is addressed with the stepwise scaling and the standardized reactor design. And third, the team bandwidth, which we address with the hiring of materials engineer and operational lead. This is, as we were building the product on the inside, we were curious of how the market reacts. So we have conducted discussions and shared samples with various industrial contractors and partners, and have received a formal letter of interest. This is what our live pilot facility looks like. And this, you see, is the scaling in terms of Kisancred with the use of the decentralized units. This is the capital split with a major chunk for the expansion of production, certification, and pilot deployment. Meet the team behind Kisancred. Ayush, who is the founder and CEO, focuses on the silica and the material processing. And I focused on the binder formulation and the properties. We are also supported by our mentors, including an ex-founder, a professor, and an industrial veteran, who guides us in the business modeling, the R&D, as well as the reactor manufacturing. Not only that, but we are also awarded with grants and supported by some great institutions across the world. This is the roadmap of Kisancred, which stretches over a period of 18 months. Here, I would like to conclude Kisancred not only as a building material in India, but a climate-resilient solution for the global south. Thank you.
Thank you.
Thank you.
Thank you. Great presentation. Can you describe how you're planning to bring the solution to market? Are you kind of selling systems to concrete makers or cement makers, or are you kind of producing cement and concrete yourself?
Right. So right now we are working on end-to-end systems where we are targeting first the industrial floorings. And right now we have manufactured our own prototypes, as you can see here. I'm sorry. Yeah, just a sec. So this is our initial prototypes which we are putting out to the pilots in the companies. For the example, industrial floorings, we have had our initial pilots with petrol fuel stations or areas which are prone to acid and fire exposure. So yeah, these are some of our first prototypes, and we are manufacturing it all end to end. Yeah, if you can see.
So I'm curious.
You said you're doing modular reactors. Do you expect to have these in one centralized facility and bring the rice husk to it, or are you going to decentralize them and kind of sell them to people using them? How do you think about going to market with the thing you're building?
Right. So we are working on both the solutions. The reactor that we have designed is modular, so it can be put on a small truck and it could be taken directly to the fields. And the thing about is that is the way when we extract silica from rice husk, it results in 10x reduction in its volume. So if we are processing 100 tons of rice husk, we are left with only 10 tons of rice husk produced, or the silica extracted enhanced rice husk. So that basically, if I would be honest, it depends on how the CO2 emissions result in the whole process. If we are able to save on the carbon emissions resulting from the transportation, we would be definitely taking our whole decentralized facility to the fields. Otherwise, we also can have it on in the centralized facility where we have a whole production line in place, and we can start from raw rice husk to get the final Kisancred product.
Hi, thank you. Great presentation. I had a question about, you talked about starting with non-structural cement. How does your product eventually compare to, I believe Portland cement is sort of industry standard for cement. So how does it compare to industry standard? And do you have pathway to market for structural cement usage? Like what's the go-to-market plan there?
Right. Based on our discussions with users, what they wanted to understand first is how the product behaves. They wanted to understand the behavior to gain their trust. So we started first with the non-structural aspects. And on that, we have successfully been 3 times more stronger than what non-structural offers in terms of the strength. And for the structural, right now we are midway. So we are still working on research and development R&D process where we are trying to maximize our silica extraction and are developing our own ratios in-house. So based on testing on those ratios, we're looking for about 12 to 15 months of timeline where we reach the structural marks. So the structural mark basically is about 30 to 35 MPa. So that's the 35 MPa is kind of, if you reach that mark, then you're almost eligible to any kind of projects which are structural, for example, houses or load-bearing structures. And right now, currently, we are at 25. 20 MPa is something we are giving out to our users, and 25 MPa is something we have achieved in our lab. So we have some way to go on there.
Thank you.
I'm sorry, I cannot hear if there's a new question.
So what is the biggest risk to using your product?
Risk, as in, for example, if we look at the non-structural aspect, there is no risk. Rather than we are covering the risk which cement or the cement concrete-based non-structural usage styles were not offering, for example, fire and acid resistance. So right now there is no risk. But of course, as we will work onto the structural market, we need to be backed by data of live pilots, and those data and pilots would give us the credibility to have this on ground. But we are following all the standards. We are working with standardized IS codes, Indian standard codes, and the international codes for making sure all products are certified. And they work on the given standards before we are shipping out there in the market. So if you can see the tests that we have done, they all are based on the existing standard codes, and we are getting certified by them.
Thank you so much. Okay, next up is Terra Compliance. Welcome.
Thank you.
Thank you.
Garbage in, garbage out. It's a phrase we're all probably quite familiar with, especially in the age of AI slop, but it's something that I've become more familiar with when I first met Peter. Peter spent nearly 40 years across all aspects of the waste industry, running landfills, MRFs, paper plants, composting facilities, and most recently, he was ushering a handful of Northern California cities through their waste operations.
Hello.
Back in the day, waste data, even in the state of California, where things are normally on the leading edge, was quite simple for him. He ensured that waste haulers picked up the trash after the businesses were generating it, and they made it to their landfills. He wasn't thinking much about the methane emissions, even though they existed there, because nobody had to. Then regulations started being passed, and one bill, if you don't know, is Senate Bill 1383 in California. This is the nation's most aggressive organics diversion bill passed to date. For those that don't know, landfills are the US's third largest source of methane emissions, and diverting this waste is one of our best chances of slowing down near-term warming. Every metric ton represents 0.7 of CO2 avoided. So when this bill was passed, it enacted teams to take action, but inadvertently left Peter and thousands like him buried in administrative work. Just because the regulations existed, teams weren't equipped with the infrastructure to tackle them and make it happen. So Peter and many like him are left flying blind with now being responsible for thousands of businesses, millions of residents, and millions of data points that they don't have ability to actually capture. They're left weeks to months behind and are on the hook for all of this in addition to their normal day-to-day job. So Peter went out to look for tools that might be able to help him and was left with much to be desired. So he did what many of us might do and started complaining to his family around the dinner table. I'm Emily, and I'm the CEO and one of the co-founders of Terra, and luckily for me, Peter's not a hypothetical. He's on our founding team. And around that dinner table was his son, Ethan. Ethan and I were former colleagues where we spent a few years building blockchain and emerging tech infrastructure products, and I come from a background in GovTech at Deloitte Digital. I'm currently now pursuing my MBA at Stanford, and Ethan is a longtime startup operator. So after we heard that some of the incumbents told Peter to be okay with taking 6 to 8 weeks to do something as simple as reset his password, we knew that there was some opportunity here. So we dug in with Peter's network and built Terra, the product that Peter's always dreamed of. We ingest the data from any hauler waste management company to provide teams and customers like Peter a single source of truth and system of record in a way that can layer on the additional data sources that he needs and do their day-to-day operations, all while automating the mandated reports that they need to submit to governing bodies. And we really view that SB 1383 is just the start. On our municipal side for SB 1383, we have some proven traction. We're bootstrapped to date, and since launching our MVP this August, have closed 10 municipal contracts that are multi-year. With our government tech SaaS business model, it's proven and sticky, and we anticipate a very low churn rate. And in doing so, because we aren't like the rest of the incumbents that have typically been born out of services models, the data platform play and flexible architecture that we approach this with is getting market pull. Teams are asking us to do more. Recently, someone like Carrie from the city of San Leandro has been asking what other data sources can we capture for her. We're helping her expand her impact, capturing things like her climate action plan, her stormwater, or her franchise agreements and how she actually interacts with waste management companies, holding them accountable for their impact as well. And beyond just the municipal side, we've been able to identify a much larger opportunity on the enterprise side. By working with waste consultants, we've been able to understand and magnify our discovery process with their extra ears on the ground. They've been pulling us into their enterprise contracts with Fortune 500, Fortune 10, Silicon Valley tech companies, and we were shocked again to see what we were finding. I don't know what's happening with this. So just recently, one of our consulting partners pulled us in with a Silicon Valley Fortune 5 company, and we determined that similar to that password reset that we found out, some of the most sophisticated companies were operating 6 months in the past. So they brought us in, instead of shelling out what we found millions of dollars a year for consultants to literally parse data line by line, where they're leaving ESG reporting, cost decisions by the COO all out on the table. So we've engaged with an SOW with them to start first on solid waste, focus on diversion, ESG reporting, but now growing into their construction and demolition and other waste streams just of last week. So they're feeling the pressure as well, just like how we started on the California organic side. We've actually found that our wedge and foothold in this market has proven quite impressive and important, as most of these enterprises also view California as their starting point. So with these Silicon Valley companies that we've been engaging with, they view these corporate campuses as just the start, rolling out soon after to distribution centers, data centers, retail, and globally across their footprints. Each layer that we've been building is additive, but because we've approached this from a modular architecture, we've been able to add these things on without increasing our overhead. The business model is growing over time, and we've been able to expand not just outside of California to other state mandates, but again to the enterprise side, and are continuing our discovery there with both corporate but also waste management companies. And we're moving fast. Just since a few weeks ago when we were on this stage for the semis, my co-founder Ethan's gone full-time. We've brought on another full-time engineer, and I'm gearing up to do the same when I graduate in a few short weeks. We're excited about what's happening here, and I've kicked off also other conversations with waste management companies in the Northeast out here and chemical manufacturers. This capital takes us with our proven execution to the next phase. We're hoping to continue to close our active pipeline that we have and really build out the tech around this enterprise offering. While these initial pilots are getting scoped, we're determining the repeatability around them and what that offering really looks like, along with the willingness to pay. This may include an additional engineering hire and bringing my other co-founder, Peter, online as well. So we would love your support in helping make waste compliance climate action. And outside of capital, we would also like anyone in the room who has introductions across these spaces, whether that is waste management executives, ESG and EHS leads at these enterprises who may want to get in touch about making their data more actionable. Thank you.
So thanks for that. So a couple questions. So you talked about markets beyond California. What would be driving demand in those markets beyond California? That's the equivalent of the California bill. And the other question is, your software and your system, what provides you kind of a sustainable competitive advantage? Why wouldn't, other folks see this opportunity to help customers meet this challenge and be able to develop similar software?
Yep, thanks for the questions. The first one in terms of the state mandates. So there's already 11 other states that have similar mandates as of 1383. But what's been interesting over the past few months is we're seeing that it's beyond the regulation of the literal state mandates, and more why we're also interested in this sort of enterprise play. What can this data do outside of just compliance to enable your teams to make better decisions when they're historically operating months in the past? And then as for your second question, can you remind me what you asked?
Sustainable competitive advantage.
Mode, yep.
Why are you different and unique from anyone else trying to solve this problem?
Yeah, so we started to simply disrupt the incumbents that were after the 1383 space. And while we did that, because we approached it more from the tech side and doing so in a flexible way, we've been able to actually expand our capabilities, whereas some of these teams either focused purely on 1383 and their rigidity did not enable that expansion. And with regulations that change day in, day out, they weren't able to keep up. And then in terms of these other players, because they're services providers first, tech second, many of these other partners don't want to work with them as it is directly in competition. So we've been able to benefit by being consultant agnostic and expanding our reach. And then in terms of where we're playing upstream now more, that area hasn't been as tapped. So there's these historic legacy billing systems that we interface with, and then there's the eventual reporting systems where you might think of like a Sphera or a Watershed, but this middle ground here is still quite untapped. And because we're starting later than some of these older players, we benefit also from the software competitive and compounding advantages of building in 2026 versus years past.
Thanks, Emily. Great presentation. Can you talk about what you see as the contract value that you're able to get in this scope, and your sales cycle, what you think it'll take to sell, and the value also that provides to the customer?
Yes. So in terms of the municipal kind of product one offering that we have in the market, the ACV right now is around 35 to 40K. And we're already seeing the upsell that's working. So we have a few quotes right now in late stage procurement where we're nearly doubling the offering. We're kind of playing with what sort of add-ons they're going to actually purchase. And we're normally able to do those at 3 years, 5 years, sometimes paid up front as well. And then on the enterprise side, we anticipate the low end being around 250K ACV, but are still scoping those things out with pilot. And then in terms of the customer benefits, predominantly on the municipal side, the buyer is the city staff member, someone from the public works department or city manager. So one, compliance and kind of insurance policy for being compliant. Regulators are able to log directly into Terra. And then two, major cost and efficiency savings. They're no longer needing to hire in-house to create workaround tools or also purchase something that doesn't really work and still hire a consultant.
What are your costs to deliver this? You know, if you've got a 35K ACV, is it effectively zero marginal cost SaaS, or do you have some amount of hand-holding or systems you have to manage?
Yeah, so we've been able to dramatically reduce that over the first few onboardings that we've had. It's always been quite high margin and pretty repeatable processes, typical SaaS engagement. And we've now sort of refined how to automate that better, how to ensure that they feel trained and equipped due to change management reasons and things like that with these teams. But yeah, the cost to deliver is quite low and it's very repeatable.
Thank you, great presentation. Two questions. One, you mentioned 10 muni contracts that you've already closed. Just curious about how those came about and sort of the sales efforts there. And then the other, not meant to sound like silly, but Ethan and Peter have the same last name, I think. So around that dinner table, is that like, what is the dynamic there? I'm just curious about the founding 3 team members.
Yeah, for sure. Thank you. So in terms of how the sales came to be, we're competing in very typical way of winning GovTech contracts. So we have sort of a few different channels. One is traditional RFP measures. One could be something where folks are able to sole source if we're able to show our unique value, or sometimes it's a 3-bid process, and sometimes we're able to really leverage through consultant networks who then recommend us, and then the buyer chooses us. So ours have actually been a combination of all of those methods. And we've had great luck also attending industry events and things, boothing at conferences, really getting our name out there as it is such a trust-based industry. And then, yes, they have the same last name. It's a father-son relationship. And luckily for me, that's kind of how I got involved due to great working relationship with Ethan back in the day.
Questions?
No.
All right, thanks, Emily.
Thank you.
Thank you. Next up, and the last in this block, is Isosphere Technologies.
Hi, we are the founders of Isosphere Technologies, and we want to make decarbonizing the chemical industry economically viable. So the chemical industry is still heavily reliant on fossil carbon and is responsible for around 2 gigatons of CO2 emissions per year. So a lot of companies and startups are actually racing to get that CO2 out of the atmosphere and try to capture it. But the question with that is, what happens with all that CO2? So a lot of it is actually stored underground and sits unused. So that is very cost intensive and also very space intensive. So yeah, and also the business models. The business models are reliant on carbon credits, which is quite an unstable business and doesn't create any new value. So another idea is basically to take the CO2 as a building block and create new chemicals out of that. The problem with that is that it's actually taking a lot of energy. It's very cost intensive as well to make that. So if you actually want to close the carbon cycle, you need something else. You need an economic engine to finance that whole system. And that is what we want to do. So we took a closer look at the CO2 molecule and on an atomic level, and realized that the carbon actually consists of 2 major isotopes, carbon-12 and carbon-13. And carbon-13 has a really high value because it has very interesting physical properties. So you can see it in MRI, and that makes it very interesting for pharmaceutical and medical applications. So it can be used in drug development to determine how a drug behaves in a body. So if you have a new medicine you want to bring to the market, you can label it with carbon-13, which then acts as a tracer, and then you can determine how it is absorbed, metabolized, distributed, and excreted. Carbon-13 can also be used in medical diagnostics to determine what pathogens you actually have in the body. So some pathogens like bacteria can actually metabolize some chemicals into CO2. So if you label these chemicals, you will actually breathe out carbon-13 labeled CO2, which can then be measured. Also, a very new application for carbon-13 is actually medical imaging to determine how a tumor behaves in the body. So normally, if you have a tumor in your body, it looks a little bit like that, and to the untrained eye, you cannot really see where the tumor is and what it does. So if you use carbon-13 labeled compounds as tracers, not only you can see better where the tumor is, you can also determine in which direction it grows and how active it is and how aggressive it is. And because of all of these really important applications, carbon-13 has a really, really high value. So we want to use that as our economic engine to finance closing the carbon cycle. The idea here is quite simple. So we take CO2 and we separate the isotopes, and then carbon-13 will be turned into label compounds for the pharmaceutical and medical applications. And to give you kind of like an example how big the difference in value is, yeah, so for example, if you take methanol, this is sold at around €1 per liter. On an industrial scale as a feedstock chemical. In comparison, if you label that with carbon-13, it is sold at €190,000 per liter. So that difference is really vast, and that's what we want to use. So we want to take these ultra-high value carbon-13 labeled compounds basically as to finance the establishing of our technology. And then, basically this is quite a small margin market, so we want to take it basically as an entry market. There are like around 500 kilograms of products produced per year, and then after we've established our infrastructure, our processes, we can actually go into bigger markets like the fine chemicals markets, where around 1.5 million tons of products are produced per year. And then eventually you can also expand into the bigger markets like feedstock chemicals, where around 800 million tons of products are produced per year. So how is carbon-13 produced right now? Basically, there are not a lot of producers globally because it's quite difficult to separate the isotopes. Especially if you see here in Europe, we don't have any producers of carbon-13 because historically our supplier was Russia, but due to the geopolitical constraints, it's not a supplier anymore. So we have a growing demand all over the globe and also in Europe, but a reduced supply. There are some suppliers in Asia which are supplying quite on a low scale. So basically there's one big supplier, which is actually here in the US, which is responsible for the global supply of carbon-13. They're called Cambridge Isotope Laboratories. And because they're the only supplier, they kind of have like a monopoly on the production of carbon-13, which is quite difficult. Because they have the kind of monopoly, there was not really an incentive of changing their technology. So what they're doing, their technology is still based on a technology from the 1950s, so which is based on carbon monoxide, which is a fossil carbon feedstock. And carbon monoxide is produced via steam reforming, which is via steam reforming, which is responsible for around 150 million tons of CO2 emissions per year. The technology they're using is called cryogenic distillation, which uses up a lot of cooling liquid and is also very energy intensive. So our approach is really different. We developed a new 3-step process, which starts with a duct unit, which you can see here. And then the next step is our isotope separation technology, where we leverage chemical selectivity. And that is way more efficient than the technology which is existent right now. So we can actually reduce the plant size needed to separate the isotopes by 95%. And then after we've separated the isotopes, carbon-13 will then be turned into the carbon-13 labeled compounds, and carbon-12 can be turned into other fine chemicals. Our business model is quite simple. So we are producing carbon-13 labeled compounds, which we then sell to pharmaceutical and medical companies. So these range from really simple building blocks to more complex building blocks. And the more carbon-13 that is incorporated in these compounds, the more valuable the compounds are. In this graph, you can see our profits we can make by selling these, and you can see the difference between the green, yellow, and the blue graphs. So that means if you still have to source carbon-13 externally, you actually don't make any profit for really small molecules. And by producing the carbon-13 ourselves, we can actually leverage all the value. The market size is around $15 billion US dollars for the isotope market globally, around 2.4 billion for the European market, and we want to get into the European market at around 10%. It is expected to grow 9% annually, and the market is projected to reach $32 billion by 2032. But that is not everything we want to achieve. That is just how we want to enter the market. And then in the end, we want to actually go into the feedstock chemicals market, which is around 800 billion US dollars. And why we want to do this, it's because it has a way bigger impact what we can achieve here, because that is actually responsible for around 1 gigaton of CO2 emissions per year. So our team consists of my co-founder, Mark, who did his PhD in the University of Bristol, and who was a postdoctoral researcher at the Technical University of Munich, where I'm currently a postdoctoral researcher myself. And we've been able to gather a big round of supporters over the last year. So we're supported by Professor Harald Klein, who's at the Process and Plant Technology in Munich, and we also have a consulting CFO on our side. We're supported by the Venture Labs, which are also here today. So thank you so much for supporting us. And we've gathered around 13 LOIs from academia and industry so far. So in academia, we are supported by the Helmholtz Center, the German Cancer Research Center, and several universities. And in industry, we are supported by AstraZeneca, Sanofi, Boehringer Ingelheim, and Roche, to name a few. We've also achieved some milestones over the last year. So we got into the startup incubator, the Venture Labs, where we built up our labs, and which are the foundations of what we do now. We have finished the startup accelerator. We got our first collaboration offer. We did extensive customer outreach, and in the beginning of this year, we got our first funding. Right now, we are preparing for a government grant in Germany, which is called Exist. And by the end of this year, we want to incorporate the company and start our first sales. By the end of next year, we want to have our first enrichment pilot plant. And by the end of 2029, we want to have a fully operational process plant. Yeah, with the money of this prize, we want to basically further develop our prototype, and to be a bit more specific, we want to get our DAC unit from around 90 cubic meters per hour to 1,000 cubic meters per hour. We want to scale up our process for the separation unit from milliliters per hour to liters per hour, and we also want to be able to go from gram to kilogram scale for our products. Thank you so much, and we are happy to answer questions.
I'm curious about the techno-economic analysis of the work you're doing to extract, the carbon-13 and carbon-12, especially when you look beyond the isotope markets, but towards kind of feedstock markets.
Yeah, so that's why we're entering the market where we are in the isotope market, because direct air capture is really like a tiny cost compared to the separation of the isotopes. So with developing the direct air capture and managing to get that integrated into our system, we want to further refine that and improve it, and then see how that can be used then in the feedstock chemicals production. Because right now you need to have a really cheap source of energy. For example, I think they produce methanol in Iceland because they have the geothermal stuff there. But yeah, in the end, we're heavily reliant upon like oil-based chemicals, and we'll need to move into the CO2-based chemicals in the future at some point. So, yes.
And is your long-term vision that you will always kind of subsidize the chemical production side of the business with the isotope side of the business, or is it like a transitional sort of phase of the company for you? And are you also working on like proprietary direct air capture technology, or is it really just the separation technology?
Yes, I think there were like two different questions. So the first one was, yes, we want to definitely stay in isotope chemistry. And the idea was basically that in the beginning, we were looking into how can we turn CO2 into useful chemicals. And then, yeah, we realized it's really expensive to actually do this. So we looked into ways of how can we produce something which is so valuable that we make enough profit to kind of cross-finance making chemicals from CO2. So we definitely want to stay there because it's super interesting, actually. We learned a lot over the last year, but yeah, we will stay in that as well. And then we can expand step by step, I'd said, into more fine chemical markets, which are, yeah, for example, methanol or something like that. And then the second question was?
If you're also working on kind of a proprietary direct air capture technology, or is it you're kind of a taker of technology as it comes into the market, and you really focus on the separation piece?
Yes.
Yeah, so we're working on a proprietary technology for the direct air capture to integrate it into the whole separation system. So yeah, we're hoping to cut costs that way, really, to have it all completely in one system.
Can you tell us about your unit economics?
So you mean the market size, or just the how much it costs to make all this stuff, or?
Yeah, like what do you expect revenue to be versus your cost at scale?
You see, so in the isotope market, it's quite a large margin. So the costs are relatively low, and the commercial value comes from the value that people see the carbon isotopes as. So you can really sell it at quite a large margin, and right now the global provider is based here, and they sell around 8% of carbon-13 compounds, so they really dictate the price globally. So that margin is really quite high. So that's where we want to come in, because the demand is also there and not quite being met, especially in Europe. So yeah, in terms of the margin that we can fit into, yeah, we think quite comfortable there. Yeah.
So to expand on that, so obviously you have a strong margin for the carbon-13, but looking at the fine chemical market, do you have any margin there? Do you have any advantage over competitors for those other markets?
So again, that's why we're looking at the isotope market first, because we were well aware of that. And then the fine chemicals, we also have an idea from both being organic chemists. There are certain compounds which are way overpriced for what they're used for, but that's due to demand and supply again. So what we would initially look at are those molecules where the margin is very high, move into there and have a sort of proof of concept of CO2 to complex molecules, and then from there work down until the margins become lower and lower, and it's no longer economically feasible at the current rate.
I mean, if you look at the fine chemicals like methanol, if you make them at a HPLC grade, for example, that's kind of like a middle way, which also have a high value, and you can also produce it in a way that you take CO2 and make it, but the margin is not really big, but it's still big enough that you can make a profit. I think then if you look at the methanol, what I showed an example where it's like €1 per liter, it's really not profitable to make, but it's still important to make it. And so far, companies are not really interested in looking into sustainable ways because it's just so expensive to make it that they don't want to. But I think it's really important that we find ways to make it sustainable and to make it from CO2. So you need to find ways to cross-finance and also find ways to do that. Yeah. All right, thank you.
Thank you so much. So now we're going to break for lunch, and we'll come back at 1:45.
hey, 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 hey. So this is just, I shut the house off, and so it should be feeding you, and it should be plenty of level now. 1, 2, 1, 2, 1, 2, hey, 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 ha, 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 ha. 2, 2, 2, 2, 2, 2, 2, 2, 2. Huh? How you doing?
I'm on mic. I'm not hearing anything.
That's on the middle, I think.
Oh.
Now you're on mic.
Now I'm mic. Okay,
think.
go ahead. Try it.
Oh, wait a minute. No, that's mic low.
Yeah.
Ha, 2, 2, 2, 2, 2, ha, ha. Nothing?
I'm not. Are you sure it's feeding to me?
Yeah. Yeah, 2, 2, 2, 2.
I'm seeing it. Hold on.
Ha, 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 ha.
I'm seeing it. Go
2,
ahead.
2, 2. Yeah, I see it. Hey, did it. I can always change the gain on here.
Someone turn down my headphone level? Or my unplugged? No, I'm here.
Hey, 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 hey. 2, 2, 2, 2, 2, 2, 2. Hey, hey. I'm speaking very quietly. Should be plenty of level. Speak louder, speak louder, speak louder, speak louder. You want more output? I can kick it up.
Just a hair.
All right, I'm going to go to the, this, processing, compressor. I just gain stage it up a little bit in the compressor.
Okay. You're still like
2, 2, 2, 2, 2,
unless I gain it.
2, 2.
Yesterday they had a
I just added 2 dB to it.
I would need you
How's
to
that?
add like 10
No, I added 2 dB of gain on my output in my compressor.
more, so I'm barely hearing it.
Well, something's not right then. That's crazy. If it's on high, unless maybe try to put it to low.
No, look. With my gain up, it's not clipping. So do that again. Please.
Hey, 2, 2, 2. Hey, 1, 2. Hey, 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 hey. Uh-huh. But maybe high and low don't mean what I think it means. It could be maybe low.
There's a limiter over here.
Low also might be more gain, you know? So why don't we try switching it to low again? See if it goes down a level.
No, but this sounds better to me.
Oh, yeah, well, it should, because it's with the pad and going into mic level, it's kind of getting it to a sweet spot.
Okay, yeah, but like it's
Hey,
still
2,
like
2, 2, 2.
-20, so it is.
Too low.
So I'm gonna
Okay.
go to low again.
I can give you more gain. I got plenty here.
If you have plenty to give me like another like 5 to 10.
Well, that's 6 dB right there.
That's great.
Okay. 2, 2, 2, 2. Just hitting the compressor just a little bit. I'm tickling it. Hey, 4 to 5. Wow. Is it starting to hiss yet?
Nope, not at all.
Okay. That's at 12 dB right there.
That's great.
Okay, cool.
I'm down.
So you got room to play, and it's not clipping if I get it out loud. Hey, 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 hey. My compressor's kicking in a little bit. Your limiter kicking in or no? 2, 2, 2. Hey. Okay, cool. Well, let's go to the next thing.
I started reading the red line last night. I'm highlighting it where I have questions so that we can look at it together. Because I think now it's on us to send them back a V2 red line doc to because they've like accepted most of our changes, I think. And then, so I don't know. But it's gonna be great. Yeah. Yeah. Seriously. Mhm. Mhm. I felt so bad. Speaking of champagne, when we were up there, I was like opening some of them, and somehow I think Irina, I didn't even make the connection. She was like, "This was supposed to be good ones for like you and Greg," and I just like didn't even. I was like, "Greg doesn't really like champagne," and then I was like, "Oh God." Oh. I was like, he's just more of a beer guy. Like, he would just, like, generally take a beer before, and then I tried to, like, back out of it, and I was like, oh my God. I look like an ass. Sorry. She was so sweet and did that.
Hey, 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 hey. Uh-huh.
Sorry I did that.
Fader, going to outputs. 2, 2, 2, 2, 2. Hey, hey, uh-huh. Hey, 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 hey. There's the output. 2, 2. So this should be feeding signal to this right now. Hey, 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 hey.
So
Uh-huh.
I'm assuming,
Uh-huh.
okay, so hold on. I'm now outputting to the PreSonus audio box. Right. Okay, so.
Let me see if I got any returns.
I have no audio feeding to it right now because I'm
2,
not
2.
talking.
2, 2, 2, 2. Hey, 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 hey. Hey, hey, 2, 2, 2. I'm feeding the box right now.
Are you seeing me right now?
Am I seeing you?
Yeah, because I'm talking right now, so.
1 second.
My audio should be getting
No, I'm not.
routed into
I'm not.
the Sonos. Okay. So it says noise removal is on. So it's not.
2, 2, 2, 2, 2, 2, 2, 2, 2. 2, 2, 2, 2, 2. I'm feeding you sound. I'm feeding you sound.
I just got hot.
Should I be changing that?
I don't know. But
New balances and all.
this is going to be beneficial or not, but.
I also think Emily and Alicia pick is really cute.
Okay, yeah, we're gonna skip this.
Hey, 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 hey. Uh-huh.
I need to install drivers and stuff.
Oh, weird.
Oh, you do?
Yeah, and I do not have time for that. Okay, so I'm gonna.
They always have this kind of
connecting then the Sonos box.
awkward, like
Okay.
trying to be like.
I'm gonna get that connector back.
Jarring, you know.
Tried
so hard.
I have that one. I'll put that back. At some later point, we will try this out.
This will come to these little buildings.
Now it is. Now I have nothing. Coming through.
Hey, hey, hey. 2, 2, 2, 2, 2, 2, 2. Hey, 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 hey.
My mic is on muted. Do you have house audio off?
Yes.
Okay, so I'm just now speaking. Right?
No, but she really did try.
Yes. On the.
On the digital, this 1/8 inch.
I'm getting on both of them actually.
You are.
On. That's weird.
Okay.
Let me think here a second. Oh no, I'm sorry. That's a sends. Never mind.
Okay, Okay, so
You gotta look at the returns. On the returns, go ahead.
You're seeing me right now?
No, I'm not.
Okay. That's my microphone going out, so we would need someone from a different. I am seeing that. Or no, hold on.
There's nothing.
Hold on, 1, 2, 3. Okay. So all right. When people start speaking.
Well, I'm talking right here, so you should be getting a signal. Yeah.
You're seeing it all on the live stream. Because I'm not getting that here. You getting that?
I don't know. Because this is, whatever it is going in, it's coming out. That's
Right, no. So I need to rehook this back up to here. But we have this reconnected. Yeah. Okay, so I'm going to have you take the whole box. All right?
Hey.
I felt like I could hang pretty well with all these companies, except for that last one, the isotope, whatever, C13 and C12. I was like, I'm listening. If I really have a question that isn't covered by these like PhDs that are I'll ask. That was the only one I didn't ask a question for. I did have things I wanted more info on all the other ones. And that one I was like, this one's like really out there for me. Yes, I do. In here? Oh, hi, C16. Oh, that's true. Yeah. And theirs was interesting though, because they were talking about like these three paths that they were going to focus on, and it got a little murky because the margins for all three were like way different, and so it felt like they were talking about one down here that's like a huge margin, but this one that they have to start in is really small margin. But the one I felt the smartest on was Earth Sprint Solutions, which I actually am really fascinated by. It's like rice husk waste stream into a cement-like product. And I felt like I had a lot of good sublime knowledge of like Portland cement is the industry standard, like how do you comp to that? They're all only focusing on non-structural things right now. And so that one I was like, I can do this. The thin solar, the Fitsol, that one's super early, like literally just coming out of a lab in Australia that was kind of like cool, but like I feel like you're kind of almost like you have an idea, you have one working prototype, but like so early. Aeropod is this one. It's for like oxygenation of soil for regenerative ag, which is actually seems very.
Hey.
Albon was really impressive. Cosine, I think I'm most drawn to purely because the kind of companies we see here, that it's thermo. It's like induction,
Choo-choo.
kind of electrification for heating. Oh, were they? You know, I meant to Slack you. Be like, do you have any like courses in this?
Choo-choo.
Is that on?
Choo-choo.
Yeah, are any of these mass-based? Yeah. Got it. Oh, cool. Yeah. Cool.
Choo-choo.
Jody, you want your water?
Bad day to be Julia.
Why is that?
All right, told Adam. Because we were talking about something else. It's also, there's complaints on Greentown Labs, so it's not just our space. The guest Wi-Fi is working.
Okay, sorry, I've been in this.
Anyway.
Yeah.
It was, when it was good, it was really good. But anyway.
When it's good, it's good. When it's bad, it's bad.
Yes. It's hot and cold. Oh, that definitely.
Yeah.
Oh, that's true. It is weird that the Greentown Wi-Fi didn't work. Guest Wi-Fi actually did work. I mean, pretty good. You give me access to the mapping for Wi-Fi, I'll look every time and tell you. I know, and Marina says the same thing, and I said, that's beside the point. That's not how it should work. Like, that does work. I don't disagree, but it shouldn't have to work. You know what I mean? Like, you're not wrong. But you shouldn't have to.
Yeah.
Adam and I had talked about it the other day. About the world we were walking about here. I think they're looking at it this weekend. Anyway, trying to figure it out. There's probably no pizza, but that's okay.
No, they ran out of everything. There were chunks of chocolate pieces. There were like random. pull that from? Where? Sorry, what? No way. $25, but I don't know. Is it? Well, do you know if are these staff stuff on? Yeah. Oh, they're. I'm sorry. Sorry. We can't officially endorse the market basket, but I don't know of anyone ever getting towed. Buy a pack of gum. There you go. I think that is your best. Yeah. That'd be fun. I like this like real-time kitchen over here. It's like let's put it out. Fun.
Hi, everyone. If you can start making your way back towards your seats, we're going to go ahead and get started again soon. And please feel free to fill in these front seats, too, if you want.
Have fun.
You trying to get us to sit back down? I'm a front row sitter and an on-time guy. Great to meet, by the way.
Yeah, same.
Gabe.
Home stretch here.
So, I am.
Yeah, likewise.
Whereabouts?
Cohasset.
Okay.
Yeah. So I've got a kid going to school in Central, another one going to school out at Albon in Wells City, and so I'm always happy to come in the city way and do things.
Is Central where?
The Central Square.
Oh, right here. Oh, okay. Great. Yeah, so not too far.
Drove in with him this morning, dropped him off. He's doing high school there, so this is last year though, and then.
Yep. No, I got a junior in high school and a sophomore in college.
So you're in the middle of it. Yeah.
Right, and
I've got an 11-year-old, so we've still got a ways to go.
Oh, okay.
sophomore nearby, or?
Is it?
Okay, thank you so much. Hope you enjoyed lunch, and we're on to our afternoon session and our last block of pitches now. So excited to welcome up Veriflex.
Hello. Hello. Should I start? Yeah. Hello, everyone. I'm Vikas. I born in a small town near the Thar Desert in Hisar, where in summer we cannot avoid a heat, and having a reliable cooling systems was not so affordable. So instead of focusing on a growth and opportunities, many people were trying to cope up with the heat. So as I grow older, I realize it was not my problem. It's a global challenge. Today, around 1.2 billion people still lack access to adequate cooling. Moreover, around nearly half a million people died due to extreme heat. On top of that, around cooling already consuming around 20% of global electricity and responsible for around 7% of global emissions. If we do not improve the cooling systems, by 2050, cooling demand roughly would be around triple, and the emissions would be roughly double by 2050. So the question is not whether we need a more cooling, it is how to provide it more efficiently and affordably. That's why we are here. We are Veriflex. We make cooling system more efficient using our high capacity coolant technologies. Before moving onward, let me tell you why the traditional cooling systems are not so much efficient. Let me give you a live example. You see the air duct there in this room. From this air duct, the air goes to the heat exchangers and exchange the heat behind with a liquid coolant loop. In that loop, there is a coolant that carry a heat exchange the heat just by warming up, and that's a limitation. By warming, coolant able to carry only limited amount of a heat. So whenever we need a higher cooling, operator just increase the cooling by brute force. He increase the more flow rate means more pumping power and often higher chiller power, making a cooling system inefficient. As a Veriflex, we have developed a new patent-pending coolant technologies that have a two physical product, a Veriflex coolant and a flux core. So how does it work now? So what we need to do, remove the traditional coolant, put a Veriflex coolant inside the loop, and add a flux core inside that whole cooling system. That's it. Whenever my coolant is cold, it forms a tiny pockets of cold energy within the coolant mediums. And whenever it exchanges the heat, it do by warming and melting effect. Melting effect you can take as a ice melt on a hot surface and a hot surface get cold. So in this way, my coolant able to carry 5 times more energy per unit volume compared to the traditional coolant. Now, to provide the same cooling performance, we require a much lower flow rate, means much lower pumping power, much lower chiller power, making a cooling system much more efficient. Flux core help us to regenerate and maintain the level of these tiny pockets of cold energies. We have tested our coolant technology on a 10 kilowatt prototype. 10 kilowatt prototype you can take as equivalent to the cooling need of the 5 to 6 room house in a Boston during a summer. And we have tested our coolant technologies, and we have provided the same cooling performance with the 70% less pumping power, around 20% less chiller power. Overall, we are able to save around 21 power by providing the same cooling. A part of this, results of this study is already published in a collaboration with Keppel Data Center as early technology validations. So what does it mean for end users? Let me give you an example, like with the help of 10 megawatt data center. On average, 10 megawatt data centers spend a 50 gigawatt hour of electricity annually. And if they put a very flux technology in the facility side of the data center, they can save around 11 gigawatt hour of electricity annually. As the electricity use goes down, they can avoid carbon emissions also, and that comes around 7 to 10 kiloton of carbon emission depending on the power source for them. So in this way, for our end users, we are creating a value on a three front. We are making them more sustainable, we are reducing their carbon emissions, and we are saving their cost in a form of electricity. So yes, we have a competitor also. And our competitors generally sell they have a product, either a treated water or a PG25. So instead of comparing with the company logos, I compare directly with their product. And through our market interview, I understand that different end users have a different need. Like data center as end users, they want a high efficiency gain or a high OPEX saving, whereas the cooling system provider want a capex, lower capex to build that cooling system. And it should be not, my coolant technology should not be hard to integrate. That's why, as a very flux, we win in this competitive landscape. We provide a high efficiency gain for our end users like our data centers. And we make sure that to build that cooling system, we reduce the capex. Moreover, our technology is also not hard to integrate in the cooling systems. So we choose our beachhead market as a data center, so our TAM become $8 billion, and we are looking that by 2030, we will remove around 700 megawatt of heat using very flux technologies. Accordingly, our SOM become a $66 million. Once the product is ready, we can expand to other markets like industrial cooling, district cooling, LNG cold energy recovery extractions. So our go-to-market strategy is through the cooling system providers. We will sell them upfront like a flux core and a coolant, and provide an annual service fee, service and maintenance to the end users. Cooling system provider can integrate our coolant and the flux core into their system and have a benefit of smaller pump, smaller chiller, and smaller heat exchangers, and can save to build that cooling systems. And they can sell to end users by saying that same cooling performance in a compact size. End users can have a saving on the OPEX saving, and they can save around 20% of annual OPEX. Moreover, they can avoid the carbon emissions also. And today we are not a revenue yet. Our tractions are more of market validations. We have conducted 50+ market interviews. We are already selected on the Singapore's largest platform, National Grid program, that help us to take a technology from a lab scale to the industrial scales. Whereas we are in a talk with the 4 big companies, 3 are the MNCs that provide a cooling systems. One is the Singapore's government company that's responsible for the sustainability of government and buildings in the Singapore. The reason for them to talk is that to bring them on board and co-develop a pilot scale and de-risk the technologies. And that's why I'm here, to raise a fund to build that prototype. Once we build it, we de-risk the technologies. We are looking that by 2027, we are looking to install our first paid pilot. And by 2028, we are looking to expand the market in a data centers, scale the market. So at a moment, as I said, we are looking to build a team. So we are looking to build a prototype. So we need more on technical skills at a moment, and that's how we construct our team. Myself, Vikas Damu, I have a 6+ year experience in building a prototype and expertise on coolant technologies, whereas my CTO, Mayappan Karna, he's a scholar at NUS, but he's great at doing the optimization, whereas Prof. Praveen Linga help us to scale up and de-risk the technologies, whereas Michael come with a 20+ year experience from industry like Porsche for a system design and integrations. So he helped us to design that our systems, whereas also help us by giving advice on a business side. By 2028, we are looking to expand our team. In last, I will say that we are very flux, greener, cooler, smarter, the future of cooling. We are on a mission to make a cooling system much more efficient and affordable. So now the question is from you guys. Are you want to join this my journey? If your answer is yes, let's connect after the PPT. Thank you.
Thanks, great presentation. Can you talk just a little bit more about the technologies themselves? I'm just curious what's going on in there. You've got the chiller and then the heat transfer fluid. Can you talk about the chiller? Is there a new cycle?
Okay.
Yeah, go ahead.
So, to be frank, we are not bothered about the chiller. Chiller is that whatever the chiller they want to use in industry. It's more on the coolant side, the property of the coolant. So my coolant is a phase change material, a mixture of a phase change material suspended in a water phase. So what happens is that when it exchanges a heat, it do by like a melting effect, like ice melt on a hot surface. Same in that way, my coolant have a micro size of ice suspended in a water phase. If we end users want to melt them at a 20 degrees Celsius, 25 degrees Celsius, we can melt accordingly. We can customize. And so that we can able to achieve 5 times more heat transfer in that way. That's the crux of my technology.
Kind of along those lines, are there any downsides to it? Is it corrosive? Is it harder? You know, does it try to escape more? Like, why wouldn't people do this?
Okay, excellent question, to be frank. Today, they use a water in today's industry, and water is also corrosive. So do my coolant is also corrosive. My coolant is 97% is a water by mole fraction. And how to now eliminate that risk? So today, industry uses an inhibitor package to lower the corrosion level. So do we use. So using that inhibitor package, we're able to reduce the corrosion level by 90%. Once you add, it run for a 25-year plus. We no need to add extra anything.
You mentioned you've been working for 6 years on a coolant technology. Was it this one or a different one?
It's this one.
This one?
Yeah.
And what has been the evolution of the product that you've built over the last 6 years?
Okay. So first we started with the idea. Idea was started actually 10 years ago. Then I joined the lab, and then we start building on it. So if I say in a more technical terms, it's a clathrates. It's like a IC-like particles. Initially, they were used to stick together. They form a big chunk. With the time, that was the first particle. Then we able to make in such a way that we can freeze it, or we can form that tiny particles at up to 27 degrees Celsius. Next step was that, okay, now it should remain a suspended mixture. That was the next step. Now, the question was come here for a corrosion one. We also figure out how to downsize up to 90%.
So on your competition slide, so it looked like in one of the fields that you were pointing to a slightly higher complexity for your solution. So I'm curious what creates that higher complexity. And then I have another question about data centers. But
okay, higher complexity, first of all, the first question. It's because that we are adding a flux core inside a loop. That's why I need to put a medium, a low to medium in that here, low to medium. We are adding a, if I go a little bit more back, yeah, we are adding a flux core in between. That's why I need to put as a low to medium.
All right.
Another was the data centers.
Yes, and so for your coolant, so data centers, so there's the idea of direct liquid cooling.
Yes.
And so is your coolant compatible with direct liquid cooling for data centers?
Okay. So direct liquid cooling comes when it goes on a chip side. Potentially with a cold plate, yes, it is possible. But to enter in that market, the risk is very high, the frictions are very high. So instead of choosing that part, I choose on the facility side because the friction to enter on that side is very low. Yeah, that's the reason.
Okay.
To that end, you mentioned on one of the slides you interviewed 50 customers for market validation. Can you talk a little bit more about those conversations and the customer discovery? And
sure.
Especially as it relates to the low to medium integration tech challenge.
Sure.
Did they speak to that?
Okay, so let me give you specific examples. First I talk with the data centers. I actually with the CEOs in Singapore and with the manager operators of the data center, they say that they will not directly use my technology, to be frank. That was their insight they have given to me because the reliability is so high. And they given me a suggestion why you don't go with the cooling system provider. Then I go with the cooling system providers and they say that, okay, we can work together, We can co-develop a product, but they will not adopt my technology directly. Firstly, I need to prove my technology in an environment that's similar to the industry. For a moment, it's in a lab environment. That was one of that. And they also say that flux core. You see in my, like in a prototype, they say that, oh, flux core is too big. How to integrate it? This black box. So for that one, the reason is that, yeah, they were curious about this part also, but this is a research part. In a research, whenever we do to make sure that it should be safe. So we make a size 5 to 10 times intensely bigger. When we do optimization, the size will reduce 5 to 10 times. So they were comfortable at that level. Moreover, they were happy by looking at our data that we are reducing a pumping power by 70%. So their pump size reduced by 70%, chiller size reduced by 22%, 20 to 22%. They save a lot of money on that one. That's the reason.
Thank you.
Thank you so much. Next up will be Mineralize. Right here, you can just take this off.
Hi everyone, I'm Rafa, this is Daiki, and we're here to present our solution to coastal erosion, Mineralize. 3 billion people live close to the coastlines. The problem is that the shorelines are receding 3 feet per year, causing billions of dollars in damage. Yet, the so-called state-of-the-art solutions are temporary, expensive, and environmentally incompatible. This creates a massive opportunity as 60,000 miles of coastline is at risk, justifying a $15 billion coastal erosion protection market that is growing 7% per year, heavily relying on carbon-intensive solutions as, for example, concrete seawalls.
Our proprietary technology uses just 3 essential components: a pair of electrodes, such as cathodic mesh and anodic rod, low voltage electricity from solar power or generator, and lastly, seawater. When electrodes are embedded into soils, low voltage electricity causes naturally dissolved ions in seawater, especially calcium and magnesium ions, to precipitate as durable solid, such as calcium carbonate and magnesium hydroxide. These minerals act like a natural glue, binding soil particles together and transforming them into a strengthened, porous substrate. Because we have the ability to control the rate at which these minerals precipitate and where they precipitate, we are able to create a substrate that, while strengthened, remains permeable, allowing for water and sand to move through the system so that the beach ecosystem can continue to function. Building up on the fundamental process, here you can see the process at work. In a coastal environment, starting from a starting condition, like the one shown here. Along the slope of an eroding coast, flexible cathodic meshes are installed and then covered up with the backfill sediment. Once connected to the power source, our electrochemical treatment kicks in immediately. Over the treatment period, soil particles surrounding the cathode turn into a cohesive crust that integrates seamlessly with the ground beneath. The flexible cathodic meshes can be fabricated with wide apertures, meaning that the resulting substrate is strong enough to withstand wave energy while still being porous enough to allow for sediment transfer to beaches to support the growth of native vegetation. This way, the treated shoreline can preserve the natural character and habitat value of the coastal environment. Since the idea was first conceived, our demonstration has followed a clear progression from the molecular scale to the microscopic scale and to the macroscopic scale. It is the cost rebuilding from within. We don't rely on cement or polymers that are typically employed for soil strengthening. Harvesting natural resources with mild electricity, we have achieved strength and stiffness improved and permeability reduced. So now, where are we? We are now poised to validate our technology in the real world. Just last week, the town of Truro on Cape Cod in Massachusetts approved the first real-world pilot, with installation set to begin next month. We are also working to secure necessary regulatory permissions to deploy a pilot in California for cliff stabilization and another in Oregon targeting rocky shorelines, both expected to begin in early 2027. The most important thing is we didn't do any marketing. Interest in our technology has been spreading naturally and organically. We have developed a bio-inspired solution that mimics how marine organisms create their shells. Instead of metabolic energy, we use electrical energy to mineralize and strengthen coastlines. The process is permanent, quiet, fully reversible, works everywhere, and affordable. Where other solutions are expensive and impermanent and often detrimental to the environment, our solution is cheap, as low as $50, $100 per foot, permanent and environmentally compatible. In addition, it has minimal carbon footprint.
We want our clients to forget about cost erosion. That's why we're offering an end-to-end solution that goes for 5 steps. So that starts with the site assessment, understanding the specifics of the environment. The second step is in the engineering design, where we develop a tailored solution to that specific site. We also handle permitting, which is often a bottleneck in that space. Finally, in the process of installation, we deploy our technology that not only protects shorelines, but also heals the ecosystem. This 4-step process is charged at $1,500 per foot, which is lower than the existing solutions. Equally important, we are also offering a regulatory and compliance package to meet requirements from different states, as for example, the state of Massachusetts. That has the goal of allowing our customers to really forget about cost erosion while generating recurring revenue for Mineralize. Our direct-to-consumer approach is our first step in the go-to-market strategy. Our goal is to target private owners and properties, as for example, high-end hotels, first for 2 reasons. First, to get a lower sales cycle, and second, to get our technology in the real world. As a second step, we're targeting municipalities and agencies, as they have access to higher budgets and long-term contracts. As we scale, we're going to be partnering with engineering and construction firms so that we can scale without becoming asset heavy. Let me take a look in what our commercialization pathway looks like. By the end of 2026, we're going to have generated our first 100K in revenue, mainly by our first pilot in Massachusetts, as well as in California and Oregon. In 2027, we're going to be ramping up our pipeline in the direct-to-customer sector. In 2028, we're going to be targeting our first municipal contracts. Take the state of Florida, for example. Every year, they spend $50 million in beach nourishment. It's one state, and that's per year. What is really exciting is that the underlying technology that we're using for coast erosion can be used in every single use case where we need to strengthen any materials. So that will unlock different markets as, for example, infrastructure retrofit, build on retrofit, and offshore infrastructure retrofit. That will allow us to get access to higher TAMs as well as CO2 emissions. But first things first, let's start talking about what could be used in the MIT CEP prize money for? We're going to be using the money for 3 reasons. For 3, very cool. So first, to boost our pilots both in California and Oregon. Second, to demonstrate environmental benefits and perform LC analysis. And third, to build our proprietary monitoring and compliance package. Solving cost erosion, it's a hard problem. That's why we assembled a team that has different expertises, as for example, legal, business, and scientific. I'm Rafa Baroni. I'm a current MBA student at Kellogg. I have a background as a chemical engineer from École Polytechnique in France. And I've worked over 5 years at McKinsey in intersection of entrepreneurship and climate, bringing climate ventures into the real world.
And I'm Daiki. I'm a PhD student in civil engineering focused on turning the lab breakthrough into a reliable and field-ready infrastructure.
And we're also joined by Alessandro Hottaloria, who will be taking questions with us. He's the scientist behind invention. He's also a serial entrepreneur and the current professor at Northwestern University, as well as Wendy Luer, who brings over 30 years of legal and regulatory expertise, startup launchings, and also a personal stake as she's affected personally by coastal erosion. Finally, we believe that coastal erosion should not be a tax on the future of future generations. We believe that's a problem we can solve if we mineralize it. Thank you. We also brought a prototype that are going to be passing for the judges as we take questions.
Thank you very much. As somebody who's lived on one of these cliffs and watched them erode, I'm curious, one, how long it takes for the deployment to become effective, and 2, what happens far up the cliff where the seawater is not regularly touching? Does this work with rainwater or just general moisture? Curious how that works, because we'd often see the erosion on big storms when it's coming way up over the seawall.
So as for the treatment, like typical treatment time, of course, it's not going to be done overnight, but realistically, it's a matter of like a month or 2. You'll be like realistically big chunk of material that you can see. That's kind of took two months.
Wow.
Yes. And what was the second question?
With respect to the water, we can tailor-make that on a case-by-case basis. So for example, in the cliff photo that you saw, there's not the problem of water because it's constantly wetted by the ocean. In the bank application that instead we have in Massachusetts, for example, we have designed a watering system with drip line emitters, similar to the one you could have in your garden, essentially, so that essentially we can take salty water, seawater, and wet the bank.
And to push on that, you say naturally wetting in a cliff environment. I lived on maybe a 70-foot cliff with 20 feet of seawall, and the erosion would happen above the seawall in like 3 storms a year. So if you do the thing on the full cliff, do you have to pump water up to the top, or is the like small amount of spray that gets up there going to get the job done?
So the small amounts of spray can get the job done. So really, it's not essential for the material to be constantly saturated with water. It only needs to be periodically wetted by some water. Yes.
And then for your go-to-market strategy of going directly to kind of individual property owners affected by erosion, who do you need to go to market with? Looks like you do have some partners, but I imagine that there's a deeper structural component as well. How do you verify the efficacy of the whole system? And do you need to go to market with partners to do that?
Yeah, no, that's a great question. So like our direct to consumer approach has been organically, as they said, where they've been reaching out to us. But in the future, at least for the first 3 steps of the 5-step plan that I showed, we're going to be relying on partners that are currently addressing coastal erosion, just offering our very specific proprietary technology for the protection of the cliff. So we're going to be like tagging on the system that's already working, but providing something that's better than the current alternative. So instead of having like seawalls installed, we would have mineralized product.
And I think if I may add on that, the reason why we consider that in the short term this is the best approach, meaning that we do the thing together with partners instead of just giving the technology away and asking somebody else to do it, is that we want to take the responsibility and opportunity to do things well and demonstrate ourselves that this works, because essentially if anything were to go wrong at this stage, it would be a burden on us to actually recap and actually demonstrate that it really works. And so in the short term, we work with trusted partners who can help us to address the goals that we have and achieve the milestone that we have. But then of course in the long term, essentially to scale, in 5 years from now, the goal is to really license the technology once it will be proven in the real world, and everybody will also feel more comfortable in using and will know how to use it and deploy it.
Mm-hmm. So you're charging $1,500 a foot. So how much? What's your cost per foot? What's your margin on that? And then have you segmented the market of how much? It's pretty high cost. So how many folks are willing to pay that much on coastlines? Have you been able to determine that market size?
So it does sound like a lot of money. It is a lot of money. On a relative basis, it isn't, for two reasons. One is, once you install it, you're done. You never have to do it again. Whereas the other solutions are along the lines of that cost, maybe marginally less, but they don't work, or they work for a period of time and then they biodegrade. So comparatively speaking, I happen to be one of those people who are living on a coastal bank, and I can tell you that yes, it's a lot of money, but it's, again, over the long haul of a life that one might own the property, it is significantly less expensive. And it's a rarefied world of people who are very lucky enough to live on that oceanfront. And I think, well, I know all of my neighbors are lining up to get the technology. That said, that's not where we hope to end. That's where we're beginning, because it's an easy way to get into the market. But obviously, ultimately, the goal is to make it more affordable, perhaps charge lower margins in some markets, so that in Caribbean countries or in, the Philippines or wherever, where it's a dire situation as opposed to a luxury, honestly, that I'm trying to protect or that my neighbors are, that would be the long-term goal, if that answers the question.
Sure. And what is your cost and margins?
Yeah, so the cost is really compatible to other elements in the industry. Would have at least more probably than 50% margin. That's like our initial approach. As we scale and most of the fixed costs go down, that could be even higher. And also, we for potential customers such as high-end hotels, if we're thinking about insuring some properties, we could also have higher prices, which would increase the margins even further. But that's the lowest number. Yeah.
And just as a complementary remark, that 50% margin is what we have today without any economy of scale, and essentially, it's what we need to pay if we were to go to Home Depot and get what we need. So it's really a low-hanging fruit and not optimized.
I'm just curious about how did you all get connected? It wasn't clear on your team slide, like what the founding team story is. And then I'm just curious how large the churro down the Cape, how many square feet that pilot is.
So how we met, obviously I live in Truro, I'm very lucky. Come visit me anytime. And we have coir logs, which is one of the state-of-the-art, I would say the state-of-the-art, that is permitted in Massachusetts. It works, but it biodegrades, so roughly every 7 years it needs to be replaced. It is very expensive and very disruptive to the ecosystem. You have to bring heavy equipment, et cetera, onto the beach. So I'm a curious person, and I've been looking for a solution that might work better than the one that we have. And in my looking around, I was incredibly lucky to find Alessandro, and I reached out to him and said, I see what you're working on. Would you consider tailoring something specifically to be acceptable, basically, in the state of Massachusetts, which is one of the most difficult states to get permitting in? And he said yes. I will let him speak to the rest of the crew, but just to answer the other piece that you asked, The initial pilot is in 2 phases. The first phase is just 10 linear feet, 100 square feet basically, in 2 separate properties at opposite ends of a stretch of beach. And that piece of the pilot will be used to fine-tune the prototype, and then roughly 6 months it'll take. Once we have completed that aspect, we want to make sure it gets through a winter, see how it does, and then there are roughly 9 properties in a row, it's almost 2,000 linear feet, that are signed up and ready to go if it works, which it will. But I'll let the rest of you answer.
Yeah, very quickly. I mean, I met Alessandro through like Northwestern. I was doing an MBA at Kellogg. He's a professor there, and yeah, I think the AIC is very similar. His PhD.
Right.
Yeah.
Thank you.
Oh, thank you.
Thank you. Next up will be Hollow Traps, who's going to join us virtually.
Can you guys hear me? Is it working? Perfect. Okay, let me just share this screen as well. Right, okay, perfect. I think that is working. Right, good afternoon, everyone. I will be presenting to you about hollow traps, where we are developing defense systems against climate catastrophes, including urban and wildfires, air and water pollutions, nuclear and asteroid accidents, and much, much more. Right, so most of you would have heard about Los Angeles fires of January 2025 and the damage they caused. Most people would also know that those fires did spread at quite a drastic rate, which is true. As we look at the timeline, we notice that the fires ignited over 10 acres on January 7th, and by the next day, they had spread over 10,000 acres, resulting in 0% containment rate for days on end. And by the end of January, when they were fully contained, they had caused enormous environmental and economic damage. So the question is, are these types of major crises undetectable until they fully materialize? The answer, as it happens to be, is a resounding no. For a crisis to pick up this level of momentum, conditions have to be right and parameters have to align. In the case of Los Angeles fires, what we learned was that almost a week before the fires ignited, the ground started to trap heat in preparation for the fire, which in turn emitted infrared rays. Right. In fact, this phenomena of invisible activity taking place before the scene, invisible activity taking place behind the scenes before the catastrophe surfaces is not just exclusive to fires. For instance, air and water pollutions directly contribute to ozone deterioration, which can be identified through UV rays. Or equally, before a nuclear accident takes place, there is almost always a gamma radiation that builds up at the epicenter. Moreover, these signals appear so early on in advance that if you were to capture these in time, at the very least, you will have a very high likelihood of drastically reducing the impact of the disaster, and at best, a fair shot at completely halting the event from taking place at all. So then the question is, why has no one done so yet? Well, 3 reasons. Firstly, as you can see on the slide, the signals in question can be from anywhere across the entire electromagnetic spectrum, and the available detectors are only able to capture very limited narrow parts of the spectrum. Second, the scientists have historically struggled to transmit signals over extended ranges. And then third, even when the data is transmitted, it is received with a measurable delay because of the distance and so on and so forth and the amount of data, making the information obsolete. And that is exactly where holotraps comes in. All of the technical limitations I have just outlined are the areas we have excelled at. We have designed, developed, and deployed a system capable of transmitting and receiving signals across the spectrum, targeting at over 300 miles in real time, which means if you were to deploy this across any critical location, for example, let's say a seaport, you would be able to actively monitor all sorts of signals, including for potential urban and chemical fires and differentiating between those, or any hazardous ionizing radiations. Not only that, we are also able to identify pollutants and their concentrations within the atmosphere and within the oceans. And on top of that, the bonus part is that with the same system, we are also able to monitor for any incoming and outgoing air and subsurface traffic, along with their coordinates as well as dimensions, because we retain the phase information, as well as communication signals incoming and outgoing. So because of all of this, whenever there is an upcoming crisis, because of our ability to synthesize multidimensional data across domains, the holotrap system is able to provide unparalleled situational awareness of every ongoing activity. And this capability ensures that nascent threats and intensifying systematic instabilities are analytically monitored and forecasted, enabling strategic diversion of hazards with almost negligible losses. As an example, if you again take a wildfire, which we just discussed, it goes through quite a few significant phases. before the fire itself emerges. And holotraps technology can forecast that way before the fire starts at its earliest inception stage, giving substantial time advantage to rewrite the course of future history. And this is not just for detecting fires, at which our competition is slowly getting faster at, but we left that race long time ago. And for reasons quite obvious actually. We deal with not just infrared signals, but any and all signals. We do not need to deploy our systems on satellites or at high vantage points, but at almost anywhere, including eventually underwater as well, where we are testing right now. Then on top of all of this, we come in at the earliest point, detecting in real time without even having to wait for the signals to reach back, and that too at previously unachievable distances, making us able to detect way more than just fires. Okay, in terms of where we are and where all of this is heading towards, last year we successfully completed control test, and this year we are running pilot programs, starting with seaports in Asia and airports in Europe. Then in the years leading to 2030, we will be expanding the target markets to include commercial and dual-use applications. And then by 2030, we should be in a place to fully deploy this across and actually beyond the planet. So speaking of which, holotraps when fully deployed would translate to environmental and economic impacts of 2 billion tons of CO2 and 900 billions of US dollars of savings annually just for US alone through averting wildfires. Similarly, tracking pollutants, it would result in reversing global warming and cooling the planet by 0.5 Celsius degrees by 2050, which would be the first, and thereby preserving Arctic sea ice as well as the coastal cities along the equatorial states. And yeah, what can I say about identifying radiations? Anyone who might have also grown up in places like Hiroshima would be able to realize that the impact of radiation outlasts generations. And we, for the first time, actually have a chance to stop that from happening ever again. Okay, last few things. Regarding our customer base and revenue sources, we have started off with federal government contracts, and we'll be moving on to building holotrap systems for local government departments and international bodies involved in combating relevant climate crisis, before eventually deploying our systems within commercial use applications as well as jurisdictions which will be considered under international law. And once all of that is successfully up and running, we will be in a position to accept even more ambitious projects, such as predicting asteroid crisis and averting its impact. That is, if and when such event might occur. Yeah, so those are some of the government contracts and pilot programs which we are either already running or otherwise finalizing. In fact, the major issue for us right now is that we have too many offers for paid pilot programs than we can run. But yeah, expect to see those increasing over the coming weeks. Right. Very finally, as you might be able to appreciate, all of this has been only possible due to the extensive effort and planning by the Holotraps team, of which CEP Grand and I are the founding members. I was last year endorsed by the Royal Academy of Engineering in the UK as the global talent in optoelectronics, as I'm one of the less than 30 scientists across the globe who can control the electromagnetic spectrum in open space, which is effectively what true holography is, and probably the only one to do so for the entirety of the spectrum. I also have a PhD from Cambridge University in holographic technology, and am also a qualified UK and European patent attorney with multiple years of experience. Cyprian, our COO, has founded multiple deep tech startups and has near a decade of experience in strategy consulting. And hence, Cyprian leads the strategy department at Holotraps, and I direct the Holotraps tech department. Right, those are some of the institutions and organizations which we have supported, which have supported us. And that is it from me. Yeah, thank you. And any questions? I'm happy to take. Exactly 10 minutes.
Any questions? Okay.
Thank you. Why do you have so many pilots with airports?
Yeah, I can take that one.
Yeah, I'm assuming you guys can hear me. Right,
Yeah.
so airports tend to be the easiest place to sort of like get the permits, and it's a high intensity, high traffic area where there is a danger of like fire breaking out, like, you know, things that happened at Heathrow Airport last year, also like other radiations and incoming and outgoing signals. So it's a really good place to test it out without necessarily like, you know, deploying it on active wildlife areas and so on and so forth.
Yeah, and maybe to add one point, airports have shorter procurement cycles. If we work with national ministries, political organizations, it's typical 2 to 3 years. Airports work within 9 to 12 months.
And what are your data?
Sorry.
What are your data sources?
What do you mean by data sources?
Sorry, what do you mean by data sources? As in, like,
How do you acquire data into your platform?
Hassan, I will leave
Are
you.
you deploying your own sensors? I'm sure there's some satellite data that you can leverage. Do you need to do your own instrumentation? How do you acquire all the data that's incorporated into the platform?
Yeah, I'm assuming you can still see the slides, but if not, so basically like we have created the entire hardware as well as software. So obtaining the data is part of the entire holotrap system. So we captured the entirety of the data across the electromagnetic spectrum.
Yeah, so along those lines, I'm trying to understand like what the nature of your invention is. Like what are you doing that hasn't been able to be done before or is different that's enabling you to acquire data over such large areas and identify what others can identify? And also, do you ever have false positives?
Yeah, okay, so in terms of the technology, I mean, I can go into quite a lot of details, but very briefly, so you guys can still hear me, right? Okay, so there are three main things that we have done, right? One is that we found a way to modulate, i.e. control different electromagnetic spectrums with just one modulator. So there was like a bit of a fabrication of the entire modulator as well as the algorithm that runs it. So that's on one side. Then for propagating the beam at such a distances, we basically came up with certain phases which we put on the propagating beam and effectively create a space-time wave packets which retain the entirety of the signals. Then three, in terms of detecting those signals in real time, what we managed to do was effectively leverage the differences in the scattering and the gradient forces that act on those beam pathways. So effectively, like, you know, identifying that these are the critical areas, then knowing exactly the science behind those things, like how those things operate and happen, and then sort of engineering the solution to those things. So that's basically like what lead to this thing. I mean, for context, the research on this, I started back in 2016, and only in 2022, I knew that we were able to do all of this thing and way ahead of the market. And then we effectively started this holotraps last year.
Ask one more question. And what do you anticipate the economics of the business looking like? The contract value that you're able to get from your customers versus the margin and the cost for you to develop the platform
Great
and
question.
sell it?
Yeah.
And I think in
So,
unit
for
economics,
instance,
a
there is
unit
like
we
a
see
one or
as
two
one system
competitions which
deployed,
try to
which
sell something like, you know, and they advertise it as holographic, but it's not because it doesn't cover the entirety of the spectrum. They are selling it for around 2.1, 2.2 million US dollars per unit. Ours has way more features and technically is way more capable, and it only cost us to assemble for like 300 to 400 300 to 400,000 US dollars. And even if we sell it at like say 3x that price, we are already undercutting the competition by half and making a profit of like 2x of the original price. And then in terms of the applications and the use, I mean, it's not just specific areas I pointed out, like it has way too many dual use applications, and hence the airports, seaports, and climate agencies and departments have been very interested in this thing. So it's effectively a matter of time before we complete these pilot programs, which we are not running to verify the technology. That's all done. It's effectively to adapt these specifically for the potential customers and then sell it to them.
Yeah, and on unit economics, so one site deployed is
and
one
we
unit.
already actually have started to
there's a
plan for the mass production units and assembly lines.
Yeah, so one unit is one site deployed. It's more than one sensor, 2, 3, 4 sensors, depending on the area covered. The sensor we sell at a 70% margin, 7-0, on the hardware, and then we have software subscriptions. And the acquisition cost is quite high. Like I said, the procurement cycles are long, so we should account for $150,000 for signing a contract. Contract size, to your question, yeah, the first few contracts will be smaller, around 1 to 2 million. And then if you really start covering wide areas of wild area, it's going to go up to 20 million. For example, Driat, one of the competitors, they signed a 20 million contract in Greece. So that's the size of the contracts.
Thank you. Last up is Interlinked. Welcome to the stage.
Appreciate it. Should I see it? This one?
Yep.
Can I take that? There's only one right here. Oh, it's not us now.
No, yeah, let me.
Right there. A little higher. A little higher. Yep, right there.
There we go.
This was the Palisades fire early last year in California. In just the first 20 minutes, it went from that single ignition point to over 200 acres in burn. It was a disaster before anyone had seen it coming. But what if we had seen it coming? When seconds matter, why are we 20 minutes behind? It currently takes emergency response teams and fire departments 20 minutes on average to get an accurate map when going into a fire or disaster. This is caused by two major issues: outdated static mapping and a lack of real-time insights. And this leads to loss of life, loss of infrastructure, and millions in preventable damages to society and the environment. To truly paint the picture of what's going on, I want you all to imagine yourselves in the boots of a firefighter. These are some photos from one of the organizations we work with back home in California, CAL FIRE, which runs the entire state of fire operations. And while you see smiles on the left, I can confidently tell you that if you look at the right, there's nothing to smile about. Fire departments and emergency management teams have to track an unparalleled amount of data and integrations when scanning for a fire. Combine that with real-time insights from any first responders, as well as the outdated static mapping and lack of real-time insights I mentioned, I can confidently tell you that fire departments and emergency responders are forced to make life or death decisions sitting in operational chaos. To make this matter worse, on the financial side, that same organization, CAL FIRE, spent $3.5 billion over the last 2 years in suppression costs. Those are the costs related to under or over allocating resources going into a fire, not from the damages the fire actually caused. This proves it's not just an operational problem, but a financial one, and exactly why we built Interlinked. Interlinked is an AI command system to predict ignition of that fire, map the spread of that fire, and deliver response strategies all within seconds. No more waiting 20 minutes for a map, no more guessing games, just pure real-time insights.
This is the dashboard that the departments we currently work with use on a day-to-day basis. Very specifically, we start by predicting the point of ignition. where the fire starts. We then move to calculating the risk of ignition for key areas, stakeholders, and the environment, as well as optimized routes that firefighters will take and the response strategies associated with them, making decision-making data-driven rather than instinctual. We start by combining multimodal data, which is data from the environment to the society, to even the very insights of firefighters themselves. We fuse all of this together in a pipeline of ensemble AI models that weights the factors based off of what's important in the environment. We then use reinforcement learning to be able to adapt these predictions in real time to what's happening in the environment. And this feeds into our agentic layer that turns these predictions into actionable intelligence. And this actionable intelligence takes the form of response strategies, telling firefighters what to do and when, resource allocation, where should firefighters most optimally position their units, and a human feedback loop where every time there's a change in the environment, we account for it.
And that doesn't exist in today's operational workflows. So we built this model proprietarily in our lab back home in Berkeley, but what's a model without data? We partnered with some of the most reputable data firms across the country and world to build this algorithm. We have over 50 integrations, and our most notable partnerships are with Google FireSat as a commercial provider for their Google FireSat satellite. This isn't available to the public and adds to our data moat. Other key partnerships we have are with NASA firms and NASA Veer satellites, as well as Waze for traffic data. Combining that with our backgrounds from Berkeley Disaster Lab, Berkeley AI Research, and Berkeley Institute for Data Science, we get the advice and prowess to build a complex model like this. So far, we've received $100,000 so far in non-dilutive prize funding and $500,000 so far in compute. Compute is our biggest cost. It's ultimately allowed us to scale our pilots very effectively. Speaking of those pilots, we have 15 pilots across California with notable counties such as Los Angeles and San Diego County to test and prove our technology. One thing we've learned about our total addressable market is fire departments aren't the only ones that can benefit from saving 15 to 20 minutes when allocating resources going into a fire. Other agencies and entities include insurance companies, utilities companies, and emergency management platforms. And these are some of our other partners that utilize our API. Very specifically, since we were here 1 month ago in Boston, we recently signed a $1 million LOI with the largest municipal utilities provider in the US, which is LA Department of Water and Power, proving the speed and scale required to move in this industry. Very specifically, how we make money with our counties, it's very straightforward. They utilize our dashboard. It's a dynamic pricing model, which means the larger the county, the more money required due to the amount of data. We're currently going through procurement cycles and testing with our existing counties. For everyone else, in their existing flows, whatever softwares that they currently have, our technology plugs in as an API. This doesn't disrupt existing workflows and allows them to ultimately utilize it to the maximum ability. Very specifically, by the end of this year, with our new contract with the LA Department of Water and Power, as well as our counties, we aim to be at $1.8 million ARR, and by next year, moving to the other fire-prone counties across California. There's 45 or so left. Very specifically after that, moving to fire-prone states such as Arizona, Texas, Colorado, to name a few, as well as fire-prone countries by 2029. To talk about our market opportunity, there's 45,000 tech-ready global departments worldwide and 200 national state fire agencies. For us right now, we're solely focused on California to test and iterate and perfect our technology, working with our counties as well as CAL FIRE, the state agency, as well as the enterprise, as I mentioned. Very specifically, this market model is only for fires. We've started with fires for 2 reasons. First, they're right in our backyard in California, makes it very easy to test, iterate, and visit our departments. And second, fires are actually the most complex kind of disaster. If we can do it for fires, we can do it for all types. To talk about our moat and our competition, it's the ability to respond in 15 seconds versus 15 minutes. That's our real-time decision engine. And specifically how that works comes from 2 major entities. Our private data partnerships, as I mentioned, one thing about fires, they aren't just caused by the environment. They're caused by people like you and me doing dumb things, anthropogenic factors, which means random. The other entity is calculating traffic, where people are moving during a fire, because the same people that are trying to escape the fire block the firefighters going in. So combining all these different data sets into one pipeline to respond, that gives us speed and why our departments utilize our technology. And the second level to this is we've tested with all these different types of counties across California. And another thing most people don't know is each county describes a fire very differently. They have their own language, their own vernacular. With our reinforcement model, we ultimately allow to adapt to that feedback, the way they talk, the way they act, and what makes them more comfortable in the moment. Each fire department, at the end of the day, they're seeing life or death in the face. They need to have something that they trust, that talks like them, that acts like them, and why we have so many champions across our counties. Very specifically, to talk about our impact by 2030, we align with SDG 13.1. There's around 8,000 fires a year in California. And to really be specific, the average fire burns between 150 to 250 acres. With those predictions, we believe we can save 6.65 billion trees from being burnt and 278 million carbon tons from being emitted solely from early response for the average 15 to 20 minute latency gap window I just mentioned. Talk about this more specifically, though, is in California and across the world, people live in wildland-urban interface zones. Those are zones that are at risk of wildfire. For example, in California, 1 in 8 Californians lives in one of these zones. The ability to tell them how to respond and get out faster ultimately saves lives, saves infrastructure, and also working with utilities companies, they cause most of the fires. So we're really working with them and providing them resources to protect their assets ultimately stops a majority of the problem. These are our pillars: protecting lives, infrastructure, and stabilizing communities. To really talk about how we would use this money. We've tested this, iterated this within California with our departments and the state. But one thing we want to do to make this scalable, work outside, is start testing this with states outside, right? We've already signed contracts with counties in Colorado, Texas, and Washington. We just need the money to go and scale this and run our testing outside California. So that's the big focus. And really talking about our team, we come from diverse backgrounds across AI. My CTO, Rashil, is a lead researcher at the Berkeley AI Research Lab, one of the most reputable labs for AI in the country. We also have a team of firefighters. Chief Chris Bachman is on our team. He's the one that taught us the entire fire space and ultimately how we iterated this technology so quick in a year and a half across California. We also have a team of Jonathan and Neil. They're not here right now. They're sitting in California working with a couple departments. Really specifically what they do is designing the data, working with our data providers, working with Google. And our advisors are here at the bottom. We have advisors from the fire departments themselves, as well as Google, AI researchers, and disaster researchers. Now, wildfires move fast,
but Interlink moves faster.
Thank you.
Can you integrate with existing systems that the fire departments are using, or is it rip and replace for them?
Great question. So very specifically, to talk about our current partner platforms, Genesis and Everbridge are two of the popular companies that are already in this space that fire departments use. We've designed our technology to be an API to plug into those technologies, so activates the total market. We can work with everyone regardless of whether they want to do rip and replace or if they just want us to plug it in.
Right. On top of that, just adding to that, especially for like Genesis and Everbridge, they really see a potential benefit using the AI portion. Their technology currently uses just regular algorithms and software.
Static mapping.
Static mapping, exactly. So we enhance that by making it dynamic and adding a prediction layer to that.
How do you validate that your predictions and your algorithms are correct?
That's a great question. It's really hard to predict the environment, especially when we're giving recommendations to firefighters. So there's no real way of calculating the accuracy of the model. What we do is we run simulations on past fires that have happened, as well as what our models are currently telling us we would tell the firefighters in that current moment. And that's how we're able to refine the model. In addition, we work with the firefighters and the fire departments to really take their feedback and fine-tune our models as much as possible.
Yeah, and just to be very specific here, the main thing in this space and in this industry is the big issue that affected these fire departments is they weren't getting data and information there in time, designed in a way to actually help them make decisions. That's what made it extremely instinctual and why a lot of bad decisions ended up happening. So very specifically what this does is it breaks the data down simply, and it's supposed to be suggestions. At the end of the day, their instincts is what matters, but with all this testing and working with these different types of counties in different areas, it's given us good accuracy numbers to push this to commercialization long term.
Can you speak any more about, great presentation, thank you. Any more about you said 15 pilots or however many pilots are up there that are happening right now? Like have they used this during emergencies? Can you speak about the impacts of the tech?
Yep. great question. So we started our pilots last July, which is right in the middle of fire season. Around the pilot sphere, we have scopes of work with all these different counties. It's between 12 to 18 months testing. So very specifically, we've run for around 10 out of our 15 counties. We've run live simulations, the largest counties being Los Angeles, Contra Costa, as well as San Diego. The biggest thing is just getting that data there faster. So when we're testing and writing these contracts with them, the three things we measure are first, how fast can we get the data there? How perfect is it for their specific workflows? Is it talking like that specific department? Is it actually saying things that are useful? And the third thing is, can we see measurable results? At the end of the day, anyone can go and build the best data partnerships, but the most important thing is, can we see results? What they see is the ability to get there faster, time spent getting there quicker. That's the most important thing that we measure. And then the second most important thing is the accuracy of the model. Is it saying accurate things? So really the things in the accuracy that we measure are, first, how many structures can we save? So that's why we work with utilities companies, because we realized that at the end of the day, they cause most of the fires. So that's why we can apply this across the realm. Hope that answered the question.
Mm-hmm.
If so many of the causes of fire are random, how do you predict it?
Good question.
Sorry, could you repeat that?
So you mentioned that a lot of the fires are caused by random events. So how are you
Yes.
able to predict that?
See, that's a good question. So basically what we do is predicting the hotspots, right? Especially anthropogenic factors that we can account
That means
for.
random, yeah.
Yeah, random factors. What we do is we take into account where these are happening. That's why we're constantly surveying the areas using our technology. Yeah, using the ensemble that we have, specifically cameras that are set up, we're able to pick these events up, especially smoke in the air.
And the best way to explain this, like very straightforward, right, is the fires will have natural causes or unnatural causes. So when we have fluctuations in our data that ultimately show us, okay, this doesn't look like the typical historical sets we've seen, it ultimately tells us, okay, this could be caused by a lithium fire, not a natural fire. This could be caused by a utility grid company. Also, the main thing is tapping into all these partnerships with the utility companies as well as the traffic data, noticing, okay, near these homes right here, there were fires that have happened very consistently. If one just came out of nowhere, it's an anomaly, right? So that's how we calculate. The other thing is, one thing that we didn't mention in this pitch, along with all the data we procured, we actually built our own vegetation maps within our lab. Vegetation is how quickly the fires will burn, how fast it'll spread, because that's something that adds to our proprietary LLM that tells us when it's a natural cause from natural vegetation versus someone doing something in the wild. So
May I add something to that? So what we actually do, because the data right now is so inaccurate to actually make good predictions for firefighters. So what we've done is we've developed in-house models to take these static maps, like Rehan said, with the vegetation, for example, or with any outdated data, and really make it dynamic. We use machine learning methods and algorithms to be able to take satellite imagery specifically for the vegetation.
From Google and all these different satellites.
Exactly. And then basically overlay them over a static map and create a dynamic map that's not just faster and updates quicker, but also has better resolution.
And that's how we respond in real time, pretty much. So.
Yeah.
Thank you.
Nice.
Thank you.
Great, thank you so much. So that was the last of our pitches, and now our judges have the hard time of deliberating. So we're going to have a panel of Greentown Lab companies in the meantime. So I have the lovely Zara to introduce that panel. And in the meantime, if the judges wouldn't mind following me into this room back here. Thank you.
We're actually going to do a quick 10-minute break, and then we're going to come back for the panel. So thank you, guys.
We need to bring the screen back to life.
choo choo choo. Hey hey. Hey hey. Choo. 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 Choo choo. Hey. Ha.
if everyone can make their way back to their seats, we're going to go ahead and get started with the panel. I'll introduce you guys. I mean, if you want, you can go ahead and get seated. It might make it easier, but I'll introduce you and then you're welcome to come on stage. Then take your time. No one's coming. Hi, everyone. Please start making your way to your seats so we'll get started with the panel. No.
Testing.
Hello? Testing.
So thank you again to all the startups for pitching. Next, we'll have a panel on founder stories with startups here in Greentown Labs. So on our panel, we'll have David Liu, who is co-founder and CTO of Laminar, formerly H2OK Innovations, an industrial AI company using sensors, machine learning, and control systems to manufacture plants to make manufacturing plants more autonomous. A Brown University grad and Forbes 30 Under 30 honoree, he focuses on bringing real-time quality control to process industries like food and beverage. We'll also have Eric Mock, who is co-founder and CEO of Glimpse, a company using X-ray CT scanning for battery quality control. While at Tesla, he realized that the lack of scalable quality control solution was slowing down the transition to electric mobility, which prompted him to co-found Glimpse. He holds a Master's of Science in Quantum Physics from École Centrale Paris and an MBA from Harvard Business School. Our moderator is Anna Ullman, who is a project and pipeline manager at Tomb Venture Labs Climate and Circular Economy, where she supports startups within the local innovation ecosystem. She is pursuing her PhD at the Tomb School of Management and Campus Straubing for biotechnology and sustainability, focusing on the impact and resilience of clean tech startups. Anna holds degrees in natural resource management and sustainability from the Technical University of Munich and from Cornell University. Please welcome David, Eric, and Anna.
Thank you very much, Sarah, and it's a pleasure to be here. It's a pleasure to have both of you here as well. Before I get started, I just want to say thank you. Thank you to Todd, to Libby, I know she's in the back, for connecting us. We've been part of the Climate and Energy Prize, so we being the Tomb Climate team in Munich for the last 2 years. We hosted the semifinals the last 2 years. So it's exciting to be here in person to really be part of this process. And of course, a big thank you to the students that have made this possible year and year again. So please, another round of applause to them as well. And then another round of applause to the startups pitching today. You guys made it. You did your pitches. We were finally there. You can take a breath. You can breathe. The hard work is done. And now hopefully we can distract you a little bit while the judges are evaluating. Before I transition to the panel, I just want to say a couple words of what TUM Venture Labs is in case for those that weren't around this morning. My colleague Lars gave a little bit of an intro. He's standing in the back waving. For those that aren't familiar with the Venture Labs, it's the largest entrepreneurial ecosystem in Europe. It's received the leading Startup Hub Award 3 consecutive years in a row. So it's really a big, exciting ecosystem. What makes the Venture Labs unique is we have these domains that we focus on, one of them being climate and circular. And that's what brought us and connected us with this ecosystem and what makes this wonderful collaboration possible and having such great speakers. It brings the whole thing together, and it really shows the most fun part of what this like international part of it, right? You're from France, right? And where did you grow up?
Here in the U.S.
Where?
In the Bay Area, and then moved out here for university. But I also was at TUM for a summer.
Exactly. So it's a small world after all. Okay, wonderful. So without further ado, the purpose of what we're going to do today is just chat a little bit and hopefully give some practical advice for the startups, the students in the audience. You guys have gone through this in one way or another, have some personal experience with it. So that would be simply the hope of today's session. Also to our audience, if you have concrete questions even during the panel, by all means ask. This is for you, so it's not about my particular interests, what I think is interesting, but what you guys need. And with that, maybe I'll give you both just a chance to introduce yourselves a little bit more thoroughly, actually what you're working on, and then we'll go from there. Sounds good? Would you like to start?
Totally. Hi, everyone. I'm David, CTO and co-founder of Laminar. At Laminar, we are thinking very deeply about how do we build self-optimizing, self-driving production lines in factories. In this current world where climate and geopolitics are at the forefront and there's a lot of uncertainty, knowing how to make things is super important for every region of the world. And we're very focused on how do we allow our manufacturers run the most efficient, most cost-effective, and sustainable way possible. We're specifically focused on process manufacturing. So if you think of manufacturing, there's two types of manufacturing. There's discrete manufacturing, which is where a lot of focus is on. So assembling components, like assembling a phone, assembling an aircraft, a car. And then there's process manufacturing. This is where a lot of this manufacturing is invisible, such as processes that flow through pipes, through tanks. When you walk into these factories, they're very much black boxy. You can't see how these things are being produced, and they're like recipes that are oftentimes special sauces or like kind of black boxes. And we're very focused on creating self-driving layers where we think a lot about awareness, first developing high-quality sensing within these production lines to bring visibility into these production lines. We built the intelligence layer, which is our machine learning AI platform, which takes all this data and takes data from their control systems and computes the most optimized action to take. And then we have our action layer, which we send, design a lot of the controls and send the signals back to the control systems to run in the most efficient way possible. Fun fact, all the Coca-Cola you get here in New England, we help produce, and then all the Chick-fil-A sauce you get in Chick-fil-A, we help produce as well. So it's definitely really fun, and it's been an amazing journey. So happy to share more about my insights and see how I can be helpful.
Wonderful, thank you. What about for yourself? I'll pass it on to you, Eric.
Yeah, thanks. Hi, everyone. My name is Eric. I'm one of the three co-founders of Glimpse and the CEO. I knew what you guys were doing, but hearing you describe it, it kind of hits like how similar our businesses are. And so you described two types of manufacturing, and we're pretty much doing what you guys do, but for the other half of manufacturing. So when you think about assembling parts together, it could be any sort of object around you, consumer electronics, medical device, airplanes, aerospace, and so on. So we started with batteries, but we're sort of expanding beyond that. So any assembly parts, you need to check the quality inside those parts. If the screws are in the right place, if the spacing between the parts are right, if there's any impurities or foreign materials in those parts. And in order to check the quality of those objects, we use X-ray CT scanning. So X-ray CT scanning is the industrial equivalent of CAT scanning that's used in the medical field for things like cancer detection. And so we've built a technology that is able to scan those parts very quickly and extract features from those images, process those images, and use computer vision to look for defects, look for manufacturing variation, and so on. So very, very similar to what you guys do. I think we sell our software and hardware in factories, so we have to service those. We have to sort of be on the hook for making sure that our customers can keep running their factories and react quickly if there's any issue with those. So very, very similar from that standpoint.
Cool to already see synergies existing. We haven't barely got started. All right, so the first question I have for you will actually orient the panel and what we're going to talk about. And that is, if you were to go back and, let's say, be in a stage where the startups that we're pitching today were, so students, they're founding their companies, maybe pre-seed funding, like in that general area more or less, what would you actually like the panel to be about? And maybe you could give me a couple topics, just generally speaking, but what would be or would have been the most useful for you at that time?
Two things come to mind. The first one is you never talk to customers enough. So I would prioritize a good chunk of your time talking to customers, as many as you can find, asking them as many questions as you can. I think there are ways to over-interpret the responses from customers, because sometimes they'll describe a pain point and they'll come up with a solution, but it might be the wrong solutions. It's always the right pain point, but it's sometimes the wrong solutions. And you kind of want to build that muscle, especially when it's your first startup. But yeah, talking to customers is a big one. The other one that I would sort of say more of as a sort of advice for just surviving the process is the highs are never as high as they sound or feel, and the lows are never as low as they feel. And so you kind of want to reduce your gain when you have good news and bad news. You kind of want to just push through, keep your head down, and hopefully there are more good news than bad news because those wear you down over time. But you kind of want to ignore, or not ignore, but sort of shave off the peaks and the valleys because it's a long process. You're going to have a lot of good news, a lot of bad news, and you don't want to over-index on those.
If you were, very quickly, sorry, if you were to rank one above the other in terms of addressing first?
I think there's just, one is around like how to move through the uncertainty of our startups and talking to customers, getting feedback. The other is more about sort of a, how to sleep at night and sort of run this marathon. So they're just very different. It's hard for me to rank them, but I guess talking to customers is probably the most important thing you can do, especially in the early days.
They're kind of like two different, almost very different topics. Like one is very on like talking with customers, and the other one is like you as a founder, how do you like psychologically, run and keep your mental health and things like this. Definitely echoing some of those points I'll tap on. Like I think in the highs and lows, I feel it's like for me going through life, it's like yin and yang. When there's good things that happen, and then when things that are good happens, in the next few days something bad can happen. And then when something bad happens, something's good gonna come around the corner. So I never get like too excited or too like upset anymore because of this. And I think talking to customers is really important. There's actually so many hacks. Like when I first got started, I actually just graduated from university. I was like a nobody. When I was working in manufacturing, so there's people in manufacturing do not look like me. And like I started this fun fact with my younger sister Annie. We're co-founders and also siblings. And so we were very different from everyone within this industry. And of course, when we first get started, we didn't have that much of a reputation. So there were definitely a lot of doubts. And so being able to overcome that, but also just being able to learn very, very quickly. I think what really allowed us to be successful was we were very, very passionate about this industry. We were young, we had a high energy, and we had a very deep thirst for knowledge. So we did a ton of customer interviews of people who were just like experts in this field and learn about all the problems inside the sector. We talked to people and asked them, what's the most important trade show that inside this specific industry you're focused on. And we would go to this trade show and would network and meet everyone who, like in the panels, and we'll often host happy hours, and we talk to people within these trade shows, who are all the top people like we should meet in this show, and then they would recommend us and then introduce us to it. And so we were able to get connected with a lot of really, I think, people who are very knowledgeable in this space, had a lot of experience very quickly, and were kind of like a sponge, so extracted and distilled down a lot of that knowledge to kind of focus on where we should be directing the company, what problems we should be solving, and what are some of the big pains. I think the other thing that we did well was we learned very quickly how to build business cases around our solution, and to really justify investment for our customers in terms of buying our technology, and how to build like payback years, and I think that helped us well in terms of going to market and also being able to sell and execute and scale our technology.
Can you just speak a little bit more about who your customers actually are, how
Yes.
many they are, where they are, like what are we dealing with here?
Definitely. So we scaled to already over 120, 130 facilities already, and scaling much more. We signed some really big contracts last year, and it's definitely a very, very exciting time right now. We started off, Annie and I, we didn't know much, and all we knew were like the big brands. So we started with enterprise sales. We sold to like the top, Fortune 50, Fortune 100 manufacturing companies, and a lot of food and beverage companies, like Unilever, AB InBev, Coca-Cola, Known, PepsiCo. Those are all organizations we're deployed with, scaling with, and have like global scale-ups with. And so we had to quickly learn how to do enterprise sales. We also had to learn how to do enterprise like procurement negotiations, all these types of things. But now we're actually tackling a lot of mid-market, and it's definitely very exciting to see kind of that grow, and we're growing our sales team. No, I think the learnings we had along the way really helped us be able to get to where we are today.
What about you, Eric, in terms of your customers? Who are they, the details of it, and maybe any tips on acquiring them as well?
Yeah, so we started Glimpse 3 years ago, and we all came from the battery industry. So 2 of us were at Tesla, where we spent about 4 years working in Tesla's battery organization. And so that's where we started, and I think it gave us a bit of an unfair advantage, because we built the technology that we wished we had in our previous life. And so that allowed us to also leverage our existing network, because it's a small world, and once you start knowing a couple dozen people in the industry, then you kind of know everybody within second degree type of network. And so we probably had an easier time understanding where to go and who to talk to than the average startup, just because we were in the industry for so many years. So to answer your question directly, our customers, we have about 70 customers today. We can't talk about most of them. We are allowed to share a couple names. So Lucid Motors in California is a customer of ours. So they source a lot of batteries for their car. NASA is a customer. They use a lot of batteries for spaceships and other types of systems, similar systems. Archer Aviation, so they are a electric vehicle takeoff landing startups in California as well, customer of ours. So typically we serve 2 types of customers today: the producers of battery cells. So without mentioning specific customers' name, names that you might know of are LG, Samsung, Panasonic, CATL in China, Tesla in the US, and then buyers of battery cells. So any battery-powered product around you, they are made by companies that are potential customers of Glimpse, right? So your smartphones has a battery, your AirPods have batteries, your car has batteries, vacuum cleaner, and so on. And so these are the 2 customers that we target. For the producers, this is very, very similar to what you guys do, which is inline quality control, sometimes at-line quality control, which means on the factory floor, but not really inline, where you do things on a sampling basis. And then for the buyers is more of a incoming quality control, failure analysis type use case, where you source a lot of batteries. These are black boxes that tend to explode if they're not well built, and so you kind of want to check the quality, look inside, make sure you're keeping your supplier accountable. So these are our 2 customers. We are going through a transition this year where we're expanding our technology to other industries beyond batteries. And so I gave a bit of a more general introduction of Glimpse because we were starting to expand in the aerospace industries, medical device, consumer electronics, and less about batteries and more about just generally speaking assembly type products that are made of multiple parts, components. Some are powders, some are metal parts and so on, and you want to check the conformity and the build quality.
Wonderful, thank you. You actually said something that made me think of a post that you had recently on LinkedIn, which was this difference between sharing your insights and keeping a competitive advantage, so also like some things that are confidential versus not confidential. So I'd like to turn it back to you and see where that post came from. Why is that something you wanted to address to your peers, to your colleagues? How did they respond? Did you hear any insights from them?
Great question, great question. The thing about this is like, because we're on the cutting edge, there's a lot of insights that we learn from both, so there's both technology, like technical moats that we have, and there's also a lot of just insight moats that we have, because we have such deep understanding of our customers. Now I've gone to hundreds of thousands of factories already, and so I talked to a lot of shop floor workers, knowing where to look at and the direction to look at. I think those are also a lot of insights. And so I think a lot because we are at a stage where we have product market fit, we have exciting customers, and we're scaling a lot, and thinking about how we tell our story, what do we want to share and what do we not want to share, and what do we want to keep to ourselves. I think those are things that we think a lot about inside the space, and how do we continue to maintain our moat. So that's like a little bit of the background about the post, and it's, I think, something a lot of like technical founders think a lot about, but I think also so much about startups is just the speed of iteration, and like a huge part of your moat is also just how fast you can move and how fast you can continue to iterate and develop and innovate. And so those are all things that I think very deeply about, and still continue to grapple. I still don't have a good answer on it, and so that's why I made the post to kind of hear what people are thinking in their minds.
Eric, does that resonate with you as well?
Yeah, mostly I would say in general, we should be aware of what the competition is doing, but I think people tend to be overly concerned about competition. I think if this sort of, everything is a spectrum, but so if you had to bucket competition, there's like the big, large company incumbent that's been there for a while, and supposedly, if you raise venture funds and you're a tech startup, you're doing something somewhat innovative, right? So you're doing somewhat something different. You're sort of have a new angle to address things, or you're coming up with a new technology. And so thinking that sort of the incumbent might care about you when you're like a 3-people startup or even a 20-people startup, and have revenues in the range of a few millions or even a few tens of millions. For those large companies, it doesn't really move the needle for them. Coupled with the fact that they're probably 100x slower than you, makes it so that they're not very. I'm not too worried about them just because they're so small, so slow, and so the speed of iteration, that sort of natural startup type thing, is a good thing. As you start scaling and gaining more market share and surface area in the market, then I think that changes a bit, right? And so you don't want to be naive as well. And then the other bucket of competition is other startups. Some might be bigger than you, some might be smaller than you. I think I've heard something, and I'm not going to give credit to whoever said this, because I think someone famous must have written this at some point, but like never in the history of startups has one startup killed another, right? Startups die because they run out of money, because they work on the wrong thing, not because of competition from other startups. Again, that becomes not true, a few years in, once you start expanding your sort of customer base and footprint. But at our stage, I think we should be mostly open. We should be careful and not stupid about sharing everything, but we should lean towards sharing our insights, sharing our journey, sharing the success that we have, because I think the successes are gonna bring more successes just because this sort of halo effect where, oh, startups is being successful, maybe I should look into them as a customer, right? So I think people have too much biases for being closed and being worried about competition, and I think at our stage it's mostly overblown and overthought.
I do have some thoughts as well. I 100% agree with the fact that I think, especially in the early stages, sharing, because you don't have much, like we haven't developed much. I think oversharing is definitely the way to go. And I also, the people I learned the most from is also other startup founders and also other startup founders in our space, and we share very openly. I think it's once you start to get to a phase where you have that scale, and then before like people that don't really pay attention to you are actively paying attention to you, and like that's when like we start thinking a little bit more about competition. And of course, we're not naive in this sense. Like I think we are very collaborative, but also, of course, if you start a company, you are competitive in nature, and we are very competitive in this sense. And so, like, I do think a lot about like how do we win. Like we're here to build something big, and how to win the whole industry, and how it's the fastest way, and how do we scale the fastest way in both like and how do we build the right partnerships to be able to allow us to kind of win this whole space.
I'd just like you to address, when you say share, how? On what platform? What works? Maybe we'll start with you again.
Yeah, when I say share, I'm not a big LinkedIn guy. I have my occasional posts when I feel like I have to. What I mostly mean is like, in meetings with, or in trade shows with competitors or potential competitors, we're trying to be pretty open. Again, I think our biggest motives are execution speed, and even if you spend an hour with us in a meeting, we're not gonna transfer that execution speed to you. So I guess that's what I mean is companies that you interact with or bump against in your industries. These are the right forum to share more, and then if you're big on social media, I think that's fine as well. Yeah.
And how about like stage presence, or there's a handful of publications on your guys' page as well. You're very, very active on the scientific publication phase. How do you rank all of that? Why do you choose what you choose?
Yeah, that's a good question, and that's credit goes to my co-founder and CTO, Peter, who comes from a very academic background. He's done his PhD at Stanford, done a lot of research on batteries, and we thought this would be a way to assert our credibility as a startup, to do a lot of R&D in partnership with academic labs and publish a lot of papers. And we've started that from day one. Now we have maybe a dozen papers out there. And when customers ask us, well, why your technology matter, or why you're helping me to solve that problem, we can pull those papers up in meetings and say, well, this is a peer-reviewed paper that we did with Northeastern or Stanford or MIT that explains why this is important, why this matter. And we thought this is probably the highest leverage marketing, because it is a marketing activity that we could do at our stage. And I think just to be self-aware, as well as also because we're not marketing geniuses and we don't gravitate around sort of these activities. So this felt like a more comfortable marketing activity for us as engineers and nerds in the space.
David, what about from your side in terms of platform? You have different strategies. I see on your page a lot of like video LinkedIn clips, for lack of a better term.
Yes. So we started to build out our marketing team, our go-to-market team. We found that videos are very good, and it's for us, we are selling to enterprises, and so we have a very outbound strategy. We have sales teams who reach out to enterprises, and then having the marketing materials to support that is very helpful in speeding up the sales motion. We are also doing a lot of work with customer referenceability, so like we get testimonials from customers. We have a lot of customers who's able to be references for us, and then we're also working on filming videos within our customer facilities to be able to post them on our website, and those build a lot of credibility for us and continue to show kind of why we are the best inside the space and we're the most advanced in this space. Continue to build out that customer referenceability. So even like competitors, if competitors aren't getting in this space, they might try to copy what you're doing, but they don't have the customers and the testimonials. And like every day, you were able to showcase how new facilities are coming online with our technology. And this is kind of our vision in terms of building our referenceability and reputation and growth on the marketing side.
We should do more of that. I guess, do you guys have dedicated people, or how do you find the time?
I think when we first got started, our marketing was not that strong. We were very much of an outbound motion. We build like sales collateral, but then now we're starting to, like we have someone, like people focused on marketing who's working on marketing content and videos, and we also started a podcast and starting to working on inviting our customers onto these podcasts to talk about their experience, their viewpoints of the industry. So those are all ways that you can share more about your technology and also share your insights to the world, and also builds that extra layer of credibility.
Do you think it helps with finding, like in the hiring phase as well?
So on the hiring, I think one of my goals for Laminar is to make Laminar the place to be at by the end of the year within Boston. That's one of my goals in terms of hiring. We are growing tremendously. We have like 10 plus roles open right now. We are a team of 40, hiring from everything from the engineering side, from like software, back end, front end, machine learning, to hardware reliability, to deployments people, to operations, supply chain. We're hiring our recruiter, so we're hiring someone to hire people right now within our company. So looking for people who are just love meeting really talented folks here in Harvard, MIT, BU, Northeastern, Tufts, Olin. So being able to retain talent here in Boston, I think that's definitely a topic that we're thinking very deeply about. Hiring for biz development, salespeople, like we have a huge pipeline. Literally, if you are interested in business development and sales and you want to make a ton of money, like you should work at Laminar, because we have such a huge pipeline and we have so many customers that we need to funnel and close this pipeline. So hiring a lot of people on the sales side as well.
Perfect pitch. How about from you, Eric, in terms of the hiring front? You're also looking, I believe, for some positions, or you were recently. What's your strategy? Who are you looking for? What do you look for when you are hiring?
That's a lot of questions. So yeah, we were looking for, we had 5 recs. We closed 3 actually. So it was we had 6 recs, we closed 3. So very happy about the people that we brought in. So we're still looking for MLOps and cloud engineer, and then an edge infrastructure engineer. So if you like to work close to the metal and write code close to the metal, and then a marketing lead as well, just to do a little more of what you suggested. Our strategy has been actually to try and hire a couple key folks per quarter. We're trying to maintain like a gap of how many people we wish we had versus how many people we absolutely need. And I think it's a healthy tension to have, because as soon as you hire someone, you know exactly what they're going to do. It also helps you be very specific when you pitch the role to someone, because you're doing their job at that exact moment in general. And it also helps you not overhire, which I think is very destructive in startup, because obviously you burn more money than you should, but also you have people that might be distracting in the organization that are looking for things to do, and that can be very destructive. So hiring a couple folks right now, but again, we're not trying to have a hockey stick type hiring phase, which is neither a good thing nor a bad thing. It's kind of where we are as a company.
Perfect, thank you. I think we're slowly coming out of time, or running out of time, but I do want to circle back to the second topic of importance that you mentioned in the beginning when I asked 2 topics that would be helpful. And you spoke a little bit, I would say almost like in the direction of mental health, in the highs and the lows, to make sure you can stay steady. And I want to make sure to bring this up. This is a topic that comes up really frequently in our own lab as well. We recently started a webinar specifically on founder resilience, on well-being, on what founders can do, because it's a quick process where you can explain better than I can. all the changes that happen and how quickly they happen. So I would love to hear from both of you individually what you do to help stay balanced, stay consistent on even just a personal level, because maybe it's some tips and takeaways for our audience and for the students in here as well.
I'd say definitely like a founding journey. It is a marathon. There's a lot of resilience and a lot of actually like through my founding journey, there's so many highs and lows, and there were so many things that people told us were impossible, that what we're doing was impossible or can't be done. But we were able to, like, first principles-wise, it made sense, and we believed in ourselves, we were able to get it done. So I think through this process, we actually also built a lot of confidence in ourselves. And why I love this job is that, like, every year, what my belief is possible continues to grow every year. And, like, this self-limiting beliefs that we keep shattering that, and, like, there are no self-limiting beliefs inside our organization. So that's why I love so much about being a founder. And being to continue to grow every single year. But just like you said, there's like so many ups and downs, and a lot of the times you can't really share the downs, because like you can't share the downs with your team, and you had to work through it, and then like figure something out, and then get the organization to continue to grow and move and make sure like things are able to be run and build the steady machine. So what I like. The thing for me is like I love talking with other founders, because like we know I live in also a hacker house with other founders as well here in Boston. So I think it's a lot of fun kind of share some of these thoughts with other people who kind of understand and have like the same mentality as me.
So it sounds like the network is really what was important for you.
Totally.
Okay.
Yeah, I'll give you two answers. First one is very obvious and probably a little boring, but health. For me, if I sleep well and I work out at least a few times a week, that helps me stay sane. Probably pretty obvious for everyone. Talking to founders as well, super important. Sort of go out of your way and meet other co-founders or founders in the space or in different spaces, by the way. Some who are maybe a couple years ahead of you, generally super helpful. And then I kind of want to react on some of the things you mentioned, which is around optimism, right? And one thing that I've noticed and learned is there's almost like a cardinal sin as a tech startup founder is to underestimate two things. The first one is the market that you're going to create for yourself, because you're working on something innovative, and so you come up with a new service, a new solution, a new product, and you're addressing a pain point that hasn't been addressed or not nearly as well as what you're doing with your product. And so by definition, you're gonna create your market and be the best one at that market because no one else is doing it. And I think we all, or at least I tend to underestimate the power that creating a market is. And then you self-limit yourself, right? So that's one thing. And the other, which is sort of a very similar idea, but around the technology side, is underestimate the rate of progression of technology, right? So as a tech founder, you're riding a big wave, and that wave is technology. And the rate of technology improvement keeps increasing every year, regardless of which field you're working on. And so you never want to underestimate where the technology is going to be in 6 months, because you're riding that wave is going to lift you up. And I think if you're not actively trying to integrate that information, you're also going to limit yourself in your plans, in the thing you'll be able to achieve. So underestimating the rate of progression of technology and underestimating the market that you're going to create for yourself by bringing technology to market, I think are probably affecting your mental health more than you think as an early stage founder.
Definitely. I think echoing all the points that you talked about as well. And there are many tough parts about being a founder, but then being able to create a team, being able to create the market, seeing the impact that you have is extremely, extremely rewarding. And talking with customers and seeing how excited customers are and able to play a role within the industry, I think there's a lot of good that being a founder, you can kind of achieve. And like literally also our employees, like hiring people, changing people's lives, seeing them develop, seeing them grow. Like honestly, a lot of the roles here in my company, if I apply to them today, like, or if I applied to that role when I was gonna graduate it, I would not be able to get in my company. Like I would not be hired, honestly. So no, it's definitely amazing to like see the colleagues that I have and see the people that we've brought on and see them grow over time as well.
Thank you both. Thank you for being so open in your answers. In the audience, do we have any questions for our two speakers here today?
Cheers. Thank you guys very much for your time and sharing some pros of wisdom on the panel. I run a pretty deep tech, like technical startup, and one of the big aspects that we're having to juggle is sort of contact with our advisors. I was kind of curious from both of your perspectives how you manage those relationships, how you develop them, and how often you're really, meeting with the core advisors that sort of help you get through those milestones and hurdles.
Great question. Great question. I think we were very fortunate early on. Our first like institutional investor, extremely founder friendly, and was both an investor but also an advisor and mentor for my sister and I, my co-founder and I, and like helped teach us a lot about fundraising, about hiring, and we would kind of troubleshoot and brainstorm ideas with him and game plan and strategize a lot of decisions. I think our best advisors, like our best investors, we were able to go to them when challenges occur, and like they would help work through some of the most difficult things with us and people that you trust. So, and it's with founding a company and talking with investors, it's always kind of an investor and founder relationships. It's kind of like tricky because you're like, what do you share, what do you not share, and because you also care about the like follow-up funding and things like this. So it's definitely something that founders do think a lot about, and finding kind of advisors that you really trust are definitely kind of a deep privilege, I would say. I think also a lot about this is like being passionate and going out there and going back to like one of the things I talked about earlier. I think what Annie and I did really well was that like we were just very passionate about this industry, and if we want to learn something quickly, the number one way to learn something quickly is just find out all the people who are the top in this industry and just talk to them and ask them the questions. And like that's how I utilize a lot of advisors, and like especially young people, our brains are so plastic, we're able to learn so quickly. Like we can have a few conversations, we can suck so much, and like if you're very intentional, you're good at asking questions, you can learn so much over a series of conversations. Yeah.
Thanks so much. Follow-up question about hiring. I'm curious kind of how you navigated in your earlier stages where you were either maybe hiring for technical skills or kind of jack of all trades, people who could help fill in the gaps. Can you talk a little bit more about how maybe you transitioned from like earlier stages of hiring and now where you're at, where it seems like at least you're growing a little bit faster and with more specialized roles?
Yeah, I think it's really hard to hire in the beginning, really hard, because no one knows about you, no one knows about your startup, and you're probably not really good at explaining what you do as a startup. And so hiring in the beginning felt very hard, and you certainly don't want to outsource it. You want to do it yourself, and you want to send the emails, you want to DM people on LinkedIn yourself, and you want to iterate. So finding your first few hires is just as hard as finding your first few customers. As you sort of progress, and by the way, you want to keep a very high bar for your first few hires, and I'm probably stating the obvious, but they're going to drive the culture of your company. They're going to bring folks that are like them, and so if they're good, they're going to bring really good folks, and vice versa. And so took us 6 months to find our first hire, and then 3 to 4 months to find our next couple of hires after that. It gets easier as your footprint in the market increases, as you have a bigger presence, and I think I haven't noticed sort of a step function in how we hire people. It's gotten a little easier, but it still takes us a lot of time, and the bar is still very high, and we still spend hours and hours discussing a candidate before we bring them in. But as you build processes and structures and especially the sort of the top of the funnel, you can outsource more easily at the beginning because it's just about bringing candidates in and hiring the first phone screen, which is very standard questions. Are you in the area? Are you willing to work from the office? What is your compensation expectation? All those questions, you kind of want to get them out of the way early, and you can outsource it. But the sort of past this first stage, it still feels like the early days where we have a high bar for candidates, and it takes a lot of time to find the right fit. And you don't want to lower your bar. I don't know. It's my first startup, and so I don't know exactly when you become big enough so that you just need bodies and you have to lower your bar because you're just a bigger company. But I can tell you, it's not 20 people is not when you start lowering your bar. And maybe you guys, no, you probably haven't reached that stage. But I mean, at the end of the day, it's all about people, and the people you bring in are the most important thing you can do as a business.
Totally, 100% agree. I had a few thoughts on this. In terms of, I think, early stages. We started to implement this now, but honestly, if we were back in the early stages, we implement this will work really well as well, is like this idea of work trials. We started to implement work trials. This is something that a lot of startups are starting to do. Basically invite someone over. It's a way to expedite the process and also get more confidence of hiring a person, is you bring them into the office for a few days, like you pay for them for their work, pay for their travel and housing, or for like a week, and have them work with you, work on projects, and then you can really get to see how well do you work with each other, how well do you discuss ideas or problems with each other, and those are like ways to expedite the hiring process that we're starting to implement. I have some other thoughts. Oh yeah, I think one thing that is really, really important is just hiring people who care very deeply about the company. I think if you care, then you're going to put in that extra effort. If you care about doing a good job, you care about your colleagues, you care about the success of the organization, then people go above and beyond. And you don't want, I would always hire someone who cares about the company, and then someone who I guess is technically strong but does not care as much. So that's my 2 cents.
Perfect, thank you. I also see our judges coming back in the audience a little bit, so maybe one final quick question. Actually, I'm going to make it 2 and just merge it and make 2 short answers. One being, what's next for you guys in your team? Just what's coming up next? And a one-liner of final advice, final takeaway for the team out here in the audience.
What's next is, it's a very easy answer for us this year because we are expanding beyond our initial beachhead market. So it's going to be, it's both exciting and it's going to be challenging because our messaging, our network, the customers we've been serving, everything we know and have built for is for one industry. And so we now have this challenge of expanding to 20 other industries. So that's a big focus for this year, both technologically and commercially. And then what was your second question?
Advice for just a one-liner, summary advice, one takeaway for the teams.
It's worth a try. Whatever you're thinking about, it's probably worth a try.
Totally. I think for us, key things this year, we already know we have the best technology inside the industry that we're working in or the use case that we're focused on, and we also are the most scaled in terms of this application. So really win this industry this year or become the biggest player, or we're already the biggest player, but scale this even more. We're also looking at new industries we're diving into as well. But I think the ask for help from my side to this audience is we're growing tremendously. We're hiring and a lot of folks who like top talent, and we want to continue to increase the talent density of our organization. So if people know very smart individuals who are passionate about startups, we'll love to connect and chat. And you can also visit our website, runlaminar.com. You go to our careers page. You can see all the roles that we have open. And then advice, I would say. Advice is no self-limiting beliefs. You got to believe in yourself, and if you believe in what you're doing and the first principles make sense, then go and try go try it out and like talk to customers. And you never know. Like when we first started, we were just an idea, but now we're here. And so life takes you in like wonderful journeys and wonderful ways.
Wonderful. Thank you both so very much for sharing your time with us. I'll pass it back to the MIT team at this point. Thank you.
Should we leave those here?
Thank you. Good timing. As we do a show of hands, would you guys like a 5-10 minute coffee break before we announce, or should we just go? Okay, let's go straight into it. That's what we figured. Maybe give us like 2 minutes to figure out the tech. 1 second. This needs to not be here.
I also think we should bring Georgina.
Is she here?
Yeah, she's the woman in the hat.
And so what? We don't, okay.
Hmm?
Why?
Because we got this room for free.
Yeah, but she
apartment. And she's a former MD.
But she was
Hmm? No, I just mean bring her up here for the check. Just to help give the we brought logs. Yeah.
We need to get this. It's great. So we're gonna have them all like. We're gonna have them all. Why do we need them to be like? I guess it's. Yeah, they belong. Okay. Sorry, we're taking an accidental 5-minute coffee break, so you guys can grab coffee if you want. We'll be back in 5. So after inviting up the new MPs, I also then invite up Georgina.
I think it's
Okay.
we are losing this one.
I know. Well, I mean, because they were paired.
Okay. The tape lines, just make sure, the only reason we put that up is because it will hit the top of their head. If you stand in the middle of the stage, the light will hit their head.
Oh.
That's why we had put it up for the panel and for this part.
Okay.
Yeah. But, I mean, as long as they don't stand in between that tape.
Oh, they don't. They shouldn't stand.
They
Okay.
can't. Yeah.
They're probably going to if we're being
Which
honest, for
means
pictures.
if for pictures we should put this up. Why do you want this down?
Well, we have a screen. We have slides.
Oh.
Like that's how we're doing it.
Okay.
Yeah.
Okay.
We can retake the photos.
Okay.
Yeah.
We can, at the
We
end.
can take them at the end.
At the end, we'll put it up.
Yeah. Sounds good.
Thank you, Kelly.
Okay, I think we are ready if you want to start wandering back in. Thank you all so much for being here today, for traveling from quite far away to be here with us, and for all of your hard work that you've done over the past, not only this spring, but the many years that it's taken you to get here. We were really impressed, and the judges were really impressed. It was a tough deliberation. Want to thank again, once more, our sponsors. Really, we wouldn't be here without you. You're a key member of this ecosystem, and thank you so much for all of your continued support. So we're really thrilled to announce that this year's new MDs will be Zara, Kayla, and Akshat. So these are the people who will be leading the prize next year. You guys can come up. So as I said, this is a student-run prize entirely, and so the team turns over. But we are really thrilled with what our entire team has accomplished this year, and thank you in particular to our 3 new MDs. So be sure to catch them at the coffee break because they'll be running the show next year. And then we also wanted to invite up Georgina. Georgina is the CEO of Greentown Labs and is actually also a former MIT Climate and Energy Prize MD. So we're really happy to have her with us if you want to come up. So today we saw some amazing pitches from 12 of our finalists, and we are really excited to announce that the 2026 MIT CEP Grand Prize runner-up is Albon. Congratulations. A little awkward. A little bit. We'll take more pictures later. Okay.
Thank you so much.
Thank you, guys. Congratulations. And please stick around for pictures. We'll take a lot after. And we are thrilled to announce that the winner of the 2026 MIT Climate and Energy Prize is, drumroll, Cosine. Please come up. Congratulations. Okay. Thank you. Thank you so much for everyone who's here today, for our judges, to our sponsors, to the mentors, and to everyone else who's in the room supporting these startups, and to the startups themselves. We really appreciate you being here. So please stick around. We're going to do a quick round of photos in a couple different configurations. And thank you very much. Thank you. Good. If we could actually first get all the startups who were here today, so all the grand finalists, if you could just all come up here so we could get a photo of the full cohort. And judges and sponsors, if you can stick around for like 2 minutes, we're going to get you in some photos.
Oh, you're tall. Just go in the back.
Great. And then if we could have our runner-up Albon and our kilowatt sponsors and watt sponsors come up. Thank you. So all of our kilowatt sponsors, if you could also join us on the stage, please.